only be used by male because I still need to figure out how to make it usable for female. And not only that, it looks a little bit awkward. So when people see you, they can be thinking weird things like what is happening. So I plan on making it more fashionable too. For example, adding a few pockets inside, making it like a clothing or something. And so in the pocket, there will be a zipper where we can open and we can open the bottle lid. And I plan on making the container can store even more urine because 700 milliliters is about 6 to 7 times of urination for a kid that's in primary age. So he is around 6 to 12 years old. And that's for my presentation. Thank you so much.
Wow, very cool. So you came up with this basically as a problem that you were suffering from.
Yes.
Huh. So did you talk to anybody about it before you made the prototype, before you went any further with it?
Yes, I had an association with Kriya IT. They also helped me to design the product.
Oh, very cool. Very cool.
Thank you. Do you have questions?
Yeah.
Any questions?
Yeah, so I wanted to know, what else are you thinking about working on?
I am thinking of making it more fashionable and it can be usable for females too.
Right, but are you thinking about doing another idea? Do you have another invention in your head?
I plan on making like an assistant, so he can help you with with things you do, like carrying your stuff, and then you can also use it for reminding you to do things. So it's like a schedule robot.
Okay. I usually just that type of assistant for me was usually my sisters, my younger sisters. I just made them do all of it.
Yeah, it's a problem if we don't have any siblings.
That's
or if they kind of hate us, or if they're lazy.
Well, all of those things are true, but be careful if they're listening too. Are you the only inventor in your home?
Yes, my little brother spends the day watching television.
Okay, well, just keep inventing. Maybe you can get him excited and doing some cool stuff too.
Yeah, I hope so.
Brandon, do you have any advice for kids that are out there trying to create things or have an idea? What would you tell them to do?
From my honest opinion, try to start from yourself. For example, if you have a deficiency, you can start from that deficiency and create something that can help you solve that deficiency. Because that's where most inventors get their idea from.
I think that's a great idea, and we've noticed over the last 19 hours that a lot of people are creating things right now based on challenges that they're facing.
Yeah.
During this pandemic, so we appreciate your willingness to come and share your invention and also share why you had to come up with it. We appreciate that. I'm sure there's going to be people out there that are going to use this and be very grateful for it. So thank you very much.
I'm also grateful I can be here.
Well, we're glad you're here. Make sure that you apply for that student host challenge because we need some hosts in July. We have found out that we're old and we need extra help because it's a long day.
Yeah.
All right. Well, thank you very much, Brandon.
Yeah. Thank you. Thank you too.
Carmine, our next panelist is already here, and I have promoted him to panelist from attendee. And you want to go ahead and introduce this fella? This is Axel Joey.
I do. Axel, what's happening, my friend? You made it in. That's awesome. also from Indonesia, East Java. Awesome name. I love coffee, so that's great. You probably hear that a lot. And you also have an invention called the Deli Food Dry Bot, a robot that can deliver food at the restaurant. Very cool idea. Very cool idea. Axel, do you have a presentation or an invention to show us on the camera?
Yeah. No, I mean, I have the prototype here.
Okay.
Oh, cool. Okay, great. Yeah, introduce yourself and go ahead and get started.
Okay. Hi, I'm Axel, and I'm from Indonesia. I'm 15 years old, and I'm an inventor. So, according to research, a customer wait for a food in a restaurant is between 23 until 30 minutes. And for me, the time is very long. One of the problem is some waiters got some miscommunication with others. So I created this robot, as you can see, it's beside me.
Ah, okay.
Yeah. This robot is named the Refugee robot. Why I make this name? Because this robot is functionable for delivering food from the kitchen to the customer's table. And it's also controlled by the waiters. So this robot is shaped like a car because I made this shape like a car so it can move easily. And it's also made up by acrylic. The reason I made this robot up with this material because it's light, it's clear, and it's safe, and it's also strong. So this robot can carry 2 glasses and 1 plate for 1 delivered. So these are the components. As you can see here, these are the 4 wheels. And these are the 4 motors, the yellow one. And 4 of these motors are connected to one main motor. It's here, this one, as you can see here. And this is also the Arduino board. The function of the Arduino board is to connect one board to another. For example, I use this board to connect the motor board, and then I connect it to the Arduino board, and then I connect it to the main board, which is ESP32 here. This board is like the brain, and it has a camera. The function of the camera is so you can control this robot from a long range. So to set this robot, first you need to set the wire first. As you can see, this is a lot of wire connecting one to each other. After you done that, you can do the program, as you can see here. I use the Arduino IDE program. And then this is the for program which I made it on the last October of 2019. And you do upload it, but I've done uploading it. So the next step is you should get the IP address. To get the IP address, you need to open the tools. Oh, before that, the function of the IP address is to control this robot by your phone. So open serial monitor. And then you go to the ESP port, as you can see here, and unplug one of the cable. And then you click the reset button. Then it will appear like this. But sadly, for now, my Wi-Fi is on a trouble, so I can control the robot with the IP address. So let me show you what will appear if I can access the IP address. It will appear like this. You open the internet, you enter the IP address, and it will appear like this. This is for so the robot can go forward. This will go toward the right. This will go backward, and then this will go toward the left. So in the future, I will make this robot bigger, and I will make this robot from a solar system power. Thank you. Is there any question?
Wow. Really cool.
Thank you.
So Yeah, we're gonna have some questions. Go ahead, Daisy. I know you had a few.
Yeah, so how long have you been working with robots and this programming and coding?
I've made this robot on the last October of 2019.
But is this your first robot or have you been playing around with this idea for a while?
On December 2018, I've studying about programming. And on that day, I learned a lot about programming.
Yeah, well, you absolutely did. That's less than 2 years, so good for you.
Yeah.
Yeah. Do you play that guitar that's behind you?
Yeah, sometime. When
So do
I'm
I.
get
We're
bored.
gonna have to start a band together.
Oh no.
Sure.
Axel, she's gonna have about 20 band members by the time this is over. Hey Axel, how long have you been working on this one project?
I've done this project since the October of 2019. So I guess it's about 6 until 7 months.
Wow. And if we could help you with something, what would you need to move it to the next step?
I'm going to make this robot bigger. So I need more power from the power source.
More power.
Axel, what language did you program it in?
In English here.
No.
In the
What computer language? You're programming it in the Arduino.
Yeah, in the Arduino IDE.
Oh, okay.
So
What is it?
Axel, one of your, I don't know if it's a classmate or a teacher says that you're also a great violinist.
Yeah, that's right.
I love that. I think that when you're a musician, I'm also a musician, that musicians and scientists sort of share the same type of brain. We're kind of programmed that way, that we're good scientists and we can also be great musicians. So who is Liza?
I'm sorry?
Who is Liza?
Oh, it's my teacher.
Okay, so she's talking about you now, saying you're a great violinist. Maybe next time you can come on and play your violin and talk about the science behind it.
Yeah, sure.
Axel, when you said you wanted to make your robot bigger, what kind of parts would you use? Would you just use the same shape and make it bigger, or would you use a different shape?
I will make it bigger, like it's shaped like a car, but it's bigger, so it can deliver more foods. It can carry up to, I hope I can carry up to 5 until 10 plates in a time.
Axel, we have a question from YouTube. They're asking you, what kind of kits did you use? Or did you build it from scratch?
I used the Arduino IDE in a program.
Okay.
That's cool.
And also
Hey.
I use the Arduino board.
Hey Axel, and you might have explained this or I missed it. Is the robot is going to work autonomously, kind of like drive itself in a program, or is it going to have to be driven remotely by someone?
It must be driven by a program, by a person. So it only needs the IP address. You can enter the IP address on the internet, and then you can get the control.
Oh wow!
From your phone or either your computer.
Awesome, that's cool.
Thank you.
I know Daisha's going to ask you what you want to do when you get older.
I am.
Yeah,
What's next?
I think I'm going to make this and sell it to the restaurant.
You're going to do what?
I'm going to make this robot bigger and going to sell it to the restaurant.
Okay. All right.
Yeah,
and
going to sell my.
When you finish school, what are you thinking of? What's next for you?
I'm not sure yet.
That's okay. I'm almost I'm almost glad to hear that. Just keep your options open. You're still learning a lot of stuff now, so that's pretty exciting.
Yeah.
Axel, how did you learn to wire the Arduino? To add the,
I'm sorry.
How did you learn to wire the circuitry for the Arduino?
Oh, it's I look on the internet and I try some stuffs like doing some experiments.
What would be the next thing you think you need to learn to make your robot even better?
I think I'll change this battery power source to a solar system power source. So it's more eco-friendly.
Oh, nice.
Yeah.
I like that. Well, Axel, thank you very much for sharing your invention. Thanks for also sending us the inventor video a couple weeks ago. We've been putting that out there on the internet and people really liked it. We hope that you will keep inventing and keep failing if you need to, because that just makes you even better. And we hope to see you on a future show.
Thank you.
And Axel, when this appears at a restaurant, let us know so we can go and eat there, because I want to see it.
Okay, sure. I'll let you know.
Thank you.
Thank you.
Well, Carmine, I'm going to share my screen again because you know what time it is.
That's awesome.
It is STEAM Career Challenge, because if Axel can build an amazing car, there's got to be things we can do too. So this, I took us out of there. Let's try that again. I think the tiredness is coming through. I can't grab that. There we go. So this is our amusement park challenge. Let's see what's going to happen. Dr. Drizzle here with another challenge. This is the Amusement Park Engineering Challenge. You know, having great infrastructure around where you live is important. And it doesn't just have to be hospitals and libraries and schools. Sometimes it just needs to be places that are fun. So imagine that you have been contracted out by a large amusement park company. They want you to build a new amusement park designed on a theme of your neighborhood, town, city, or state. You're going to build all of the rides that are in it. You're going to learn about simple machines. And then you're going to pitch your idea in a 30-second promotional video. Now, make sure that everything you build is to scale. We don't want anything really, really big. So come on, an amusement park named after you? Hashtag Global Innovation Field Trip. You can do this. Start building. I just love my STEM career challenges. They are so good. Teresa, are you online? There she is. Carmine, if you don't mind, I'd love to introduce Teresa, because let me tell you about Teresa. She loves biology, reading, playing the piano, and ballroom dancing. That is my kind of girl. She is well-rounded. She is a singing, dancing biologist. That is exactly up my line. She also wants to invent things that will help other people. So, Teresa, why don't you introduce yourself? Tell us where you live, how old you are, and then share your invention with us.
Okay. Hello. My name is Azarel and I'm an inventor from Indonesia. Today, I'm going to explain about multi-leg machine. So I make this machine because I used to forget to feeding and bathing my hedgehog. And then I decided to make this machine. So this is my prototype. So this is you see the yellow box. So this is the first part. So the first part with the green button is used to keep the food pellets and transfer the food pellets to the container where the hedgehog lives. So if you press it, The food pellets will get out from this part of the machine. Then this is the second part. The second part is used to keep the sawdust and to transfer the sawdust to the container where the hedgehog lives to. The sawdust is used to keep the container where the hedgehog lives dry from the urine of the hedgehog. Then this is the third part. The third part with the blue button is used to keep water and to transfer water from the small hose. So if you press the button, you should press it until full, then the water will transfer to the hedgehog's drinking bottle through this small hose. Then this is the fourth part of the machine. So it used to keep soap for the hedgehog to leave to bath, and if you this machine can automatically bath the hedgehog. So first thing first, you should put the hedgehog inside this bathtub. Then you should press the blue button until the water tower is full. After that, you should press the black button, and then you press the purple button, and it will automatically bath the hedgehog. The soap will get out from this brush, and it will bath my hedgehog. I'm convinced that in the future, this machine will be useful for others, and for me, this machine is pretty useful. Thank you. Any questions?
Yes, where is your hedgehog?
Oh, my hedgehog is in the container. Do you want to see it?
Yes. I cannot tell you how excited I am that I'm getting ready to see a hedgehog on our global innovation virtual field trip. I mean, my day has been completely made.
How did you know she had a hedgehog? Are you psychic or something?
Because it says that's what the product's for, to bathe hedgehogs.
Yeah,
Come
but
on,
who
Carmine.
knows that somebody has a hedgehog in their house?
She said it was her pet.
I thought it was like a stuffed animal.
No.
By the way, I've just been told all of her teachers are in their offices watching this whole thing.
Nice.
So on YouTube, it may say one person, but it's actually a room full of people.
Yeah, so let me, we have about 20 people watching right now.
So this is my hedgehog.
Ah! And what's her name or his name?
Spiky.
Spiky. And how long have you had Hedgehog?
Excuse me?
How long have you had your hedgehog?
If I'm not mistaken, 3 months.
Okay. Well, Julie wants to know, how often do you have to bathe a hedgehog?
A week once. Once a week.
Once a week?
Yes.
That's just very, very cool. Carmine didn't believe that you actually had a hedgehog.
I didn't say I didn't believe it. I just never met somebody that had a hedgehog. I thought it was a game.
Teresa, we don't have hedgehogs normally as a pet here in the United States, but we do have other animals. Like I had a guinea pig when I was a child, and many people have other things. Could this device be used for other animals besides a hedgehog?
Yes. Yes, as long as it's not very big, but yeah, medium sized like the hedgehog.
Does your hedgehog like to be bathed?
Yes. They can swim, not intentionally, but they can.
If they have to.
They have to. If not, they
Yeah.
will be smelly.
Teresa, I was told that your teachers are watching this and watching you. They are. So, are there any favorite teachers that you would like to say hello to?
Don't do it.
Only if you can name all of them, Teresa.
Yeah, don't pick a
Very
favorite
careful.
teacher.
Oh,
Say
I
there.
don't know who watch.
Hedgehog. That is funny.
Well, not
Hey,
only are your teachers watching you, but Teresa, people from all over the world are watching you right now.
Okay. Hi,
Isn't
Miss
that-
Linda.
So what's the next thing you need for your hedgehog invention?
For my hedgehog invention, I think I will need woods, metal, small hoses, and other things that not clear yet.
Is this idea, do you want to take this all the way to actually making it and selling it, or you have other ideas?
If someone wants to buy it, well, it's okay, but actually I made this because I used to, sometimes I can't bath my hedgehog because I have another schedule. For example, I have lesson for piano, dancing, and sometimes I don't have any time. So, yeah.
Poor hedgehog.
No, it's spiky. It's spiky.
But spiky.
All right, well, very good, Dacia. Anything else, or are we going to bring on the next guest?
But we're going to wait just a moment for the next guest, but just wanted to thank you, Teresa, and we can't wait to see what your next invention is. If we see you in a couple of months and you have something that is bathing your next pet, which is maybe an alligator or a black bear, please let us know because we'd like to see that happen too.
Oh, okay.
All right.
Thank
very
you.
good. Thank you.
That was so great. Love that invention. I like your hedgehog's name too.
Oh,
They used
thank
to-
you.
They call me Spike.
So we do have our next person online. This is Roxaline or Roxaline. I hope I'm saying that right. And she describes herself as a pretty normal high school inventor. I don't even know what that means, a pretty normal high school inventor. Let me change this notification right here so we can see if we can get Roxaline online. So I've got your video on. Roxaline, if you want to see if you can come on out.
I cannot start the video. I don't know why.
I am trying to do that for you right here. I'm doing it right now. See if it lets you do it now.
Oh, okay, this is weird. It said select another video camera in settings. Let me try something. It's my only camera, so I don't know why it's on.
So sometimes in your settings, you have to allow outside programs to turn on your camera.
The last Zoom meeting I used, it's fine. So I don't know. The last time I used Zoom, it's fine.
Okay, well, it says right now, let me try it one more time. Well.
Oh, I'm not sure. It said in the settings, but the last time I used Zoom, the video is fine.
Okay. Well, Roxaline, how about you just talk us through your invention? I know you probably have a presentation, but maybe we can use that on the next field trip. Can you tell us a little bit about your invention?
Well, my invention is about the gastric well.
Okay.
And the gastric well is something that I made to help solve water problems in my city.
Okay, keep going. Can you tell us a little bit more?
Okay, so I get this idea when I was in my friend's house and we were doing the English assignment. And her house is located in the middle of Yogyakarta city where I live. So when I was walking to her kitchen, downstairs to her kitchen, I noticed there is a very unpleasant smell coming from near her kitchen. So I thought it was either near her well or her waste watering treatment because I don't know which one is where. So after that, after I do the English assignment, I have a family dinner in a local pizzeria. And I think there is something magical about the pizza that after I ate that pizza for one whole night, I stayed in front of a very huge whiteboard that I have in my house. And I made the sketch of Oita. It stands for Omah Ijo Tresno Alam, and in Javanese it means the greenhouse that loves nature. And I still cannot start my video.
Okay, I am so sorry about that. Where are you in the process of this project? Have you built a prototype yet?
Yes, I have built a prototype. I think if I'm allowed to share screen, I hope it works.
Yeah, it's for some reason it's not letting you. Oh.
Okay.
If the camera doesn't work, I don't think it's going to let us see your screen.
Oh.
It might.
Okay.
Try to pick something to share.
Oh.
There you go.
Oh, we're in.
Oh, okay. So this is the prototype. This is the prototype now. It's a bit of a weird picture. Sorry about the motorbikes. So,
Okay.
So this is the gastric well. It's not only like that. Let me try to show you the whole one. That is like the whole picture of it. There. With the side of my head. Okay, so how the guest, so after I designed the Oita, actually, Wahyu, she's a lecturer in a university, and she asked me to teach in her class for one time. So Bu Wahyu asked me to teach in her class, and so I present about this Oita thing. And then after that, after my teaching session, we have a little bit of a talk. And she points out that actually the main point and the main component of Oita is actually the gastric well. So now every time we met, we've been always talking about the gastric well. So about the gastric well, okay, this is going to be a bit hard. The gastric well is wastewater treatment system. And this is the latest prototype of the gastric well. It's a bit weird, and also it has eight filters. The first three it uses the wires, like the chicken wires, from the widest to the smallest. And then after that, I leave some space, and the space is because after the wires, I put natural filters like the Scout Boy, like the Scout water purificator. So I know that it takes longer, so then I put space so that the dirt doesn't float. And then after it goes through the gastric well itself, there is going to be a coagulation chamber. There is a coagulation chamber, so that and then in the coagulation chamber we use the calor seed. I have a picture of the calor seed, I think. Oh, I don't have it. Okay, I'm sorry about that.
That's okay.
And this is the filters. That is the widest, the green one. And then there is the smallest, and there is one in the middle, so that's the smallest. And there is one in the middle like that. So I use three of them. And then after that, there is this one, the yeah, the one is the scout one is started with charcoal, and then people's are gravel, and then the sand, and then there is palm fiber.
Where did you
So-
get your filters?
What filters? The wire I get, the wire my father went to like a material shop, and the natural one, I live near the zoo, so the zoo like provides almost a lot of things.
Okay, very nice.
And this is the second prototype. So the first prototype is this one. Okay, so this is my first prototype. It's made out of bottleneck. And this one, I made it, I forgot when, but this one is when I was in my other teaching session in the university. So I have 2 teaching sessions. The first one is to explain about the OITA. And the second one, Ms. Wahyu asked me to help to make my prototype. So this is what I came up with. And this one, I tried to make the shape like a gastric well, but then after that, I start to think more about what is going to be in the filters and how is the filter going to work. So that's why if you see the shape of the second prototype, it's not like that much of a gastric. It's more like something else. So that's mostly about it.
So what do you need next? If we had an investor or someone out there that's watching this, what is your next step?
My next step is actually to fulfill my goal, which my goal is to wait, what was I going to, my goal is to make this the water after being filtered. I want the water to be as clean as Indonesian tap water, which in Indonesia the tap water is not drinkable yet. So I want it to be like fresh, clean water, so that it could be reused and reused again.
Very nice. So in your own home, and then for everyone else that lives in Indonesia.
Yeah, especially the ones, especially in Sumatra where my mom lives, the watering is a bit hard and the filters, it still stinks. So I wish this could help.
I definitely think it can. And I love the design. It's simple enough that someone could replicate that or create that themselves and actually, make that very marketable for everyone in Indonesia. Was that your idea to make it simple for people to maybe build their own?
I have not think like about how it's going to be marketed, if it's going to be a product, because for now I'm still focusing in improving this to the maximum, to what I think is maximum. So then after that, after I finish about my research, then I can think about the marketing and stuff. If like you want to talk about the marketing thingy, I don't know.
Yeah, well, I think that's very smart. I love that you're thinking about the research and you're really being intentional about your thoughts with this and not just throwing something out there without thinking about it.
Yeah, that's pretty much my goal.
I was very impressed from an inventing point of view that you talk about your first prototype and your second prototype. Many times, especially students will not want to admit that the first time they tried it, it didn't work. But can you talk about what is better about the second prototype? What did the second prototype improve on the first prototype?
So the second one is obviously it's larger because it's made of plastic jug, and also I start because the first prototype is the Scout one is not actually like the second one. So I start to like more deep more research about that part, and also the second prototype, the full prototype, like what I'm showing now. Like what I'm showing now is it already has like the whole picture, because I think I forgot to mention something that that part is I think is going that part, as far as I can remember, because I've not been talking about this for a long time. This part is going to be the coagulation chamber, and then this part there will be a UV tunnel. So the second prototype, which is more full version, I think that is the improvements. And it
So-
works better in the second prototype when I compare it to the first one.
So are you going to be making a third prototype?
Yeah, I'm going, after this pandemic is over, maybe I can talk to Bu Wahyu more often, because right now I'm stuck in the house.
Yeah, we have that problem too.
You know, one of the great parts about water filters is that on the shopping channels, HSN, QVC, they are one of the biggest sellers. So water filters
Oh.
are one of the biggest sellers, not only in retail, but also in the wholesale market. So, it's
I see.
a great great product to develop.
Yeah. Okay, I'll think more about that.
Are there filters, or are the elements going to be replaceable, or would the whole filter be disposable?
I think it's going to be. I think there will be like monthly or maybe like yearly replacement. But there is still on like my thoughts on how to improve this, because this is still a very raw one. When I get to talk to Bu Wahyu again, I mean like technically talking about this, I think I will ask her more about like how is this going, how do you think it's better to be like, is it how I'm going to talk more about the materials.
Okay, good, very good, great idea.
Thank
Do you have some idea of what this might cost? You talked about maybe everyone could have one in their home, but what would this cost? Do you have any idea?
Actually not yet, because like most because as I said, this is not the maximum version yet. So I'm thinking to calculate it when it's the maximum, because first of all, some of the like the material prices for the prototype that I have here is especially for like the charcoal in Indonesia, it's like it goes a bit weirdly. So I don't know, maybe I will think about it after like I get the maximum result that I want. Because from now I'm not sure if the prototype right now and how it works has satisfies me enough.
Very good. Very good.
Very
All
good.
right. Well, thank you so much. We really appreciate you working through the camera situation and coming on with us.
Yeah.
We can't wait to see what happens with this. We really appreciate it. Good luck.
Thank you.
Thank you. Well, we have just a few minutes before our next guest. Carmine, I would say that it's been an absolute pleasure to host with you in the wee hours of the morning. I have found out that I'm probably not a night owl. I'm giving you everything I have right now, but my derriere is so numb that I'm afraid if I stand up, I'm going to hit the floor. So I will turn off my camera before I do that.
No, don't do that.
But before we turn it back over, let me just share. I've already given Julie the host. She's asking for it again, but I have already done that. So we should be good. But I just wanted to share real quickly that we do have a lot of these global STEM challenges that you're going to find on our globalinnovationfieldtrip.org website. And they have all been tied in some way to the UN Sustainable Goals. So, for example, the Mount Everest one is goal number 13, which is all about climate action. I'm going to add a few more in here, but I was able to put a number. Can you see those? Julie, can you see these?
I can.
Okay, great. I just want to make sure. So please check these out. Teachers, we encourage you to share these with your students. Students, we would love for you to try and solve these, come up with some ideas, and then share those. Hashtag Global Innovation Field Trip. But we have just so many of these out there for you to try. We're home right now, and we can do some good work while we're at home, and these are mostly materials that you can use or can find from your house. So I am going to say thank you so much for having me host. I'll probably see you again at the end of this 6 hours, but I'm going to sign off for a little bit and turn it over to our capable hands of Julie and Jake. I just realized you're J and J. I didn't even notice that. You're J squared. And I guess since I love music so much, we'll be CD, Carmine, if that's all right. So thank you, Carmine. You're a wonderful co-host. Thanks for being with me. And Julie and Jake, have a wonderful next few hours, and we'll see you on the flip side.
Absolutely.
Thank you.
Thank you,
Hey,
Dacia.
Jake, before you
Yes.
get started, could you please make me co-host? When you move hosts around, you lose your host abilities. And so I gave you host, but I need to be a co-host so I can help you.
Make co-host.
Thank you.
I've either made you a co-host or turned you into a frog. I'm not sure which pushing
I was
buttons
already a
on it.
frog, so you must have been a...
Well, I see our next presenter is ready, but we're a little bit early. Can I show one of the little short videos, which I love? Dacia's not here. Hopefully, maybe she's listening, but I just love these things. These were all created. Let's see if I can get this to work. Is it filling up the screen? Now I don't know how to get it to work.
Not yet.
Yes, because I've lost. Okay, this is what happens when you push buttons. Okay, so here's what we're going to do. I can't find out how to get this thing to work. I'm going to have to push some buttons to do that. So we might as well start with our next presenter who is ready to go. And let me just unmute you. There we go. Okay, so this is Siddharth Doctor, and you are a professor of sustainable chemical and material engineering at Sheffield in United Kingdom.
Yes.
And he leads the Green Nanomaterials Research Group with a vision to develop sustainable routes to functional nanomaterials. He is an inventor, an educator, and a mentor. And the title of the presentation is Bio-Inspiration for Sustainability. As a former chemical engineer, I am looking forward to this presentation.
Thank you very much, Jake. Can you all hear me and see my screen?
I can hear, I don't see any screens.
So I've started sharing my screen.
I see your screen now, yes.
Okay. So is it okay to get going?
Sure.
Okay, so thank you very much for this opportunity. My name is Siddharth, and I'm based in Sheffield. If you want to know more about our group and our work, then please follow this link, which is svplab.com, or you can follow us on Twitter. And today's topic is how can we learn from biology to make things more sustainable? In a nutshell, if we so this is some pictures I've shown on the left-hand side are some microorganisms and how we learn from them in order to translate that into making sustainable methods, sustainable materials and processes for future. So let's get into that topic. The outline of what I'm going to present is a little bit of background about where I am based and the university. Then background about the technical aspects of today's presentation. Then I will present the problem that we and others are facing and provide a solution, which is through bioinspiration. I will briefly mention the key inventions that we have been working on and what potential impacts they can lead to, and we will summarize this. Given the wider backgrounds of our audience, I'm going to sometimes dive in deeper into the technical aspects, but very quickly come out into more layman aspects. So if you think it's too much technical, then just give me another minute and I'm definitely going to come back and get back to normal pace. Before I go ahead, I really want to thank all my current and past group members who have made these things possible. They are researchers from all over the world who come and work with me for their PhD or undergraduate projects, or are also postdoctoral scientists. Of course, all my collaborators across the world, not just locally and nationally, and all the funders who have been supporting our work for a number of years. So Sheffield is actually known as a steel city. So it was a steel hub during the boom of steel manufacturing. It's in the middle of the United Kingdom, very close to Manchester and not so far from London. It's actually a really, really green city, as you can see from some of the facts I'm showing and some of the pictures I'm showing. And one of the things we are really proud of in Sheffield is the trees to people ratio. It's quite high. And these are the pictures I have taken from places which are between 5 to 10 minutes drive from our house, which is in the city itself. Now, the university is quite big. It belongs to the prestigious Russell Group, and it is quite highly ranked both in the world and in the UK. It has a rich history, quite wide number of departments, and large student population. The department I'm based in is chemical and biological engineering. It's one of the largest chemical engineering departments in the UK. It is rated #1 for research environment, and also our students have ranked us quite highly for their satisfaction on their education that we provide. In addition, we work on lots of research themes which tackle 21st century challenges, and these themes are processes and systems, biological engineering, sustainability, which is what I will be talking about today, and materials and products, which is also an example I will take. We've made a lot of investment in new infrastructure. We have large cohort of students coming in and graduating every year. We are recognized through funding by many diverse funders, and we have more than 200 researchers who come from all parts of the world to embark on these research challenges. Okay, so let's dive into some of the technical aspects I want to talk about today. So if we look around, we may not realize, but there are more than 2,000 consumer products that use nanomaterials, and a lot more industrial products that use nanomaterials. And very briefly, if you look at between 2006 and 2011, the number of products that use nanomaterials have grown linearly. And currently we have crossed 2,000 products. And let's see where these products are used. So as you can see from the pie charts, a vast majority of them are used in health and fitness, but many other sectors are also catching up. And within the health and fitness sector, you can see nanomaterials are used in products used for cosmetics, personal care, clothing, sporting, filtration, and we've already seen a water filtration talk before this one, sunscreens, and lots of other things. So in a nutshell, nanomaterials present wonderful future opportunities for all of us. Before we go into more technical details, let's look at what is nano, because I'm fairly aware that a lot of people may not have heard about nano before or may not know what it is. So let's take a scale, and what I'm showing here on the bottom is 1 meter long scale, and on the top it's the nanometer length scale. So if you take a 4-year-old, and I have one of those running around, and he might come into this presentation in any minute, they're about 1 meter tall, and that's 1 billion nanometers. If we look slightly smaller, some shells and other things, and there's a reason I've shown shells here, which I'll explain in next few slides. Then looking at cells, bottom is a schematic of a cell, and the top is actually a cell of radiolarian, which lives in aquatic environments. They are of 1 to 10 or sometimes 100 micron sizes. Something that is very topical at the moment is viruses. They are about 10 nanometers or slightly less in size. And proteins that make up these viruses and other biological systems are slightly smaller, of 1 to 10 nanometer length scales. And then we have molecules, which are shown on the top, and atoms, which are shown on the bottom, which is about 1 nanometer or less. So that's scale. And I've shown what we can see by naked eye and what we can't see by naked eye. But on that scale, the very bottom end, which is between 1 to 100 nanometers length scale. So what I'm going to focus on in today's lecture is about the nanoscale and the materials which are in. Okay, so let's listen to a video. If you can't hear the audio from.
We don't hear anything.
So all of us, knowingly or unknowingly, use a lot of nanomaterials.
do.
For example, in sunscreens, in separation or water filtration, and also in industrial cases. But when we look at the manufacturing of these nanomaterials, a clear issue comes out, which is the amount of waste created when producing these nanomaterials. An analysis has shown that when we want to make 1 kilogram of nanomaterial, between several thousands to a million kilograms of waste is produced. And there are several reasons why this amount of waste is created. And these reasons include the need for high purity feedstock, which requires purification and high energy inputs. So just pausing to check, you can hear the volume audio from the video.
Yes,
Okay.
we hear it.
Yes,
perfectly.
sounds great. Thank you.
It also comes to low yields of production. So only between 5 to 10% of the starting material ends up into the product. The requirement for sequential processing, which means that at each step or at each sequence, we are producing waste and it simply gets multiplied. In some cases, we have toxic chemicals being used or toxic or hazardous byproducts being produced, which contaminate the waste. And also need for specialized environments such as high vacuum or high temperatures or long duration at high temperatures. And all these cases require high amount of potable water and high amount of energy inputs, which we could have otherwise used for sustaining human life. So there seems to be a tension between getting high quality nanomaterials that we really want for easing our lives, but also looking at the sustainability of their manufacturing and indeed their use. And how can we actually ease that tension so that we can make high quality materials which are still sustainable? So one of the ways we look at it is bio-inspiration. So how can we learn from biology to solve real life problems? And before going on to our own inventions, I just want to give you a flavor of how this has been done in the past. And obviously Velcro is something that we all know. Imagine this problem, little boys and girls always struggle with shoelaces. But we also know that these blur plants come and stick to our clothes and sweaters and other things. So how can we use the blur plants to create Velcros such that all the youngsters don't have to get tied up in tying their shoes? So it's actually a hook and a loop kind of mechanism that blur plant use, and that's how Velcro has been invented. Another example is climbing gear. 10 marks for guessing what that picture is and who is in that picture. But you would think that it's actually glue doing this. No, actually there is no glue. The stickiness comes from an inspiration taken from gecko. And if you look at gecko's paws, it has multi-length scale structures. And something I've shown here in the green oval that can be zoomed in looking at a high resolution electron microscopes. And you can see lots and lots of fibers or antenna coming out. And if you look even more closely in that blue area, you can see that there's a bundle of fibers. And if you look at the tip of those bundles, even at higher resolution, now look at the scale bar here, it's 1 micron, which means each of these hairs coming out are in the nanoscale. And there's plenty of these things. And what they do is they improve the number of contact points, which creates a lot stronger forces to hold and stick. Another example that's catching up recently is waterproof paint inspired by lotus leaf. And what it does is it creates hydrophobic surface such that water, instead of spreading, as shown in this drop, actually curls up and doesn't like to contact on the surface, which is common of a lotus leaf, and it doesn't wet the lotus leaf surface. And again, if you zoom into what is happening at the micro and nano length scale, you can see lots of these structures, nanoscale structures that create such a hydrophobic environment that water droplets cannot spread around. So moving on to our own specific case, can we use bioinspiration as a nano solution? And if you look around, there are lots and lots of familiar examples of biominerals or biomaterials that are actually nanomaterials, but made at eco-friendly conditions. Simple examples are shells, pearls, our teeth, bones, and some of the examples that I'm interested in are microalgae called diatoms. So we probably can learn from these, which can lead to green roots, yet make high value nanomaterials. So I'm again going to show a quick video talking about the microalgae, which you can see from the picture on the top right in my slide. They essentially grow as green stuff on ponds. We've all seen them, but we simply don't recognize what they are. So one of the examples we're looking at in terms of materials is silica, which is SiO2. And there are microalgae called diatoms, which grow in ponds and also in drinking water sometimes. They produce biological silica. So diatoms selectively uptake the precursor for silica, which is essentially dissolved rocks in any water environments. It then uptakes that and concentrates it within the cell, and those concentrated pools of the precursor are taken to the site of silica deposition. Now, at the site of the silica deposition, there are proteins and other organic molecules which pre-assemble into the final form, and as the precursor arrives there, it catalyzes the formation and also the templates the formation of biological silica, thereby making a cell wall, which is what the diatoms use for their protection. So these seem pretty amazing, and we can learn a lot from these materials, and that's what we have been doing, looking at these diatoms and many similar systems. And our ethos has been learning from biology and taking it to the technology. So we observe things, we try to understand, make sense of that, and then apply and adapt them to our needs. Going a little bit deeper into how we do this, specifically, we've actually written a book about this, and if you want more information, you can go on this website, which is greennanobook.com. And we've created a methodology or a pathway where we start from these biominerals, try to learn from them, how do they work at atomic and molecular length scales, and develop some of these catalysts or additives that we call, which can lead us to making lots and lots of beautiful and useful nanomaterials. We can then develop their applications in pharmaceutical, in carbon capture, and many other examples, and work on their large-scale manufacturing such that now we have eco-friendly nanomaterials which can be manufactured using a sustainable route. So I'm going to dive into our invention. How we have used that methodology is one example where we have reduced the temperature of manufacturing from 600 degrees Celsius to 20 degrees Celsius. And I'll elaborate that with this slide. So an old method which required to use some of these molecules which I've shown as red circles with blue tails. And the synthesis of these nanomaterials required more than a day and higher temperatures, more than 80 degrees Celsius in their first step. What they produce is nanomaterials which are impure. So all these pink things that I've shown here are these starting molecules that get trapped inside. So these materials are not pure. And in order to purify them, we have to burn them, which is what calcination is. And that requires 600 degrees Celsius for 6 hours. That's tremendous amount of energy input that we require, which results into pure high value porous silica in this particular case. But if you look at the amount of energy and resources used, it's extremely high. And that has been causing barrier in commercialization of these materials for nearly 2 decades, so more than 20 years since their invention. What we have done is we've learned from biology and developed these bio-inspired additives shown on the bottom left of my screen. And what they enable us to do is 2 things. One, we can now synthesize these materials at room temperature within 5 minutes. So that's a lot of energy and time saving. We still make these intermediate impure materials, but then the second step, we can purify these materials again at 20 degrees Celsius in 5 minutes in water. And instead, we can now get high value porous bio-inspired silica. The added advantage of this method is that because we're not burning anything off, after the purification, we can recycle pretty much everything, including water and these original organic additives that we have, back into our synthesis. So that's highly resource efficient and energy efficient method. So we've now created a highly sustainable method, which has huge savings of energy and resources. And we've done a lot of technical calculations. And if anyone is interested, they can get in touch with us to learn about more of these things. So coming out of a lot of these technical aspects, what does this enable us? So first of all, given the low energy requirements, this method can now be scaled up at large scale, which was not possible before because of high energy requirements, making it really, really costly and unsustainable. So we can make these materials at large scale, but we can also reduce the cost of existing materials. So for example, where these materials are used in everyday products, we can now make better quality materials, but also perhaps at lower cost. We can make some high value materials such as catalysts that are used in refining and other types of industry. But more importantly, these materials are now enabling new products which were not possible before. So we have been testing these materials for pharmaceutical excipients, for energy related systems such as carbon capture, or even making battery electrodes, and in water treatment, as was highlighted as the importance in the previous lecture. So it opens up lots of new and exciting opportunities for future. So what we are doing in future is we really want to invent and keep inventing sustainable routes to functional nanomaterials, such that they have really top quality properties. The processes are efficient and sustainable, yet economical. We want to make everything environmentally viable and look at lots and lots of different applications. So currently in my group, we are looking at the core, which is the green nanomaterials chemistry and engineering, to apply to energy sector, to manufacturing sector, to biomedical materials, making catalysts and biocatalysts, and also in environmental remediation. So these are the avenues we are taking, and we really think that these inventions will reach market one day. So let me summarize. So what we have seen so far is discovery and implementation of a green or sustainable manufacturing method for nanomaterials. And this method offers significant advantages, such as it is really a fast process. It occurs at room temperature. It occurs in water. It occurs at ambient pressure, so does not require high or low pressures. And the unreacted material has the potential to be recycled. That includes the feedstock and also the organic additives. All these benefits come together, actually compound in terms of providing huge amount of potential in terms of making cost-effective yet high-value nanomaterials. So what we have seen so far. So in summary, for all the young inventors around, I would say look around, get inspired, and go invent all new discoveries that you want to make. And with that, I would like to thank you all and end my presentation here, and happy to take any questions. Thank you very much.
Wow, I was very impressed with that. That was great. I love the way you went through the whole process and talked about what was going on. But one thing I'd love to have you clarify is nanomaterials are very small, but they're just not small. They actually have different chemical and physical properties. Can you talk about the different chemical and physical properties of nanomaterials and why they might be useful and valuable in some of these products?
Yes, absolutely. And I'll give a very simple example. If I take a football, it has a given surface, and all the youngsters can tell you that the volume of that football is 4 pi r cube, and the surface is 4/3 pi r square. Now, if you take that ratio of how much surface is available in a given volume and keep that on one side, and now if I chop that football into 2 halves, where my knife cuts it it now creates two surfaces on both sides. So now we have, for the same volume, more surface available. And if I chop it 1 billion times, I'm going to get those 1 billion times more external surface for the same volume. So I have now increased dramatically the amount of surface for the given volume, which means that now those particles or nanoparticles or nanofootballs can interact significantly more with the external environment. And that external environment could be air, could be sunlight, could be reactants or molecules, all sorts of different things. So now within the same volume, we have the ability to trigger all sorts of things at much, much larger amounts. And that's one specific aspect. And as a result of that, we have a lot many atoms present on the surface rather than inside, which are keen to interact with the external environment. So they can catalyze reactions. They can have some really beautiful optical phenomenon that can give you color, or that can act as triggers, that can conduct electricity in lots of other applications. And that's the real underlying principle. And that means that many other properties that we see in bulk materials are actually different in nanomaterials, and we can have lots of new avenues and new areas.
Yes, very much. One of the other things you talked about was the fact that you improved the process by doing things at a lower temperature. You couldn't just lower the temperature. You must have been doing something else, because if it worked at a lower temperature, why did they go to a higher temperature? Can you talk about the other factors that contributed to the success of the process at the lower temperature?
Right, that requires me to summarize about 15 years work across the world in 2 sentences. So what actually we did
three
was
sentences.
three sentences, okay, with colons and semicolons. So what we did essentially was understood at the molecular and atomic length scales how biology does this. So we looked at the proteins and the molecules that biology uses and interacts with the precursors and the final nanomaterials at atomic length scale and molecular length scales, and tried to mimic those principles using some synthetic molecules. And those molecules have specific interactions with these nanomaterials, such that now the energy required is much lowered because we are using much higher type of interactions, which also results in the fact that we can tune those interactions and switch them off when we want them, which is what we use in the purification example. Is then we switch them off and those molecules just get washed out in aqueous solutions. I think those are 4 sentences.
Okay. I don't want to keep hogging the stage here with these questions, but I'm sorry. As an ex-chemical engineer, I get enthusiastic about this. Everything we do has unintended consequences. And I know with nanomaterials, there's lots of positives, but there are also some negatives. There's some things that we didn't quite expect that might happen, and there's some problems. I'm not asking you to talk about them because we should say, no, we shouldn't use nanomaterials. But if we are aware of potential problems, then we can adjust and make corrections for them. So can you talk about some of the things with nanomaterials that may be not quite as beneficial as we had hoped?
So I think I would look at 2 separate areas. One area is actually making them, which is what I was talking about. And the other area is using them. So when we are using them, we need to be aware of their properties and their fate. How do they interact with the environment where they're going to be used, and where do they end up? So in a lot of cases, they don't end up anywhere. They stay where they were, which is perfect. But then we have to think about how they interact. But if they are used such that they escape, or they are supposed to escape in the environment, then we need to know how they interact with the environment. What do they do, and what are the dangers, or what are the things that we need to be aware of? And like any drug, for example, we have side effects. So we have to balance out the value of using them, the benefits of them, and the risk associated with them. Now, again, the risks come with not just the size, but also the chemistry. So not all nanomaterials chemistries will cause problems, but then there are some that will. So examples are catalysts, which are supposed to trigger certain reactions, and therefore they will go out in the environment and trigger reactions, sometimes unwanted ones. But systems such as silica that are used even in food and cosmetics, they don't cause much problem because of their benign surface chemistry. So we have to understand these things and be carefully evaluating what their consequences are.
Great, great. Because the nanomaterials that you're using are, very frankly, much smaller than the coronavirus, have you been approached by pharmaceutical companies asking you to make specific shapes and specific types of nanomaterials, maybe as an antiviral component?
I specifically haven't been, but I know colleagues who have been making really funky shaped nanomaterials have been thinking about doing this and interacting. So the flip side is that 10, 20 years ago, or starting then, people have been using viruses to make nanomaterials, to interface with nanomaterials and use their recognition ability. So that knowledge does exist. So a lot of colleagues across the world who are experts in that interface are looking at ways to actually trap the viruses or make them inactive. And yes, that's very topical.
Mm-hmm. And one more, I'm sorry. You talked about using silicon, silicon dioxide. Are there other chemicals, other materials that could be used as a base for nanomaterials besides silica?
Yeah, so lots and lots of different ones. I mean, we have ourselves worked on many oxides and metal nanoparticles, but there's a whole host of more than 50 odd nanomaterials that people have been working around in the world. So gold particles, platinum, palladium nanoparticles, zinc oxide, germania particles. Titania is a really good example because it can be used in water treatment as a photocatalyst. So a really wide range, and the methodology I showed is actually a generic methodology we have developed that can be applied to a lot of different chemistries. And one of the really high potential project we are working on at the moment is making battery electrodes or the materials required for battery electrodes using our method, because battery electrode materials require sometimes 1,000 degrees Celsius temperatures.
We have students watching this, young students watching this, and I'm sure they're thinking, wow, sounds really interesting. What types of subjects should they take in high school and then later in college if they thought this field was interesting and wanted to pursue it?
Probably I'm not the best to advise because I dropped biology when I could, but then I relearned it during my PhD time because we were all learning from biology. But with hindsight, I think we need to look into multidisciplinary aspects. So learn as many subjects as possible, keep eyes open if opportunities are presented. Don't be scared to jump into new areas. And imagine somebody from high school onwards didn't learn biology, went into hardcore engineering, then came back and learned biology. So it's possible. Don't be scared. Jump into new areas. We have the capacity to learn lots of new interesting things, and we can actually drive ourselves to learn new areas.
Great, very good, very good. Thank you very, very much. This was very exciting. You talked about learning new things, and I love these presentations. I'm always learning. And what I liked was that you gave a methodology for here's what you learn, and now you opened up a book to this biomimicry. And I'm sure there's lots of students now who will start looking around their world and looking at nature and saying, gee, if I can't think it up myself, I'll copy it from nature and find out what nature has done, because she is very clever. Thank you very, very much for this.
Thank you very much.
Thank you. Wow. I did a lot of work in robotics as an adult, but originally I was a chemist, so you never know where you're going to end up, okay? We have another presenter, and Raj is ready, but Raj, before you start, I'd like to, if you can give me one bit, I want to show another one of our magic videos that Daisha has created. This time I'm going to see if I can actually show it. Let's see if I can do this. I don't know why this hates me. Okay. Let's see. Do you see it?
Yes. And I think I hear it almost. I've not seen this one.
Okay. And we are back. Okay. Raj Kapoor, let me get you, let me turn off your, Raj, can you hear me?
Yes, I can hear
Great.
you well.
You are now in charge. Raj is running an incredible program called the India STEM Alliance in India. And he's going to talk about India making STEM strides. India is a huge country with incredible talent and personality and potential and reality. And so, Raj, can you share with us what you are doing? What is happening in India?
Yeah, there's a lot happening, and the last 2 months have actually taught us to be actual innovators. I shared with you some time back a little video of what my students had made. If you remember, initially a face shield, which everybody had, we worked remotely on that. So everybody was actually creating that right from wherever they were sitting, from their homes with the 3D printers, etc. So that went very, very well. By the way, we also actually, during this entire pandemic, we also, my kids also created what is known as a COVID camera, which I will share a little more with you later on. But basically what the idea of India STEM Alliance, and by the way, hello to Julie and hello to Dacia. I see them on the screen, but I've never met them in person. So hello to both of you as well. And once again, Jake, great to catch up with you virtually again. So coming back, we started this with India STEM Alliance with a clear idea that India has, at that point of time, had very little clue as to what is STEM exactly. So the first few years, we've been spending actually evangelizing and educating people what STEM is. Then we took a leaf from the problems faced by our country and said, let's put a lot of social, let STEM have a social impact. Let it not just be a business or some fun or a club. So actually we do a lot of work in the social impact space, and that's what I'm here to talk about today. I don't want to talk about profits. We don't want to talk about money all the time, but we really want to see what social impact we have made and we are going to make in the future. So when you're ready, I have a very, very brief presentation. I'm going to wrap up in 15 minutes because I know you guys have got a very, very long day ahead. There have been so many presenters, and I know it's an odd hour for you, I'm sure. It's not an odd hour for me, but an odd hour for you. So if you like, I can just, jump right in, and then I'll just share my screen then, okay?
Yep.
Just give me a moment. I'll pull it up and I'll share my screen. Yeah, here we go.
We see your screen. Perfect. Perfect.
All right. Why we call it social initiatives is because that's what our real core focus has been over the last 18 months, so to speak. Whatever we do and with whoever we partner with, let's try and make a social impact. Our country needs it. It's there's a huge population and we have N number of problems. So we're trying to see if we can get people to understand STEM and then, find solutions for those specific problems. I'm going to address a few here. There are plenty, but I'm going to address a few. What is important to know that we have aligned ourselves very clearly with the United Nations Sustainable Development Goals. And each of our initiatives, there is a goal which we cull out from there and then actually make it happen. So here I go. I've translated it. This what you see, Lak Shikshak Ek Dakshak, is in Hindi, is in our language, but it means creating 1 million STEM teachers in the next 10 years. That is our priority. We know that this is a very great social impact for our country if we have teachers, because if you can have STEM, you can have concepts, you can have lots of things, but if you don't have the teachers, you're going to be in trouble. It's just like having a car without having a chauffeur or petrol. So you're gonna have beautiful Bentley lying right in front of your porch, but you can't drive it because there is no fuel. So what we are doing is creating a different type of a fuel which is non-existent in our country. We've got teachers, a hell of a lot of them, but 99% of them do not know what is STEM, and that is a challenge. So we've actually partnered with a lot of teaching organizations, a lot of international teacher trainers as well, by the way. And our aim is to unite the nation's academic institutions, the nonprofits, the foundations, companies, governments, to address the complete STEM teacher shortage. Yes, the government understands now that STEM is the way to go, but we don't have teachers. So first, we're doing a lot of capacity building, and that's something which is picked up very well. The governments are warming up to it, and we're doing a couple of pilot projects with some state governments. We are doing a lot of projects at the private level also. So getting 100,000 teachers in 10 years is a huge and very challenging task, and India STEM Alliance actually stepped in, and we are now getting a lot of interest from international bodies, NGOs, as well as Indian bodies, NGOs, not-for-profits, teachers, STEM and consultants, experts who really want to make this happen. They're all contributing, and that's been a very wonderful experience. We're giving them the support, and best part, we are doing this entirely online, completely online, before the pandemic, during the pandemic, and probably even after the pandemic. So this is something we're actually telling them, see, technology is there, let's use it. Otherwise, India, as a country as large as ours, with 28 different states, it's extremely difficult, and the demographic geography being different, to reach out to so many people at one time. So again, technology comes in, and now we're doing that. So this is something which is very close to our heart, and it's even very close to the government now, because they have realized that the way to go forward is have to have more innovative mindset, more thinkers, rather than they're just rote learners, which is what we've been having over the last few years. Now that paradigm has changed, and that's where we have really come, and we are now market leaders in this space now. I'll move on to my next one. And please feel free to ask me any questions if you want, or you can wait for it to end. It's just 3 or 4 slides. That's it. Yeah. This is another one which is very close to us. It's called STEM Sakhi. Sakhi means friend, and a STEM friend, especially an initiative specifically for girls. In India, girls are always regarded as those who will take care of the household. They'll take care of the chores in the kitchen, the washing, the laundry, everything, but not really step out into mainstream work. Now, that's what we're trying to change that now. And we're trying to get a lot of girls get into the STEM profession. It's a very difficult task, because the biggest challenge comes not from the girls themselves. They love to learn, but it comes from parents. It's come from society. They say, why do you want to go out and learn something? Why do you want to move out of the house? Things like that. There is a lot of conservative mindsets in India. Not in the main cities, but definitely if you go beyond the main cities, this kicks in. So again, we started a complete program specifically for girls, and we call it the STEM Sakhi. And that's why you see this girl with the balloons. We teach them how to soar. We teach them how to fly. And, we feel that they are damn good, but nobody encourages them. So we are there. So we've started a holistic program which includes coding and virtual reality. We're teaching them, we're starting off with coding and virtual reality with them. And again, this too ticks off the boxes for the goal 4, goal 5, goal 9. That is equality, education, gender equality, and innovation mindsets. These are all, again, sustainable goals. This program has picked up very well, and right now we have 3,200 girls who are now part of this movement for us. And again, we get a lot of international help. We get a lot of international participation. We have somebody from the US who runs a complete podcast on their behalf, completely pro bono, but it's a fantastic effort which everybody's trying to make out here. So that's the second of our initiatives in social impact. We want to bring in more girls into the technology, science mainstreams, and that's happening now. Over the last few years, there has been an increase of 11 to 12% of girls actually getting into STEM space, STEM fields at the school level and at the higher education level as well. That brings me on to my third, and again, as I said, there are plenty of initiatives. I've just selected 3. This is again very close to the heart. It's called Prithvi Se Pyar. That's in Hindi, and the English version is Love Your Planet Initiative. We've actually working with educators right across the world, including, I'm sure you've heard of Discovery Education. So Discovery Education works very closely with us as well in this initiative. And we are working with educators. There is an educator from the United States called Laura Arndt, and she runs the Green STEM Initiative. We're working very closely with her, Captain Planet, and a couple of other global as well as local companies and foundations to bring about and actually create solutions for the earth. And that's something which is very close. Now we create ocean quests, we have pollination quests, we have soil quests. We bring back your sparrows, bring back your butterflies, bring back your, bring back the bees. So a lot of kids have started becoming sensitized and they understand why we need to take care of the world. It's a very old adage, we all know that. There is no planet B. We have a planet A, but we don't have a planet B. So you got to take care of your own planet. You got to take care of all the things which are dear to you. And if you don't have your planet, you have nothing. So these are the three initiatives which we have really rolled out and have had a lot of interaction. This, especially the Prithvi CPR, is going to be soon adopted by the government as well. And we're rolling it out as a pilot with 2 state governments in India as well. So I just wanted to share my experience of these 3 initiatives with you guys. And that's it from me as far as the initiatives are concerned. Love to hear from you if anything.
Well, Raj, that's incredible. I can't tell you how impressed I am with what you're creating and what you're doing. And we are going to be, we are obviously recording this, and we are going to be putting this up, and people are going to be watching this now. You are going to be a template for other countries, because very frankly, any problem you have in India, they have other places also.
Yes, they do. Yes.
And so they're going to be looking at what you're doing and going, well, we should be doing that with our children. I know you don't want to talk about money, but money does make the wheels go round. So
yeah,
how are you funding this organization?
I'll tell you. Yeah, that's a good question. Yes, you require money is actually the real fuel of everything anyways. What we do, we also, while we have these initiatives, we also have for-profit businesses. Like we do a lot of curriculum development for schools. We do a lot of workshops there. We set up these innovation labs, what you call them in the US as the maker labs. So we call it innovation labs or idea labs in India. So all this generates money, and what we do is, and that's something which which I'd love to share, is 75% of our profits comes back into these initiatives, and that's where money is important. And we are completely self-funded. We have not taken a single dollar from anywhere outside. We have funded this initiative ourselves through our business. And we now work with more than 3,200 schools across 3,100 schools right across the country. We work about 300 to 400 colleges. We work with now, since the time I spoke with you last, we are now in 120 different towns and cities in India, 12 different states. And the India STEM Alliance has gone beyond the shores of India. We are now also present in Nigeria, in Kenya, in Botswana, in Rwanda, and a couple of other, Nepal. So we've been in many more places now. We've expanded rapidly over the last few years, and all that has helped us because the profits from there and the money we make from there by setting up these, by selling basically STEM kits and science kits right across the schools, help fund our social initiatives. So that's what we do, Jay.
So if somebody is watching this from a country that does not have it, could they contact you? Would you be interested in talking and helping them set something up?
Absolutely. We're doing exactly that in Africa, in Nigeria, in Kenya. We are working with a lot of local people, and we're happy to share our expertise, the models, technology, how we made the models happen. And all of them are very robust model because they've all been more than about 1.5 to 2 years old. And which is very, in India, it's big because STEM per se came to India about 4 years back. So these models have been running since last 3 years, and very sustainable models, and a lot of government as well as foundations are helping out us in this. So happy to help anybody who's keen to understand how they can do this and much more. This is free. We have many more which we can speak with them. Not a problem, and absolutely no cost. Happy to do so.
So speaking of all the things that you're doing, you are doing so many. Can you talk about what you consider your greatest success? And you can define success any way you want, but which are the projects you are the most happy about?
Yeah, well, actually, frankly speaking, I've taken top 3 right here. But if you want to measure success, I'll tell you how I measure my success. I measure success when I actually go to these schools and see kids who have never seen a computer before actually sit down and explore the world of coding, for example. I see them smiling. I see the enthusiasm. I see the inquisitiveness, the curiosity coming through. And at the end of the sessions, we take them, and I take a lot of them personally. The smile, the gratitude, it's just too wonderful. I have hundreds and hundreds of people asking me every day to come over and speak to the girls. So STEM Saki is my favorite, I would say. One of the reasons I'm a little partial to that is I myself have a daughter, so maybe I'm a little more partial. But yeah, and by the way, my daughter is in the USA, in the lockdown. She's in Walt Disney, so she settled out there. So that's a different thing. But yes, that STEM Saki I would count as my favorite. The second I would say is my Love My Planet initiative, and I see a lot of kids understanding the value of actually disposing trash correctly. Very simple. It may be simple for many, but in India it's not. Segregation of trash, taking out plastics from oceans, and even understanding that why bees are important for our existence, the existence of this earth. Simple things like that, which normally are not really taught freely in our schools out here. The impact they've created, we've got at least now about 2,000 clubs like this started up in the last 2 years. And all this are run by kids. They take care of it. And that's my yardstick for success out here. Finally, and for my teacher program, I have almost, I've said 100,000 teachers in 10 years. I think I'll reach that in about 5 years. And that, I think, is my yardstick for success there as well.
Wow.
Yeah.
That is fantastic.
So we've created a complete framework. We've created the content. We've created an online program. So it can run not just in India, it can run anywhere. We are happy to share with anybody who's seriously interested. We can work with them anytime.
And so if they wanted to find you, they go to India STEM Alliance on the web?
Yes, there I have my LinkedIn profile. It's linked to my LinkedIn profile there, or you have my email ID. You can share it with anybody who feels, I'm happy to share it. Not a problem.
Excellent. Well, thank you very much, Raj, for sharing this. A conversation with you is always exciting. I have to admit, though, that I'm a little bit excited, but I'm also very jealous. So
you are?
Yeah, I'm very jealous. I can't imagine how exciting it must be to go into those schools and see stuff. So thank you for sharing what you've done. Thank you. Thank you very much.
Thank you. Thank you. Bye-bye.
Thank you, Raj.
Okay. We have our next presenter coming up. Julie?
Yes, we do.
Antonius? Can you get him going? There we go. Yep. So Antonius, let me get you unmuted here. So this is incredible. Antonius, I don't know if you know this, but we have had an incredible amount of just amazing students from Indonesia the past few hours. I think you were probably watching, but they were just fantastic. And you should be incredibly proud. So this is Antonius Barras, and you are the director, the chief director of the program that has all those students?
Yeah, it's actually like a center for empowering educators and young people through innovation and creativity. So just a little bit secret that we are standby start from the morning. Our staff is standby to check everything's run well. So that's why I shared the picture to you just now. Yeah.
Very good, very good. So you're going to talk about Live Asia, Learn from Inventors, right?
Yes, yeah.
It's your presentation, Antonius. I want to warn you, you have a high bar because your students before you have done such a good job. You're going to have to really, no, I'm serious.
They are better than me.
We are not judging you, but I do want to say there will be a comparison, okay?
All right, so I will share my screen. Yeah, okay.
We see it, it's perfect.
All right, should I start now?
Yes, please start.
All right, so hi Jake, hi Julie, and hi everyone who watching this presentation. My name is Antonius. I'm a learning experience designer. In other cases, I'm a CEO of a Kriya ID in Indonesia. So if you want to know about a Kriya ID, you can scan this barcode. You will directly can see what is the Kriya ID, what we are doing. So previously, we concerned on in Indonesia for developing young people and educators as well through creativity and innovation. But like start about 1.5 years ago, we start moving to reach ASEAN countries and also Asia as well. We have some activities there. So anyway, I will not talk about the Korea idea at this moment. So I want to share about what is our dream actually. So I used to be a teacher before 2009 when I was in the university. So at that moment, I just thinking that we need more encouragement in education. So we are thinking about how to connect education, professional industry, and media and technology, and also how to connect to the society, investor, and government. So at this moment, I will talk about media and technology itself, how we use media and technology to enable and helping young inventors when they are doing in the process. So I give my title of the presentation is actually Live Asia. Live is stand for Learn from Inventors. So I will start from this. Because I was in the school before. So the thing is now is everything's changed a lot. Everything's disruptive. We are in the uncertainty era, right? So I think these 21st century skills still relevant for ourselves. It's not only for students, but almost all people who are alive now. So when we talk about this, we talk about the learning skill, literacy skill, and life skill. But I don't know why out there is so many people only talk about the learning skill, which is very known as 4C, critical thinking, creativity, collaboration, and communication. So at this moment, I think literacy skill and life skill is also important to be improved. It's like the information literacy, media, and technology as well. So that's why I'm trying and learn about this, and I try to integrate all of these skills all together. So the thing is, inventor need the story. So meaning to say that we need to be inspired when we are get inspired, and then we can create something, and then we can dedicate. So I try to put it is like this scheme. Myself, I call it ICD learning cycle. So this is what we use in Korea ID to work. So this is like a framework. So when we create the learning process, how this experience can be inspired and then make our students or young generation create something, and then after that not only create something but they also can dedicate to the society. So the heart of doing this is actually collaboration. So yeah, we use this framework to do. So the initiative is actually how young people get inspired and how to share the idea to the world. So that's why I really appreciate for Jake and the team on doing this. You are very doing this very well. So that's why, yeah, again, how to make a trigger for the young people to get inspired, and after that, how we help them together to make something, to to innovate something, and then how to share it. So the idea is coming from that way. And then we started learn from inventors first before in Indonesia, which is we record some stories of young inventors. And then we share about how they do it, what is the process, and what is the learning thing that they do. So we more concerned on the reflection. So here, as I mentioned here, I think like Nabila also joined this conference as well as Brandon. So here is when they have the innovation activity, but actually at that moment, what is the experience and what is the life value that they get? So from that, they can improve their life. So innovation is actually only the tools or the vehicle of the life itself. So that's the idea. We started from Indonesia. We record some interesting story and we select them. But as I mentioned before, that since like 1.5 years ago, we enlarged our reach to ASEAN countries first. We have like a conference to gather some young inventors from other countries in ASEAN, and also we tried to have some activity in Korea and Taiwan before. So that's why now we are thinking how to gather ASEAN people, and then how they can share about their story when they are doing innovation. So Live Asia is learned from Asia, so you can scan also this barcode, and then you can go through the link, and then you can see all these inventors. So we can see, and we can see what is the motivation of they are doing this, and what is the outcome, and how they work on this. So we hope that young generation will get inspired, and when they get inspired, and then maybe they get an idea, and then they can do something more. So how it does work is actually we try to review the invention and the team, and then after that we give them like an award, and after that we offering the project. So the project here is actually self-project. So the students or young generation, they can record by themselves using some requirement that we give to them. And then after that, they can do the project and submit to us. And then my team will edit and publish it in Korea ID and Live Asia platform. And then after that, certificates will be released. So that's what we are doing. But actually, what is the thing that we want to do is actually, again, how the young generation get inspired and how they have the stage to share. So in this case, we hope that the inventors can see how the other inventors get and doing the problem solving, how they get the value, what is the environment around, and what is the insight. So in the end of my presentation, in this case, it's not only about how the students or how the young generation, how people doing the innovation itself, but actually in this case, they learn how to learn. When they learn how to learn, they make the innovation happen. So I think that's all my presentation. Thank you so much.
Good. Thank you very much.
Yeah.
I have a question though, because I think what you're doing is fantastic, but Indonesia is a particularly difficult environment because the country of Indonesia is not only very large and spread across many time zones, but it's many thousands of separate islands.
Yes.
With literally 1,000 languages spoken throughout the entire country. How do you run a national program when it's so hard getting from one place to another and communicating?
All right. So in Indonesia itself, actually we have some community around. So it's like, I mean, like I mentioned to you, like today that our young generation they share their idea in this conference is actually some from Papua. Papua is actually close to Papua New Guinea. So it's far away, you know, and you know, the flight to Papua from Jakarta is like you take the flight from Jakarta to Europe. So, you know, it's very big, but yes, we try to connect with the community, and the simple thing actually how they can share their story, and then how we can publish it. So for this thing, actually, we have one language. We have our one national language. So we use Bahasa Indonesia to speak. But in other case, also, I love to travel. So when I travel to some places, I try to find the inspiring people. So that's what we are doing on this part.
Wow, that is an incredible story. And you said you were also working with other countries. You mentioned South Korea.
Yes. So with South Korea last year we have a collaboration as well. But I think for me it's more interesting when I shared to you my experience when I was in Vietnam and Cambodia. So in this case also I tried to find the interesting people. So when I fly to Cambodia, I tried to find these people or this young generation, and I did an interview as well, and I offered it to them. So that's why we have a lot of inspiring story that we keep now, and then we will release per month. So we already have from Thailand and Philippines, and in this month we will have from Indonesia, and next month maybe from Vietnam.
Very good. Very good.
Yes.
Thank you for sharing all this. Thank you. And I just wanted to let you know you did a very, very good job in this presentation. It was almost as good as what your students did. So I want you keep working, and you will get better, and you will be as good as your students. So
thank you so much. We can do kind of this next time.
Absolutely.
Yeah.
We are doing this again in July, and I expect to see more of your students at our next program.
Yes. All right. Thank you so much.
Thank you.
Bye. Bye.
Okay, Julie, I see that our next presenter is up.
Indeed, she is.
I am very excited. This is a person with unlimited energy, and she goes in so many different directions.
We need some of that about right now.
Oh, no. So, Rana has a program. Hello, how are you? She has a program called The Little Engineer. And trust me, that is a misnomer because their engineers are not little in any way. Oh, well, physically they are, but that's it. Okay. Rana is a leading Lebanese entrepreneur in the realm of STEM education. Rana holds a bachelor's degree in mechanical engineering and master's degree in electrical management, and is now 11 years into her Little Engineer program. What she has done is regional programs all over the Middle East. And in fact, Rana, you are now where? In UAE, right?
Hello, Jake. Hello, Julie. I'm in Dubai. I'm locked down in Dubai. It has been 66 days for now.
Oh, I'm sorry. That has not stopped her. I have seen all she's doing. And you're going to be talking about 3D modeling with 2 blocks. The sky is the limit.
Yes.
Rana, it is your presentation.
Yeah, thank you so much. Thank you. So I will share my screen here. Okay?
Yes.
Okay.
We see your screen.
Okay. So this is the presentation. I managed to do it, so if I want to share it later on with your anyone who wants to see it, but I will skip directly just to let you know that we at the Little Engineer are doing two type of business. So we have the business to business and we have the business to client. During my stay in Dubai, I was developing some content for the little ones, the KG1, KG2, KG3, for them to have hands-on learning, because all the school are asking, Rana, do you have anything for the little ones? So at that time I didn't. So during my stay, I was playing with these 2 blocks, okay? So there are 2 blocks, rectangular, square and triangular shapes. And you know, during the lockdown, all the hands-on activity were stopped because of the contamination and for safety reasons. So I thought, how can I make, you know, these 2 blocks going online and engaging students in creativity and innovation? So this is how the coronavirus inspired me to generate something very, very interesting to keep the students engaged in STEM education. Unfortunately, our platform is not online. It's not payable for now, so we cannot generate revenue. But I said, okay, Rana, it's okay. Let's give to the society. Let's give to the community. Let everyone be happy, parents, students, teacher, everyone, so we can excel. So I came up with this 2 blocks. You can see here, you have the triangular and the square shape. I converted these 2 blocks into STL files, so I can use them really on the platform. And I start to elaborate and think. And I thought, let's go to 3D Builder, where we can really make something nice and everything. So I downloaded my parts on 3D Builder, and I managed to create whatever I'm creating through hands-on on the screen. So I was so happy, inspired, and said, oh, I did it. So I started with the 3D Builder program to make the students, you know, gather the blocks together to design some shapes. But it's not about being and creating this. So you have to engage people and let them really follow you. And when I launched this to my partners in education in Lebanon, they said, Rana, we don't have, you know, 3D Builder. We don't have Windows 10. So I said, okay, let's do an Autodesk. So I designed the parts to fit the Autodesk platform. And now the students can use those 2 blocks on either 3D Builder or on Tinkercad to generate their ideas. But it's not here. How can you involve students and let them drag and inspire them? So I created the challenges, different challenges to create a boat, a snail, Easter bunny. So we were moving with the Corona from week to week to making a 3D county house, to make a face. And I designed 10 challenges so students can go to our website, collect the blocks, and start the challenges. So as you can see at the beginning, they had to go into designing a small boat here. So I gave them the instructor on how to do it. And these were the results. So students were adding blocks. You can see the blue one is on Tinkercad, the gray one is on 3D Builder. And students were following our instruction to build. So I asked them to do a snail. You can see the creativity of students. Some of them put some covers there, different colors, different activities. And from week to week, I started to increase, you know, the challenge and make it more difficult. So it was Easter, and I said, the student, let's do some Easter theme. So Easter bunny, Easter egg, and you can see how the students were generating, you know, the ideas to do whatever they want to do. And it was really impressive to see that students really can manage to create this garden with the eggs around the bunny. So, and this is why I said with the 2 blocks, the sky is the limit. So from week to week, I had to generate ideas and activities. So I thought about doing a county house, and this is the results of the students. You can see, and this is only with 2 blocks. So they cannot use other than these 2 blocks. So they have either to use the triangular one or the square one. And another challenge came to my mind is to make, you know, this face. So let the students create, you know, a face with eyes, brown hair, and let's see what, and this is what we received. So it was really, really impressive. So you can see that we can really unleash the potential of students just if you give them the chance to explore new tools or skills of tomorrow. So, and this is the airplane, the commercial, being a partner with Airbus, you know, so we are partnered with Airbus since 2012. We deliver workshops on aviation. I thought, let me engage students in this and let's build a commercial airplane. So you can see here this lovely guy who was working on his mobile phone on Tinkercad to generate and to build his own airplane. And another lady who is missing the Middle East Airlines did, you know, the logo of the Middle East on this. So really we can engage students to move around. And definitely we engage them in doing a space challenge, which was to build, you know, the Ariane 5 launcher. So you can see that how the students are designing. I can mention that the age of the guy who did this is 15 and the age of this is 16. So we were able to engage students from different age, from the little ones to the students heading to university. Opening this platform to them, we let them, you know, explore the opportunities of tomorrow and how they can excel really and what is needed in tomorrow. So we cannot hide on them and keep on delivering, you know, the traditional learning at school. Definitely from nothing, we managed to do amazing creativity for children. So this is here another one. I said I want to do a clown, and you can see how students thought about doing a clown in different, with the 2 blocks only. And this is the amazing thing about. And the last challenge was to make the Tower Hill Bridge from London. And this is what we received. This is the first design and the only design we received because it was launched last 2 days before. And I believe that this platform that we created during the Corona challenge can go from our local community in Lebanon, from the local school in Lebanon, to connect students and teachers and everyone around the world. So it's not only for Lebanon, it's a global project that I can believe that it can fly, you know, all we need is to make it sustainable. We have to make effective coaching skills to everyone. So we have to build a relation with the teachers to tell them how to use it so they can replicate it in their schools. And with the 2 bricks, we can do amazing job. Definitely later on, we're gonna release more bricks, maybe the circular one, other things to make it more creative. But this is what we believe that we can do. So sustainability of any invention is very important. So we listened to our partner who said that we cannot use the windows. So we designed something to fit on other channels like Tinkercad from Autodesk. So we are listening to them. We are providing for them instruction thanks to the great team who is in Lebanon and doing amazing job. They are really, really supportive to everyone who is requesting an inquiry on our website. And I believe that the building relation between learner, parents, teacher, parents, school teachers, and school director will be really amazing during Corona and after Corona. So this is what I believe. And this is, you can see that in order to keep the student engaged, we went to our social media to show their job and to make it, reachable to everyone, and to encourage them to stay online. And definitely we have winners who will win special session to our platform after Corona. And this is how we can keep engaging, recognizing the winners, maybe now online, maybe in the schools, maybe in the country. So this is how we can scale up the content. And because Corona hit everyone and the economy is going back everywhere, so we thought about building our online platform. So from now till the end of the month, we will be having, our online activity, the paid and the unpaid one. Definitely we'll keep on developing free online activity to engage everyone. We are partnered with Airbus Foundation, and they have, the Airbus Foundation Discovery Space, where we can engage students in aviation and space industry. We will be, collecting the best online resources for teachers and school to go and do not reinvent the wheel in fetching for different topics. So we will make the job easy because we have been doing this. So we don't care at all to share our knowledge. And definitely we will convert our TLE courses to paid session in the very, very near future to sustain our initiative on the global level. So, and this is how people can follow us. And I will leave the floor for questions now, for any questions if you want.
Rana, so I have a question then. This is built onto the Tinkercad platform, these models that you made.
Yeah.
So I have a Tinkercad account. How can I get access and use your models in my classroom?
Okay, so we can, it's in the presentation here. I will share it with you today, and you can share it with everyone. So if you are Tinkercad, so you go to the online platform, you have to be connected online. So you press on the Tinkercad and you log in. You have you put your email, you can log in through maybe Facebook or anything, and you can get here. So, okay, you can go to the Start Tinkering, and you can see what you want to do to create, okay? So you can tell whether you are an educator, student, to join a class or create a personal account. So you can create a personal account. You can sign either with Google or your Apple account or with your email. Once you are there, you can import the 2 blocks and you can start working.
How do I find your blocks?
You have to email us. And you can, tell me why. Just now at the beginning, but later on we're gonna put them online and they will be payable, because definitely we have to sustain the business so we can generate revenues. And if I take from you $1, it will not kill anyone. But this is how we can sustain the program later on. So it was an idea to because we have employees. And as a founder and as a CEO, I always think about not myself, my team. How can I keep my team working? I don't want them to go home. I don't want anyone to go home. So now we are sending these blocks for free for everyone. You contact me, say, Rana, please, I want the blocks. And I ask you which platform you want to work with, because the bricks that works on Tinkercad are different than the bricks that works on 3D Builder. So I had to adapt. I had to invent and to fulfill the need of every platform to make everyone happy and satisfied.
Great, great. This is a little bit of a change in topic, but can you talk about the wonderful work you're doing with Syrian refugees?
Yeah, definitely. So let me tell you what we're doing. The Syrian refugees, went back to 2015 because I provide solution for everyone. So I had a friend of mine who is Syrian, and she told me, Rana, how can we support Syrian in their camps? I said, okay, we can create a program for them. I started my team developing, content on how to build the ecosystem for Syrian refugees where they are by having, psychosocial support, thinking about education, about using the toilets, about everything. So, and I used a robotic kit, and I generated activities that cover, the environment, the technology, how to create a washing machine for them in order not to use their hands, how to make, the toilets operating and know whether the toilet is vacant or empty. So it's kind of, building a better ecosystem where they are. And we built a story of 20 lesson plan, and we started the program in the Bekaa, which is a place in Lebanon. And we exposed more than 780 students to full courses. And what was really, really, really impressive, that students were coming under the snow in the snowy time with the, sores on their hands because it was too cold, no heating, and they did not miss any class of robotics. And I said, why you're coming here? I said, we are learning. It's an opportunity for us to be something in the future. So give us a chance and we give you amazing things. And really, I kept doing this. And this program was featured in the United Nations, but we did not win, I don't know why, but hopefully we're gonna keep on doing this because we have many refugees, not only the Syrians. We have the refugees in slums everywhere. So I've been roaming in Africa, and we're giving this opportunity to every learner around the world. So it's really fulfilling to see the smile of students on their face after achieving something, and even without even knowing what is the computer. So they are experiencing a really amazing story with our tools and products at the Little Engineer.
Do you have a picture of the students? I just think it's so inspirational. I know you must have it somewhere on your computer.
I have a video. I have a video on YouTube. So on our the Little Engineer HQ. So if you go to the Little Engineer HQ, let me check if I can do it now. Yes, I can do it. Definitely I can do it. Okay, so we have to go here.
I just think what you're doing is so inspirational.
Yeah.
Because you're just helping students who really have no one else to help them.
YouTube. So if you go to YouTube channel, and this is the Little Engineer HQ. This is our channel. Okay. Oh, I don't want this. Oh no.
Don't feel bad. I have technology problems also all the time.
Yeah.
Julie is laughing in the background.
So here, if you write Sumbula, you can go to the movie. You can see the story of the Sumbula story. So STEM refugees pilot in Bekaa, Lebanon. So here you can see how we launch it, and this is how this is the students here. You can see they were, and we were featured on the CCTV.
Yes. You don't hear the sound though.
Yeah. So this is the students, and you can hear them. It was translated saying that please give us chance to learn, and we can do amazing job. I don't want to be, a housewife. I can be an engineer, but give us the chance to do that. So it was really impressive. So you can see here the students. Can you see them?
Oh, yes.
Yeah. So this link, I can share it with you later on if you want. I can share it on the chat. Maybe you can share it with whomever wants to see it.
Well, we are recording this video right now, and this will be put up on YouTube. And so later on, everybody in the world can see what you are doing and be, amazed.
So this is another thing that I'm really impressive about it is that I developed a content which is called Sustainable Countries for every country to feature sustainable development goals, robotics, coding, and renewable energy. And it was sold to New Jersey, It was sold to KSA, and very soon we'll be selling it to Qatar and to UAE. So this is customized, and it was launched from Lebanon.
Very good, very good. Good. What was your next goal? What is your next? I know you've got a full plate, but I also know your brain is still moving. What is your next project?
My next project that I want to start a program, STEM certification program for all educators, because I believe that STEM should be for all. And if we don't educate and put the teachers on the track, we cannot make STEM for everyone. So even if the school is buying the kits, but we don't have really the real educators who are knowledgeable, you know, in the language of tomorrow, we cannot have STEM for everyone. So my project is STEM certification program. Now I'm trying to make some deals with the best universities around the world in Lebanon, in KSA, in Dubai. So we can provide this, you know, STEM certification program consisting of 6 courses to be given to the teachers so they can be certified to manage a STEM lab in the future, because we believe in every school there will be a STEM lab. So nothing to hide. This is the truth. We're heading to there. So let us prepare the generation of teachers who are skilled enough to understand the language, to foresee for tomorrow, to prepare talents for the 4th industrial revolution. So this is my plan.
Very good, very impressive. And I know you will achieve it. There's nothing that you cannot do. That is great. Well, thank you very much. Thank you very much for sharing this with us. And I personally am going to be going and doing some stuff with your blocks, because I think that is
okay. You're most welcome.
I think that is fantastic.
I will be in Dubai. I will start from Dubai. Definitely, I will start from Dubai. And once I go back to my country, because I will not leave it alone. I will not leave my country. I have to pay back to my community. But I'm waiting for the right time to go back. So definitely, you are most welcome to come and visit our country. Absolutely.
Well, everyone's in that same situation. They're being trapped, but you're not letting being stuck in a room stop you. You're still functioning, and that's a sign of a real entrepreneur.
I want to share something very nice. So this is my wall. Can you see a little bit?
Yes.
So this is how I planned. I put the strategy to keep on going during coronavirus. So nothing can stop us. It's a will to be and to sustain and to go forward.
Very good. Well, thank you very much for sharing. Thank you. And Ramadan Mubarak.
Thank you so much, Jake. Thank you so much. Thank you, Julie.
Thank you.
Okay. Julie, we have some time. Can I show the Joe Lennox video?
Of course.
This time I'll do it right?
Sure.
Okay. He says before he can actually make sure he does it right. Okay. And now I'm going to share the screen.
I see some very cute spectators too.
And share. And do you see a big black screen?
Mm-hmm.
And let's see what happens.
Perfect.
The date was February 20, 1962. I sat in my 4th grade class.
Can you turn it up, Jake?
No classroom TVs in those days. Of astronaut John Glenn.
Turn it up on your computer instead. That might help a little bit.
Intercom system. I clearly heard Glenn's vibrating voice.
Take out your headphones.
The clock is operating.
I never imagined that in those few brief moments, my life would change forever. The date was February 20, 1962. I sat in my 4th grade class and listened to the radio broadcast, no classroom TVs in those days, of astronaut John Glenn's launch into orbit that was being heard through the school's intercom system. I clearly heard Glenn's vibrating voice announce to the world, "The clock is operating. We're underway." I never imagined that in those few brief moments, my life would change forever. From that moment on, I became totally enthralled with
Jake, can you hear me?
It's not working, Julie?
Yeah, the sound has been gone for a while.
Oh, I'm sorry.
That's okay.
Oh, well. I guess I'm the only person who's ever had technology problems.
Probably not.
By the way, this is the only time that ever happened to me.
For sure.
Oh, so depressed.
Try a different video.
I don't know what happened.
Got time for one of Dacia's little videos?
Yes, so see if I can screw that one up.
Oh, I'm going to grab some water. I'll be right back.
Okay. Let's see what's happening. Okay. Well, I don't know if anyone heard this. I have no idea if the sound worked or not. I just wanted to state for the record that I am deliberately causing these so-called technical malfunctions. And the reason I'm doing that is because then when we have presenters on and they have a problem, they won't feel so badly because the great Jake Mendelson also had similar problems. So I'm doing it deliberately to make people feel better. And
when I tried that video yesterday and I couldn't get any sound. And I know it works because Dacia's played it before and you played it yesterday and it worked great. So it's just one of those things that happens. It's okay.
Well, Dacia's special, and maybe it only works on Thursdays. It doesn't work on Fridays.
We were just checking to see if our audience was listening in. And thankfully, Laura Hudicka from Fizzy Labs was texting me to say, hey, we can't hear this. So shout out to Laura.
Okay, well, I would love to say we'll fix it next time, but I'm not sure what happened. So
I
anyway.
remember seeing these guys in a video.
Yes, well, we have some new inventors coming up. And this is, oh my goodness, Robert and Aaron, and I'm going to unmute them. And you guys will be up in a second. And they have some incredible inventions. And I think one of them is going to be a camping table for soil and sand. Is that correct? Yes? Okay, gentlemen, the floor is yours. This is your presentation. Please start.
Everyone, my name is Robert and I'm 8 years old. And my name is Aaron and I am 6 years old. We are brothers and we like to invent things together. I started to invent things.
Excuse me, boys. I'm sorry. Can you ask somebody to turn your volume up? We can't hear you very good. It might be because one student has a headset in. Oh, you both have a headset in. I don't know if your headsets are working. Try it again and let's see if we can hear you better.
Hi, everyone.
No, it's still pretty quiet. Can we try it without the headset? And see if, just unplug your headset out of your computer and see if that works.
Hi, everyone. My name is Robert and
It's still pretty quiet. Jake, can you hear them good or is it just me?
No, it is very quiet.
Do you have someone there helping you?
My mom is trying to help me.
I'm here, but they're
Hi.
better with the computer.
So do you know where to turn the volume up?
What about now?
Oh, now it's a little loud. Turn it, go the other direction.
Now it's too loud. Just a second, sorry.
I'll tell you when. Keep talking, boys, and then we know when.
Okay.
That's pretty good. That's good. Thank you, Mom.
Mom,
That's it?
Mom, can you come and help me with my computer problems?
Actually, they did it, not me. Okay.
Okay, Robert, Aaron, we're starting again.
Hi everyone, my name is Robert and I am 8 years old. And my name is Aaron and I am 6 years old. We are brothers and we like to invent things together. I started to invent things when I was about 3 years old. I used to open different toys, see what is inside, take the pieces out and then put them back together. I have learned a lot about what later I found out it was called physics and mechanics. I was also using different materials like pieces from broken toys, recyclable materials, or whatever I would find around the house and build different things, sometimes cutting or destroying important things I wasn't supposed to. When I was 7, I started attending invention classes at Discovery STEM Centre, and Melissa was and still is my invention teacher, and she's doing a great job in encouraging and supporting me through the process of becoming an inventor. She is always open to my ideas, even when my ideas are not the best. I started when I was 5 years old, and I have learned a lot from Melissa and from my brother. And sometimes our parents are exhausted about having materials all around the house, but they know that invention requires material, space, and a lot of time. Being home-educated is offering us a lot of time to focus on the things we like to do, and inventics is one of them. Many times I think about an invention, and I discover that it has already been invented. I sometimes feel disappointed that someone else thought of it before me. But on the other hand, there are so many inventions that nobody thought about. The world is changing, and so do our needs, so will we always find new things that people need. If we think about what we need, find a problem that we have, we will find a solution for us, and many other people who are having the same problem. My first invention came to my mind because I was going camping with my family, and almost every time the table was falling. This was either because it was too windy, the soil was uneven, or my little sister was pushing it. So many times we ended up with the foods and drinks fallen. So I created a leg system that would get inserted into the soil or sand, and the leg system would have a sharp end which would go into the soil or sand, making the table very stable. It can be used in campings, on parties, on the beach, or anywhere there is soil or sand. The legs are also adjustable, making the system very useful on uneven soil. My first invention came to mind when I was talking to a friend of mine in Africa, and he said he has never seen snow. So, my brother and I thought about an invention that would be able to show him snow. We imagined a globe that you would put in your room, and using a hologram, anyone could see how different natural phenomena look like. This would include rainfall, snow, storm, tsunami, tornado, hurricane, aurora borealis, or even show kids how a desert, a rainforest, or savanna looks like. This could be used in classrooms at geography classes so that kids could experience and understand better how these natural phenomena occur and how they look like. I have also met people who are meditating and are using different images of gardens and landscapes to get into the meditation state. This globe could bring them into any garden they want, with images and sounds. It could be a garden they saw on internet, a garden created on computer, or even a garden they've been in and they've recorded it. This could also be used when people go to sleep to create a relaxing environment, regardless of the outside weather, like a sunset, the beach, stars, or planets. Imagine you could hear birds singing, waterfalls, or caribou walking down the mountain anytime you want. The wonderful thing about this invention is that it would not only be a projection on the walls, but a hologram that would surround you, like it would rain or snow right on you, or it would bring the hurricane around you, just as if you were in the middle of a real one. The images and sounds will have to be very clear and the color is very natural and strong, so that the whole experience would have to be very real. We have found similar inventions, but not exactly like this one. This invention is meant to really make you feel like you are in a garden full of flowers or birds, or on the beach on a sunny day, or watching the colourful aurora borealis in Iceland. We could also create a database of hologram places and phenomena, and people could upload what they like into their globe. And also, people could upload their videos and others can use them too. It would be like a worldwide recordings database, where people from different parts of the world would share and upload natural phenomena from their environment, or even celebrations, dances, or fragments from their travels. I cannot imagine my life without my books, my piano, or my tablet, although I'm sure people lived happily too before these were invented, but times change and we have to adjust to these changes. Our planet needs help right now regarding environment, health, recycling, cleaning the oceans, pollution, healthy eating, mental health, and we should constantly try to find new devices to solve these issues. This is why I encourage parents and teachers to be open to children's ideas and to allow them to express. I encourage schools to have invention classes so that kids have the time and resources to build, create, and invent whatever they like. We need teachers who are able to support us in combining physics, mathematics, mechanics, and even chemistry and biology, and schools who offer us invention kits in order to be able to create better solutions for a better world. And last but not least, I encourage kids to just look around, listen to the planet, listen to nature around, listen to the people, find the problems around them, and then just think about solutions. Their solutions might help us all. Thank you.
Wow. Now, wait a minute. Now, tell me how old you guys are again.
I am 8, 6.
Okay, Robert, how old were you when you came up with your first solution to a problem?
Around 7.
And Aaron, how old were you?
I think 5.
You guys are amazing. Let me tell you what, Jake's and my co-hosts are going to be so jealous when they watch your video that they were not here to talk to these two brilliant young men.
So I have a question. Do you have some ideas for something coming up? You don't have to have it very specific, but are you thinking about other inventions?
Yeah, quite a lot of them actually.
Can you give us a hint as to what they might be?
Like we could invent some sort of hat which would have a radiator and it would have a solar power and a fan. The solar power would have like a flap which could open and close. Like if it's raining, you don't want your solar power to get wet. And the fan would spit, and the fan could use the batteries inside the hat if you couldn't use the solar power. The mini radiator is for making you warm when you're cold and it's winter. Or the other way around.
Do you two work together or do you each work on your own projects?
We work together.
You know, one of the things that one of the presenters talked about a few hours ago was if you're going to give a presentation, you need to practice. And you two have clearly practiced. This is very good. How many times do you think you practiced this presentation?
20 times.
That is very impressive. Julie, do you have any other question?
I've just got to quit tearing up. They're just amazing, absolutely amazing. And shout out to your teacher, Dr. Butt. She's fabulous, and we're so happy she invited you to join us today. You guys are wonderful. Keep on inventing. I mean, you might be inventors, but you guys are way more than just inventors. Way more.
Well, I personally am once again depressed because, well, because when I was their age, I didn't make anything, including my bed. So this is a real. You guys make your bed in the morning, don't you? Does your mother want you to do that? Yeah, I don't know why mothers want that, but mothers seem to always want somebody to make their bed. But thank you very much for joining us. This was great. This was a great program. Thank you. Good luck to you.
Thank you so much for inviting us here.
Thank you. Okay.
Ashley, I'm sorry that you're going to have to follow this last group of wonderful inventors because I'm not sure what you're going to be able to do.
Oh, no.
Unless you pull out your little one, maybe that'll help.
No.
I know, right?
Robert and Aaron, you want to watch what Ashley is going to be talking about because this is going to be very important to you. We have all these students now. We're talking about doing creativity and STEM and education and wonderful, wonderful, wonderful. And what's going through in the kids' mind is, why am I doing this? What is the reason for learning these things? What advantages there to me to learn chemistry or to know biology or to be able to weld or do something? You know, how is that going to affect my life in the future? And that's the question that the students are asking themselves. And Ashley was asking herself exactly that same question. And she created a wonderful website program. I'm not sure what you call it, but it's called Career in STEM. And it's turning your interests into a career. STEM Career Exploration 101. It's not STEM or science for the sake of STEM or science. It actually has an impact on your life. Ashley, the platform is yours.
Yes. Well, first of all, Robert and Aaron, awesome job. It will definitely be a tough act to follow. You guys did great. And I think that exemplifies everything that I'm trying to accomplish with Career in STEM. I was a middle and high school science teacher here in Hartford, Connecticut. And I saw just a tremendous disconnect, kind of like you hinted at, Jake, that students either were completely unaware of what existed in terms of careers, or they were struggling to find the science that I was trying to teach them to be relevant. And as a young teacher, I got asked all the time, like every good teacher does, why do I need to know this, Miss? Why is this important? And that's, I think, such a powerful characteristic of Generation Z and the upcoming generations, is that they want to know why. And it's not because it's disrespectful or subordinate, it's because they want to make it better. They really have a desire to improve the outcomes of the world. And if we can harness that power that's in every one of their minds and transform it and help steer it towards a career, the world will be such a better place. So that's my mission. I have a couple slides to show and just share my screen if that's all right. Just let me know, make sure you can see everything. You can see or no?
You have to press the green button at the bottom. It says share screen.
Share screen, gotcha. All right, I should be.
We see your screen.
Okay, perfect. So let's make it a little bit bigger here. So yes, Career in STEM is actually my invention. So like I said, I was a teacher. I couldn't answer that question of why my students needed to know this. I always loved science. So to me, it was kind of inherent. Of course you need to know it because it's cool. Who doesn't think science is cool? But not everybody initially out of the womb does think it's cool, and that's okay. So for me, I invented Career in STEM, which I'll show you all a little bit of a preview of, because it didn't exist and I couldn't answer my students' question of why they needed to know this. So ultimately what I ended up doing was revamp my entire curriculum. So I still taught the same thing, but I taught it through the lens of a STEM career. So to me, the best invention is solving a problem that you care about. No one's going to work harder on something than you if it's your passion. So this is my invention, and I'll just kind of give you a preview. Before I do though, because this is a very smart audience, I'm sure many of you are familiar with the tremendous opportunity that exists in STEM careers. These statistics are specific to the United States, but I know the trend is reflected worldwide. There will be 3.5 million new jobs in STEM in the next 5 years. STEM professionals earn double the average of what non-STEM professionals make. And there's a mass help wanted need. There's over 2 million jobs going unfilled every year. I'm a part of a lot of different committees, workforce groups, and I hear so many times that we have more available jobs than we can fill. And that's just causing companies to do some awesome things for job seekers. They're doing tuition reimbursement, relocation assistance. They'll pay for your degree if you'll just go work for them, and they'll guarantee you a job when you're done with your degree. So there's so much opportunity, and the more you're aware of what's out there, the better it's going to be for your life. So that's why, my little why, STEM careers are important. And also, this is really the ideal time. I know the world of distance learning came upon the whole world very quickly. It was a very crazy awakening. All of us became homeschool parents, myself included, overnight, literally. So despite the challenges, I know there are many, I'm going through them myself, but despite the challenges, there are two really awesome bonuses of what's going on now. Number one is all students have time for creativity, for innovation, for invention. That's not something that every kid gets time for in the normal day-to-day classroom. And secondly, you can connect your passions to careers instantaneously. I was a teacher, so often the bell would ring and you go on to your next class. And for kids who were really interested, if I was lucky, I could say, hey, here, check out this website. But oftentimes that I just didn't have time for that. So now we're all online anyway. Literally, Google is a click away. If you found something that you're interested in your distance learning lesson, Google it, find a career that connects, take that first step. So despite the obstacles, there's just a tremendous opportunity to explore your passions and connect those to careers. So for me, that's really the whole goal of this presentation, is to just give you a few ideas of how to do that. So in my personal life, I have a 4-year-old and a 6-year-old. And even at that young age, I work to help them define their interests and connect them to careers. So for example, my daughter, she loves to build with blocks. So one day I saw her building and I was just like, oh, Mila, that's some really cool civil engineering that you've got going on there. So it doesn't have to be fancy. I didn't like plan this elaborate lesson around it. I just named the fact that there was a career related to what she was already showing an interest in doing, building with blocks. So for any parents and educators listening, that would be my number one takeaway point for you, is just name a career that relates to what you already see your student being interested in. So you might be saying, well, I don't really know what careers are out there. There's lots of helpful resources to help. So there's My Next Step, there's ONET, and then there's my own website. Regardless of what resource you're using, I'll show you 2 different ways that you can do so. To me, tip 1 is just, it's so important to at least provide a starting point. And I'll show you what I mean in both teachers, educators, parents, and for students. So this is my tool that I've put together. I'll just show you one quick one. You can still see my screen, right? Okay. So a starting point is just a place, a launch pad, so to speak. So say you created something, one of the talks I saw last night, a boy had created something related to water and cleaning water. So he could say, the first step would be to define what about that project he really liked. Was it the environmental piece? Was it the engineering piece? Was it the making piece? Was it the electronics piece? So once you've found something that you're interested in, dissect it or help your students to dissect it to figure out what about it they actually liked. So say that student really enjoyed the environmental piece, then they could learn more about careers in environmental sciences, and exploring is just the first step. I myself always loved animals. I didn't know other careers existed, so I just figured, oh, I'll just be a vet, because that's all I knew that you could do with a career, with an interest in animals. I never knew there were literally hundreds of different careers that related to animals. So for me, a starting point is so, so, so important. And the younger, the better. So students, dissect, take it down of what you liked about it, and research careers that relate to that interest. Parents and educators, it's the same. Say you're teaching a lesson, I'll show you the alphabetical page this time. Say you're teaching a lesson about physical science. Maybe it was a phase change lab. Physical science, I could just look through, what kind of relates to physical science? Oh, physicist, okay. So now I can have a starting point to deliver my lesson through the lens. Okay, class, today we're gonna be physicists, and we're gonna explore conduction, convection, and radiation. So just naming a career that relates to what you were already going to teach, or something that you're already interested in. So this is just the resources that I've put together, but regardless of what resource you're using, to me, it's still the same process. So back to that, that's that. So I guess my summary would just be dissect what about your invention you really liked, what was the most passionate and exciting part for you. And then as parents and educators, do what you are already going to do, but deliver it through the lens of a STEM career.
Hey, Ashley, Robert, or Aaron, one of them sent a question in for you, and they want to know, can you search it on Google?
Yep, so you can go to careerinstem.com. The website is set up mostly for teachers, but there's this one right here, careerinstem.com/free, that has some helpful resources for kids as well, like articles, some career pages to get started with.
Ashley, you showed what's on your website, but you went through it real quickly. Is it possible you could show one of those shadowing videos? I think they're all fascinating.
Yep, so let me go back here. So the way I've laid out, I have over 100 different career profiles, and they're arranged in a couple different ways for students to explore. So for example, this one has been popular, which is the salary page. And this is something that I'm passionate about, so I'll just use this platform to spread my thought, is that there's a lot of great jobs out there that also don't require college too. So I think college is great. It's not always for everybody. And there are very good jobs that only require a high school degree or associate's degree. So yes, back to your question, Jake. All the 100+ career pages that I've assembled are put together in a similar way. What I've seen in the existing resources that are out there for career exploration, I taught mostly 9th grade, and I couldn't get my kids engaged. They didn't think it was cool enough to want to use on their own. A lot of it's very text heavy. And as we know, students, and really ourselves in general, are very visual. So everything I've created is very visual. All of the virtual job shadows show people doing the job. That was another barrier that I ran into as an educator. There's a lot out there, but a lot of it is just people talking about their job. And to me, that wasn't very helpful. It's one thing to hear about it, but it's a completely new thing to see it. So for me, I worked very hard to find videos that showed people doing the job. Do you want me to just kind of play a preview? These are all just YouTube videos that are embedded.
Sure, just, 1 minute.
Yeah.
Oh, the whole thing's 3 minutes. Show the whole thing.
Yeah, so it's just like a quick. Can you hear it?
A little.
The 3 rounds in them, in the middle. Everybody good? I wanted to be a game warden since I was young. It's been truly a gratifying and rewarding experience. 18 rifles, 26 pistols. Chris's goals are to ensure.
Ashley, I want to just stop for a second because we do have some questions. So how did you get these videos? Did you go around the world and video people? How did you do this?
No, these are all just YouTube. So I've just embedded YouTube videos that I scoured through.
So you scoured 100,000 videos and watched all of them to find good ones, huh?
Yeah, so really, I mean, I have created the career information sheets and I've created the activities to go along with it or found the resources. But really, that's what I've created is a curation tool. There's no reason to go out there and make your own stuff anymore because so much exists and so much of it is high quality. But for me as a teacher, I literally spent all my weekends on Google trying to do this for my students. And I knew there had to be an easier way. And really that's what Career in STEM is now, is everything that I had done for my students to be able to help them. And now it's helping over 1 million teens and students every year, which is very exciting. So the downloadable info sheets, they're in English and Spanish. They just provide a more expanded definition to give you a more in-depth look at what that job entails. The required soft skills, which are equally as important as the STEM skills, but also including the STEM skills. The education and then the salary. When you click on the salary, it goes to the corresponding Bureau of Labor Statistics page for even more research. So all of this is curated from the Bureau of Labor Statistics. I didn't invent my own salary and education information. This is all curated from government databases and presented in a way that students are willing to engage with and explore. And if you can't get them interested in it, all of this is useless. So that's what I worked so hard in, is just trying to make it useful to students. And then every career page ends in a try it. That was my last pet peeve as a teacher, is there's all this great stuff, but now what? So I have Johnny who's really interested in this. What can I do to help him take that next step? These try-its are a way to do that. So in this example, the students would go look at this website and find field training, work conditions, opportunities in their state. So to me, that was a critically needed piece, is a try-it, a way to see what's out there.
Wow. I know you keep talking about this for your role as a teacher, but I would think that parents would be very interested also, frankly, because they care about what their child's going to be doing and encouraging them to do stuff. So is this something that parents could contact you also and get on board with this?
Yeah, absolutely. I launched this website in 2017, and I actually never received any inquiries from parents until the last 3 months. So I have been getting a lot of inquiries from parents, which is exciting because I think there's just, now is the opportunity to be doing this. Again, like I said, despite the obstacles, parents have time to sit down with their kids and talk about how this connects to your future. And those conversations are so important. I know anybody listening that's an adult knows other adults who hate their job. So if we can start when kids are in 4th grade, 5th grade, if we can start even in kindergarten, pre-K, like I do with my daughter, if we can start early, imagine what the world would be like if so many fewer of us were miserable because we knew what was out there and we were able to make an informed decision.
Excellent. Well, thank you very much, Ashley. This is very exciting. I may get on here and see what my next career will be.
Yeah, go for it.
Thank you very, very much, and good luck with everything. Thank you.
Thank you, guys. I really appreciate the opportunity to be here. I've been tuning in and following. It's so cool to see so many great ideas. Lots of encouragement.
Julie,
Thank you,
is our next presenter up?
Well, no, Ting says we're going to jump ahead one presenter.
Oh, okay.
So, but Ting, I'm not getting a response for them when I ask them to turn on their camera. Maybe we can unmute them. See if that works. Whoops. Oh, there we are. Perfect.
Hello.
Hello. So we have moved ahead, and
the other student was having technical difficulties, so I'm assuming they're still trying to work that out.
I know what that feels like. I understand. Okay. And you are from China, correct?
Yes.
And ideas of invention come from life, always ready to discover problems in life, find solutions, and it is easy. Oh, I don't think it's easy, but go ahead. This is now your presentation. Please introduce yourself.
Okay.
开始。
介绍你自己。
大家好，我叫孙一言，我来自中国杭州。Hello guys, my name is 孙一言 I'm from Hangzhou, China. 去年我参加了中国首届小发明家展会，这也是我第一次参加这样有趣的活动。它在中国杭州的低碳博物馆举行。后来我还有幸被邀请前往美国参加美国的小发明家盛会，和来自世界各地的小发明家们一起在美国的底特律亨利福特汽车博物馆里举行。我看到了很多的奇思妙想，我觉得我从此喜欢上了发明。今天我想告诉大家的是，发明其实很简单。为什么说发明很简单呢？因为首先发明的点子总是来自于生活，只要你仔细观察生活，细心观察，擦亮眼睛就可以发现问题。生活中的不方便就是我们发明的起点。第二步，我们需要思考解决办法。虽然我们的知识没有大人们的多，可是我们的点子多呀。我老是会有一些奇思妙想，我会把那些冒出来的好点子都记录下来，再考虑那些点子是不是都能实现呢？第三步，我会和爸爸妈妈讨论哪些点子是比较复杂难实现的，哪些点子是不靠谱的，我会把它们都排除，剩下来一些我会动手尝试，因为我觉得这是最好玩的环节，因为我对手工特别感兴趣。我会使用各种工具，也会用乐高来实现一些机械结构。我觉得这也是最难的环节，因为有好多点子我都不舍得放弃。第四步就是实验与改进，我会自己试用，也会去征求别人的意见，记录下那些不方便的地方，改进，再试验，再改进，再试验，直到满意为止。下面我要给大家来介绍一下我的发明——未来拐杖。这个发明来自于生活中的什么事情呢？寒假里，我常跟爷爷去养老院看望太公太婆。我发现养老院里的老人大部分都需要使用拐杖，拐杖是他们最忠实的帮手。有一次，我们遇到了一位老爷爷，那位老爷爷正拄着拐杖走路时，口袋里的手机突然响了，他连忙伸手往口袋里拿手机，却发现，手机却掉在了地上，电话也没接着，拐杖也倒了。这就是生活中的一个问题。我想，怎样才能想出一个办法，让使用拐杖的老人同时也能方便的使用手机呢？特别是爷爷奶奶、外公外婆，他们现在已经很习惯的使用智能手机了。当他们老了需要使用手机的时候，能方便的使用手机，对他们来说特别重要。我也问了养老院里的老人，问了我的太公太婆，他们都说这是一个不错的主意。于是我决定好好动手开始做。我在爸爸的车上见过手机架是用磁铁把手机粘在手机架上的。我们出去玩的时候，妈妈也会拿着手机架架着手机给我们看动画片。我的第一个主意就是拿一个塑料袋粘在拐杖的这头，要把手机装进去。但后来，现在看起来这个办法确实有点简单，又有点不靠谱的。但在那时，这是我觉得最简单也最容易实现的一个办法了。爸爸妈妈鼓励我去尝试，于是我就动手做了。我拿了一个塑料袋，往里面装了一个手机，然后把 用胶把它粘在拐杖的这头，在试用发现了2个问题。第一是拐杖在走路的时候，塑料袋会摇晃，手机容易磕碰。第二是老人拿手机还是不太方便，需要打开袋子。于是我又有了第2个主意，那就是拿一个摩托车手机架，把它给装在拐杖上。我发现使用摩托车手机架后，前2个问题都解决了，但是又出现了一个全新的问题，那就是摩托车手机架很重，装上拐杖后，拐杖很容易倒。这的确是个大问题。后来在爸爸的帮助下，我找到了一种手柄底下有弯曲的拐杖和一种轻便的手机架和一种轻便的手机架。妈妈，它有坏了。
继续，你讲完。
和一种轻便的手机架，我觉得正好可以利用这个弯头来把手机架装在另一边，使拐杖平衡。果然，新的拐杖和手机架解决了不平稳的问题。你看，我把拐杖立在地上，它多么的平稳。后面我想继续改进我的发明，比如说加上摔倒报警、照明等功能。今天我只是想告诉大家，发明其实是一件很简单的事情，只要你用心观察、用心思考，再不断的去尝试，你就可以做出一个好发明来。谢谢大家 ，Thank you everybody. Goodbye.
Very good. Thank you. 谢谢。
拜拜。
拜拜。
Bye bye. Wait. Don't go away. King?
I'm here.
Hey.
Yes.
Yes.
I've
Yes.
unmuted you. You can talk. Do you have a question to ask in Chinese?
他说他问另外一个，他有没有什么
So
question？
I can ask in Chinese, right?
Great. So I have a question. He obviously has a cane attached to the cell phone attached to a cane. Okay. Who did he design this for? Who would this help?
谁帮了你的忙？说爸爸帮你。
Father and mother help me.
那你这个是做给谁用的？
我打算，我是做给爷爷奶奶、外公外婆、grandfather, grandmother, and old people.
We understand. His English is good. We understand. Tell him, King, thank you very much. That was a very good presentation.
谢谢你的演讲，非常棒。
Now, I think our next presenter is here. Ready? Let's see if we can get this going.
他说是不是下一个？
对，然后就到下一个演讲。可乐，拜拜。
拜拜。
你同学吗？
对，我同学。
你要把他那个。
And this is Chen, and you have a no, who is this?
No, it should be Chen. Is it not Chen?
Yes. Okay. And you have an invention called the shoe partner.
Yes.
I'm very much interested in this.
So I need to translate a little bit for her.
Okay.
Yeah. Professor Jake 讲说，你发明了一个写小二，然后看起来是非常有意思的发明，对吗？请教练。
Yes.
Ting, tell her to go ahead. It's her presentation. We want to hear about it.
OK，然后那么讲一讲你的发明吧，开始吧。
更多吗？共享屏幕。
Now she's trying to find out to share her PPT.
是在哪个影厅？
就是点击中间的 Share Screen 最中间一个箭头向上的。
然后是共享屏幕吗？
共享你的 PPT 文件就可以。
视频我们看不到哎，共享 PPT 共享
上面没
有。那如果看不到，共享整个桌面也可以。
稍微等一下哈。程控制。
We can see it.
Since they encountered the problem to access Zoom, so it might need a little bit time to find the PPT and to open the PPT, I think.
We've had problems ourselves.
Hello, 音听有了吗？
正在看，有了。
I am glad to see.
Hi, 大家好。
Yes, I'm sorry.
Hi, 大家好。我今天分享的题目是我的奇妙发明之旅。首先，我来介绍一下我自己。我叫陈嘉恋，是一个中国小学生，现在在浙江省丽水市中山小学6年级读。和一般女孩子喜欢洋娃娃不一样，我喜欢动手和创作，喜欢科技和科学，经常参加一些相关的比赛和活动。照片中是我去年暑假参加世界机器人挑战赛，每次活动都给我留下了不同的收获。Hello everyone, my name is Chen Jialian. I'm a Chinese primary school student. Now I'm in grade 6 of Zhongshan Primary School in Lishui City, Zhejiang Province. I like hands-on and creation science and invention. 下面我讲讲我是怎么爱上发明制作的。去年在中国杭州举办了首次的小发明家盛会，来自全国各地的小发明家齐聚一堂，根据年龄分组，分别展示了各自的发明。我第一次见到这么多的有趣的发明，有冰冷的天花板，会发热的马甲，可以规范写字的尺子等等。发明就像一把探索世界的钥匙，让我打开了一个新的世界，也让我爱上了发明创造。Invention is like a key to explore the world. It opens a new world and makes me fall in love with it. 我的发明叫写小二。为什么叫写小二呢？因为小二是代表中国文字中的服务生，写小二也就是帮助不会系鞋带的人们系好鞋带，帮助人们更快地收纳鞋带。而且可以装饰鞋子哦。为什么要做这个发明呢？因为我的弟弟不会系鞋带，每次都要我帮他系，所以我就想发明一个可以帮弟弟系鞋带的小装置。大家看，最左边的是我在家用3D 打印笔最初打印出来的图形，中间的小孔是用来穿过鞋带的，然后固定住，再盖上盖子，完成收纳。虽然比较丑，但对我来说有非常重要的意义。中间绿色的是升级版，用专业的3D 打印机打印的，是国内比赛胜出的奖品。在旁边是我参赛的作品，外观重新装饰，并且鞋带固定的地方安装了活动卡扣，使鞋带更加稳定。最右边的写小二安装在鞋子上的样子。Because my brother can't tie the shoelace, so that I want to invent the shoelace partner. This is my invention from simple to beautiful.
在赛前准备工作要做许多，我尝试了许多材料，画了设计图纸，而且准备了厚厚的发明日志，制作了发明展板，还拍摄了介绍视频。完成写小二的发明，我有几个收获的想法，想与大家一起分享一下。第一个是要细心观察，生活中有许多值得我们观察和发现的东西，只有去发现、去探索，才有改变的动力。二是要相信自己，我一直坚信自己能完成发明，相信自己能够改变世界，哪怕只是微小的改变，也要有100%的自信。三是要多做实践，发明肯定不是一次就能成功的，需要一次又一次不断的演练和实践。四，不断改进，最初的成果不一定是最完美的，需要多听意见，不断优化设计方案，才能得到最终最好的。My sure is first, careful of version. Second, believe in yourself. Third, practice more. Fourth, continuous improvement. 然后我去年参加的这个比赛的展会是叫做 National Invention Convention 国家发明盛会，去年是第一次邀请中国的孩子参加。此外还有日本、新加坡、加拿大等共600多个孩子参加比赛，我很荣幸作为中国代表团唯一一个女孩子参加。比赛是在美国底特律举行，在这里我需要布置展台，然后迎接评委的提问和打分，并且接受美国电视台的采访。照片中的老爷爷是 NICE 比赛的主席，他特地跑过来和我握手并鼓励我。比赛现场还有许许多多五花八门的发明，非常有趣。我交到了许多外国的朋友，大家都非常友好。这2张照片，左边的是中国学生代表团，右边的是参加比赛的全部选手，大家能找到我吗？我就分享到这里了。最后我想说的是，只要有梦想就去行动吧，女孩子也可以在科学的世界里自由的翱翔。谢谢大家。Finally, I want to sing as long as there is a dream. Go to action. Girls can also fly freely in the world. Thank you.
Thank you very much. Very, very good.
Yes, yeah.
Thank you.
You have been very busy. See. Julie?
So we had our next inventor on there, but I think he just disappeared again. Let me see if he's back out in the attendees.
Well, I'm going to try showing that Joe Enix video, and this one with sound. I'm really
well, Julie, sorry that I think Sun Yiyan has finished his presentation just now. That he's a boy before Chen Jialian.
Okay, so
yeah,
so we don't.
So, yeah, I think the next presenter should be Wu Yi.
Yes.
Okay, yeah. And I thought I saw. I've got them. Hold on just a second.
I don't see his name.
He is here. Just give me a second.
Oh, he is?
Yeah, here he is. Let me get the camera going. I must have lost some of my own access here. No?
Ah, I see him. But
oh, here we go. I wasn't getting all my commands coming up right, but it's working now. Hello.
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 Hi, Jake.
Hello. How are you?
I'm fine.
We are delighted that you are here, and your invention is the BB cup. Okay.
Yeah.
Yes. Okay. And if you want clean teeth, a clean toothbrush, a clean cup in your daily life, my invention, the BB cup, can solve all of these issues at once. and you are in school, and you are in 10th grade, correct?
I'm in grade 4.
Grade 4?
Fourth grade.
Okay. Please, it is your presentation. Talk to us.
Okay. May I start now?
Yes, you may, please.
Okay. Hello, everyone. I'm Dave from Hangzhou New Century Foreign Language School, and I am in grade 4. My invention is BB cup. I noticed that after my sister brushed her teeth, there would always be residues or toothpaste or other residues on the toothbrush. This creates bad bacteria on the toothbrush, and we put it back in our mouth. Also, there are stains on the bottom of the cup due to water residue after it not drying properly. To find out if this is a common thing, I did a survey. I sent out a questionnaire in my school and online. I received feedback from 778 people. The data showed 80.9% people noticed the residues on the toothbrush, and 89.1% people noticed the stains in the cup. 92.5% of interviewees clean the residues by water or their fingers. That is unhealthy and neglected by the most people, and that's exactly the problem I'm trying to solve with my invention. In my version 1.0, I proposed using centrifugal force to throw the residues out of the toothbrush with a little motor. But that is too powerful, so a cover is needed, and that will add costs, so I dismissed this idea. In my version 2.0, a washboard is placed inside the cup, and there's a slope in handle. In my version 2.0 plus, the slope was on the cup. We've also made a hole in the bottom of the cup to place the toothbrush. After some adjustments, I finished my design and 3D printed it. It looks wonderful. I attended IC 2019 China and tried it out. Feedback said the washboard was dirty after daily use, and the slope was not steady when the cup was put upside down. I talked with the teacher and started my version 3.0. I redesigned the sawtooth in the junction of handle and cup. Extra 3 support points were created. To finish my design, I learned a new modeling software, Creo. The most interesting thing happened. I mistakenly changed millimeter into inch while I did the 3D printing. And it came out a rice cooker sized cup, and everyone laughed. This is my latest version 3.0. This is the sawtooth. It can help to clean the residues on the toothbrush. These are the 3 support points. When we invert the cup, it will stand on them to drain off the water. The hollow cup handle. We can place the toothbrush in it. How this cup works. After brushing your teeth, you have to do 3 steps. First, rub the toothbrush against the sawtooth back and forth to clean the residues on the toothbrush and rinse the toothbrush. Second, invert the cup. It will stand on 3 support points to drain off the water. Third, last, put the toothbrush in the hollow cup handle. The price will be nearly $4.99. This invention is for everyone, since we all brush our teeth. In the future, I plan to design different sizes and styles to match children, teenagers, and adults. My idea has a great commercial value. It solves the cleaning problems that people neglect after using their toothbrushes, and it's helpful to our oral health. Recently, Melissa gave me a feedback. She
She said that she had a 5-people family and there isn't enough room to place all these 5 cups. In my version 4.0, I'll plan to design to solve the problem. Who wants clean teeth? Who wants a clean toothbrush? Who wants a clean cup? Want to solve these issues all in one? Find BB cup. Thank you. And I will show you the display board.
Ah, we see it.
Okay. This is my version 1.0. It uses centrifugal force. This is my version 2.0. It uses the washboard. And this is my version 3.0. It uses sawtooth. We do a research online and in my school. Here are the data we collected from the survey. And this is the making process. First is identifying and understanding part. I sent out questionnaire in my school and online. The second is the ideating and designing part with my teacher and my friends. Next is the building and testing part with my teacher. These are my different versions. Last, it's the communicating part. I attended SciC 2019 China. The judges gave me some good feedbacks and also some feedbacks that can make my cup better. So this is the model, 3D model. This is my sketch. That's all. Thank you.
Very good. Thank you. Thank you very much. Dave, I love the fact that you talk about all the different prototypes and making it even better. So this is your 3rd prototype. Do you think there might be a 4th version? And if so, what would you make even better on the new cup?
I'll make even better if in my version 4.0, I'll make it better on the family that's greater than 3 members, like a 5-member family, just like Melissa.
Dave, we've been getting comments on YouTube, and there's people around the world who want to buy this. I'm serious. I have the names of people in Ukraine who are very interested in buying your cup. When do you think you might be able to start selling it?
I actually really don't know, but I'll soon ask the factory and manufacture it.
When you do, you have to let us know.
Pardon, please?
When you start to sell, you will have to let us know that it is now available to buy.
Actually, I really don't know.
Okay.
Sorry.
Good.
Maybe 2022.
Okay, good. That would be very good. That would be very good. Okay. Thank you very much, Dave. This was very good. I really appreciated your presentation. You have done an excellent job with your cup, but also with your presentation skills.
Thank you.
It's very good, very professional. I don't know. He's done so much already. I don't know. Daisha, we're 15 minutes ahead, and I don't want to hold anybody up, but I don't want to get too far ahead. You want to show the Joe Lennox movie this time? You can do it right.
Yep.
Because I have messed it up at least 4 times already. So.
Well, let's quit doing that. All right. So Joe Lennox is a solar system ambassador, and he has shared his story that includes some challenges with his health. And he has written all this down, and then we have used a professional voice actor to recreate this using photos that Joe has actually taken pictures of. So we will start this now. And let's see if I can get it big. Well, I don't know what it's doing there. Hang on just a second. I think I did the same thing that
Oh, you know, Daisha, I never had any trouble running this. I don't know why you're having so much trouble.
well, I think that's telling a story.
For
But
me, it ran perfectly.
February 20, 1962. I sat in my 4th grade class and listened to the radio broadcast, no classroom TVs in those days, of astronaut John Glenn's launch into orbit that was being heard through the school's intercom system. I clearly heard Glenn's vibrating voice announce to the world, "The clock is operating, we're underway." I never imagined that in those few brief moments, my life would change forever. From that moment on, I became totally enthralled with spaceflight, and it became a passion that still burns in me today. I couldn't get enough about spaceflight and astronauts, so I began creating a collection of space memorabilia that is today referred to as the largest and most complete private collection of space artifacts in the country. It includes more than 60,000 clippings of every American human spaceflight in chronological order, kept in over 200 volumes, totaling over 32,000 pages. Over 800 books, medals, audio and videotapes, DVDs, stamps, records, movies, slides, toys, puzzles, jewelry, clothing, models, and many other types of memorabilia play large roles in my museum. I have received personal correspondence from more than 750 astronauts, NASA managers and administrators, government leaders, space authors, and media personalities. More than 200 spacecraft contractors have sent me thousands of pages of spacecraft and hardware documentation, along with over 70 actual pieces of hardware. I witnessed the launch of Apollo 16 from the VIP reviewing stand thanks to the late George Low, then NASA Deputy Administrator, as well as the launch of STS-133 from the same location. Several contractors have given me personal tours of their facilities, and I have received 2 very special upfront and personal tours of Kennedy Space Center that included going up on the Space Shuttle launch tower when Discovery was awaiting launch and sitting at the controls of Shuttle Atlantis while it resided in the orbiter processing facility. Those adventures were thanks to Mike Lineback, retired Space Shuttle launch director. Talk about a kid in a candy store. NASA Lessons Learned Program Manager Mike Sinelli is a trusted friend who provides advice, guidance, and some very special mementos. Is anybody more fortunate than me? I attended LaGuardia Aeronautical College with the goal of becoming an aeronautical engineer and ultimately becoming a NASA flight controller. As with space missions, the original flight plan doesn't always go as expected, so backup missions are vital to success. After being in college for about 1.5 years and loving every minute of it, I woke up one morning to the discovery that I was going blind. It's not that it was dark and I was sightless. It was blurry, really blurry. When the eye doctor put 2 fingers 2 feet away from my left eye, I couldn't tell that there were 2 fingers there. I was diagnosed with keratoconus, a disease that deteriorates the cornea, the part of the eye that creates focus. It usually affected men in their late teens to early 20s, and both eyes would eventually go the same route about 1.5 years apart. Dr. Levy was right on the money. Thanks to medical science, I successfully received 2 cornea transplants about 1.5 years apart, and my vision was restored, but not well enough to see the small drafting and engineering data I needed for school. It appeared my space dreams were doomed. At this point, I was 23 years old and wanted to marry my wife, so I went down to Wall Street and got a job in the banking industry. My love of the space program and my collecting were still very much a part of my life, however. I read everything I could get my hands on about space science, history, and technology, and kept adding great items and new scrapbooks to my ever-growing collection. And then out of nowhere came the backup mission.
When my son began going to school, I approached his teacher. To this day, I really don't know what made me do it, and said that I knew a lot about the space program. Would she like me to come into her class and give the students a presentation? She jumped at the idea, so I went in with cardboard boxes filled with models, memorabilia, and all sorts of items. The kids seemed to really enjoy it. I kept their attention and didn't embarrass my son, so it seemed like a successful experience. The next year, she asked me to come back in, and my other son's teacher asked me to come to her class too. One thing led to another, and word got around about my programs. Today, I give about 50 presentations a year on many, many topics concerning space science, history, and technology. I was even on the staff of the Gifted Child Society, where I taught 3 10-week classes to students of all ages. I taught those classes for over 15 years. I am now retired from the banking industry and can dedicate much more time to my space presentations. I had a very successful banking career, but teaching about the space program is my true calling. I presented schools, scout groups, museums, summer camps, civic groups, libraries, senior centers, and many other venues. Now things have come full circle and I go into my grandson's classrooms. As you can see, I actually did reach my goal of being a part of the space program, and I honestly think I enjoy this more than I would have as a flight controller. I really love teaching and seeing the excitement in the children's eyes when they hear an amazing fact or see a very special memento. Some NASA space members support my efforts with special items, documentation, and teaching aids. I close my presentations with a short version of my vision story to show the participants, especially the children, that you should never give up on your goals and dreams, because even if something bad or unexpected happens, you can still reach your goals. Maybe not in the original way you planned, but alternative plans are sometimes much better. As I have made myself an expert in space history and am very well versed in the science of space, I also strongly stress the importance of reading. Everything I learned from reading, and the children can make themselves experts in any subject they want through the power and joy of reading. My collecting priorities have changed dramatically over the years. Instead of collecting just to expand my collection, now I want to receive documentation and special items so I can use them in my teaching. Today I use PowerPoint presentations, a computer projector, foam-filled suitcases for my models, and special carrying cases for everything else. Just as the space program has, I've come a long way. I have told this amazing story about my eyes and my teaching, along with how my collection was created, including many seemingly crazy ideas, and a light history of the human space program in a book I had published titled Vision for Space. I have also written a children's book teaching space science, history, and technology titled The ABCs of Space Exploration. I am a member of the National Science Teachers Association, the National Space Society, the Planetary Society, and the Space Foundation. I am a former member of the Selection Committee for the Astronaut Hall of Fame and a past president and director of education at the New Jersey Aviation Hall of Fame. I have appeared on NBC TV, been broadcast on Canadian Broadcasting Radio, and have been the subject of several newspaper articles. The joy I have received from collecting, teaching, reading, and writing about the space program is immeasurable. My wife of 44 years and my sons and grandsons support my efforts in countless ways, and their pride in what I have accomplished is among the greatest aspects of my life. I have been a very, very lucky man in so many ways. I live a normal life today in relation to my vision. I drive, bowl, play baseball with my son and grandsons, and can read with no problem. Those small details in print still cause problems, but that is a very small price to pay for the fabulous life I've been privileged to lead. So as you can see, my life has been one astronomical ride, and it all started on a cold winter day when I was only 9 years old. Just amazing.
Ah, fantastic, fantastic. Just shows what's happening in the world, and you never know the connections. Speaking of what's happening in the world is turning, and it is now a decent hour in the morning. It's early, but Canada is waking up. And we have two wonderful Canadian presenters, and this is Tricia Berry and Ross Ledbetter, and the universal design for career education. Education Support Services, Department of Education and Early Childhood Development. And their presentation is going to be innovating Education for the Future. And Tricia and Ross, I know you're here, and if we can get you up.
Hello, Jake, I'm here. Julie?
Ah, great. And
They're here.
And Tricia's here too, somewhere.
They're here. Don't worry.
Hi, good morning.
Hello.
And I see your presentation.
Oh, good. You can see it.
We can see it, and we see you. This is wonderful.
Wow, it's all working. Amazing.
For the moment.
Good start.
This better be a good presentation because you're making me feel bad by having no technical problems.
Oh, well, I'm sure I can pull something off here for you.
Please, Ross and Tricia, please go ahead, introduce yourselves, and it's your platform. Thank you.
Okay, well, thank you very much for inviting us. We're really excited to share a few things with you this morning. So talking about future ready learning and our couple of innovative initiatives happening here in New Brunswick. I am Tricia Berry, and I'm a learning specialist for Universal Design for Career Education with the New Brunswick Department of Education and Early Childhood Development. And I'll let my co-host introduce himself.
Hi, my name is Ross Ledbetter, and I used to work at the Department of Education. And while I was there with the Assistant Deputy Minister, we set up, and with the backing of the Ministry of Education, we set up this really interesting not-for-profit, iHub Learning, that I'm now the CEO of. And my job is really to support innovative projects sort of from beside education, but with a mandate to serve public education in our province. So it's a really unique position, and it affords us all sorts of latitude that is creating some really unique opportunities, which I'll talk about in my part of the presentation.
That's great. So two future ready innovations we want to talk about today are what I'm going to talk about first, a program called iCubed, Innovate, Invent, Investigate, and how we have adapted that here in New Brunswick. And then Ross is going to be talking about customized knowledge frameworks and the success factor skills. And hopefully we have a couple minutes for some questions and answers at the end. So I'll jump right in. So in my role at the Department of Education, I was really looking at career education and why change. And it's not even really a why, it's that we need to change. So it very quickly became apparent that education systems worldwide were looking to build on promising career development practices to help prepare young people for future success. And what we know is that we can't keep preparing young people the way we always have. The world is changing rapidly. Look at the situation the world is in right now, and we don't really know what it will look like in the future. But what we can do and what we do know is that we have to look at innovative ways to prepare youth for future success and future job requirements. And one of those things being that we have to shift from a jobs economy to a skills economy and really focus on what learners need for future economic, social, and to respond to future economic, social, and technological change. And so moving from more the credentials to more of a focus on the importance of skill development. And so we identified in our work here at the department what are the best practices for career education. And we feel these are practices that can be incorporated in K-12 across the curriculum in all of our schools, and they will really help our students to prepare. So these are the 6 best practices that we have identified and that we are intentionally integrating across our curriculum K-12. And so one example, the one I'm talking about this morning, is iCubed. And this is Investigate, Invent, Innovate. And it's an experiential learning program that the Learning Partnership developed. And we have partnered with them to use this in our middle schools in New Brunswick. But in doing so, we collaborated with them to adapt the pre-existing program to incorporate this this career development or career education component and these best practices. So they all exist now within the iCubed program. So lastly, the program, as it always has been and still is a program where students identify problems in their daily lives and in the real world. And they use everything from experiential, personalized, entrepreneurial, project-based methods to invent products or processes to solve those problems. And they do this through their learning in all of their classes. And so through participation in this, students develop an understanding of many things. But what I feel is really innovative and essential for our middle school students is that they are really making the connections between their learning, what they're learning in their different courses or curriculum, to the real world. So it's about making that connection, and which then in turn increases engagement. But students learning through these experiences will develop those skills we're talking about, the essential skills, the global competencies, the social emotional skills that we know they need to prepare for a variety of pathways as they move forward, but also for their own growth and wellness. And so we've also been very purposeful in including modern career development practices, our best practices into the iCubed program so that students can really dive deeper into their learning and those connections to where they're going, maybe work or post-secondary. So that's just a small glimpse into the program and how it applies to our career development strategy. And with that, I will hand it over to Ross.
Perfect. Thank you, Tricia. So my focus and my great interest is in how it is that we acquire, create, develop, deepen, and then convert knowledge to use. So when I was hired to work at the Department of Education here in New Brunswick, it was to help create a program where we get students into skilled pathways while they're still in high school, and so that these students can actually graduate and still get the meaningful graduation diploma and so on, but do it in a way that might be different from their other friends or classmates down the hallway, sort of thing. And what we focused on was the development of skills. So the development of the 9 essential skills. In Canada, we have 9 essential skills that define over 40,000 occupations, skilled occupations. And so we use that as a kind of a base, as an engine, in order to create this program where students would go into a very different type of a classroom in the middle of grade 10 or beginning of grade 10, and then take all of their learning towards a pathway. So if a student wants to become a chef or an engineer or a welder or whatever it happens to be, we tried to create pathways so that they could get directly to college and have a lot of experiences when they got to the door at college. So that is kind of this coupling of skills and experience was what that program was built on. And what's really interesting is that we've used that then to create what are called innovative personalized learning centers across the province. And it's all of this very sort of hands-on, skill set oriented, skill development oriented approach. And what we found is that, and this is why we have these two icons on the slides here. What we found is that during this time of remote learning, students that have learned these processes are actually doing really, really well and are able to continue on with their own learning. And Tricia, if you could put it to the next slide. So look at the conveyor belt at the bottom there. That's kind of one of the ways that I describe it, is this knowledge framework that we've created with students by teaching them. So you have the teacher, facilitator, coach, and you've got the learner, and they both learn and understand together this mechanism. And I sort of think of it as a conveyor belt that goes both ways. This mechanism of how the students learn how the essential skills work, how to understand their own learning in terms of those essential skills, how to reflect on their learning, how to evaluate their learning, how to report their learning, is a very, very tight sort of a package of, it's a framework, it's a conveyor belt, it's a means of communicating with one another. So what we're finding is the teachers that are at home right now, and the students that are at home right now, they're able to connect, whether they do it virtually through the video or if they're just on the telephone, and talk about the students learning and where they're going next. And it's almost seamless because they have this, what we're calling a customized knowledge framework. And because it's adaptable to the space, it's portable, it's customizable, and it's founded on something that's common to both parties. So part of what I do in iHub is research for education. I couldn't have done this research without this very strange and challenging COVID space that we have. And for all of despair and sadness that comes with that, there is at least something good that comes out of it in terms of our research, and we're understanding that. And then the second part is the success factor skill set. Really, that's a combination of the essential skills, essential learning skills, and the global competencies. So very much the problem solving, creative thinking, self-starting types of competencies that we know students need to have, and that the education system hasn't been traditionally designed to support. So we're kind of creating a little bit of a tension, a good tension by talking about these things in our schools here in New Brunswick and across our system. Next slide. Yeah, so we just did some research, and I interviewed a whole bunch of teachers right across our province. Province isn't really large, but it is a good sample set. And I asked, not what's not working. What's not working is whatever it is. What is working in this remote learning space? And there's four things: the pre-existing learning frameworks, anything that has a pre-existing learning framework, whether it be the essential skills students or somebody from an IPLC, the Innovative Personalized Learning Centers, or some other types of projects. What's working is that the space is highly adaptable, and it's there's all sorts of learning activities can take place. And there's the asynchronicity of space and time. So while sometimes you meet directly with the student online, it's okay to say, here's your work, and it's okay for the student to deliver it later, and so on. And then, of course, authentic experiential learning. That's very much working right now. And I actually have some other research that I can't share today, but we're looking at that. And it's the project-based and problem-based and challenge-based learning that is really working in this space right now. And of course, one of the things that surprised me actually that's working in this space is teachers are able to, without a lot of distraction, share and collaborate and build relationships with their students. And so that's been a very positive thing as well. So in summation, we're really looking at, with iHub Learning, we're looking at how is it that we can pair skills and experience with reflection and formative assessment and create these learning engines that really, we may be operating in a hybrid space coming up here where some students are at school and some students are home, and maybe they switch, and we don't know. So we want to try to create these things that work in all these different spaces. And with some good fortune of essentially luck in some ways, we've began to understand that this works in those spaces. So that's me. That's Tricia. Any last words to say?
No, unless there's any questions, I think that's a really good snapshot of where we are. It's great.
Well, this is wonderful. This is fantastic, and we all know that New Brunswick is the leading province in Canada, and we all know that. But
of course,
well, we know. I mean, that goes without saying. I'm not saying.
Thank you.
But the question is, the Learning Partnership is a national program. So are some other provinces following your lead?
Well, that's a good question, Jake. So we obviously do take our Kids to Work Day, which is the Learning Partnership's national program. And in taking on this project this year with iCubed, we were in a pilot state. So we will be continuing to move forward. It's been a little bumpy because of school closure, but we're going to move forward in looking at the pilot and how we have implemented more of the career education piece. And I think the intent, and I'm sure the Learning Partnership would agree, that they're wanting to look at this pilot and being able to offer an adjusted program to others if they have that same interest.
Great, very good. Thank you very much.
Thanks so much.
Thanks so much.
Thank you for sharing. And by the way, all my comments about New Brunswick were absolutely correct, right?
Appreciate that.
Thank you.
Okay, thank you.
Thank you.
Bye.
Oh, Julie?
Jake?
Yes. So our next.
How are you? We have Nikita here,
Well,
and yes.
Yes, we have two Nikitas, Anika.
Correct.
Yes.
And I think there's a third member, but I'm not sure if that's who else is up here. Fourth member, I'm sorry. I'm trying to see if this other person might be.
He's there. So let me just tell you, I am
okay.
so
Well, that's that. Just all right. Go ahead.
They're all here. They're here. I see them.
Okay.
Okay. I am so excited that you. Let me turn on their videos. Oops, don't want to do that. Here we go. I think we have everybody. Oh, there's one missing. Who's not here?
That's what I was trying to sort out.
There it is. I got it. Mute. Unmute.
Меня показывают. Вот это задержка, кстати.
Смотри в камеру, что они говорите вообще.
Діда, тебе
Так ми замучені.
Ти не замучений, тебе в тебе працює мікрофон згідно з...
Все, працює.
Should be.
Okay. Can we start? Okay.
Hello, students. Is your fourth teammate here?
Yes.
Jake? It's a different name that's here.
Slightly,
so I'm.
Yes, it's slightly different because they're translating from the Ukrainian to
Приветствуйся и потом уходи.
see if we can get the video up. I see them. I cannot turn their video on.
And you know that's the right student?
Yes, but the sound is on. You can speak.
There we go.
There.
The video's up.
Okay, so welcome, Ukraine. So let me just tell you something that may excite you or may depress you. But in 1892, my grandmother left Ukraine and came to the United States. So there is a possibility that some of you are related to me. I just wanted to let you know. Okay?
That's cool, really. Yeah.
Thank you for being excited about that. In any case, this is your presentation, so please go ahead, and we'd love to hear what is happening in Ukraine.
Okay, so I started sharing my screen, like that. So can we start?
Yes, we see your screen.
Yeah. So Nikita, you can start.
I can start?
Yeah.
I can start?
Yeah, you can start.
Okay. Our team, Fulcrum, consists of Nikita, Nika, and Zhenya. For us, creating and developing is way to success and turn around the whole economy of the world. Today, I want to introduce you our new invention, Unikittle. This is universal base, which you can use like a kettle and make tea or put on it hot plate and use like a hot plate to make to fry eggs or anything else. Unikittle is universal platform for all kitchen appliances. Using Unikittle, you will solve a problem of a contained space and problem of many cords and electric outlets. We decide to provide the concept using hot plate. Женя.
Work on this device for about 3 months, and during that time we have 3 prototypes. The first version of prototype has large dimensions and overheating of the case. Therefore, subsequent version have become smaller, and the teeth attached to the head have become narrower and taller. This version reminded another prototype.
Okay. Okay, Zhenya is done. Nikita, now you. Like.
The device contains this device solved of problem not enough space. Also, the device solved of problem of fast food because you can cook dinner everywhere and everywhere.
So.
The device contains universal base for support with the cable connect with power supply and Axel socket to connect the kitchen or other device. At this moment, an electric kettle and a hot plate. The kettle should be industrial built without any changes to this construction. With built-in overheat protection that turns the kettle off when water is boiled. The plate was made by ourselves. The body has cylindrical shape and made by galvanized iron. The diameter of the body is the same as the diameter heating platform and universal base. Inside of the body contains indicator and digital temperature controller. From the hot plate that we found on the flea market, we take heating element capacity 1 kilovolt. The heating element connects to the body with 3 M5 screws, the screws to the bottom of the device. To provide the ventilation body, the device has prongs that touch the element only in special spots that provides a ventilation of the body.
Our device consists of the universal base, a power cord, a controller, and universal socket to connect various devices. In future plans, improve the base with an audio recorder to record favorite recepts, touchpad, timer, and temperature controller. For now, the base can be connected to electric kettles and hot plate, but we are hoping to expand to coffee grinder, small food processor, and waffle maker.
Yeah, and now I'm gonna tell you about price. We spent about $5 on this prototype because we used the elements we needed from the devices we bought on sale. But after analyzing researchers such as Alibaba or Amazon, we realized that we could use industrial product or buy separate heating element about $5, connecting wires about 50 cents, and like power indicator and thermostat, it's like $1, and make us product cheaper. So in the production, the cost of this prototype can range from $17 to $12. Thank you for your attention. And do you have any questions now?
Yes, I have a question. First of all, can you each introduce yourselves and say your name and your grade and what school you're from?
Maybe they didn't hear your question, Jake.
Can you introduce yourselves? I know people are watching you and everyone would love to see exactly what you look like and what school you go to.
I can start. My name is Nika, and we're all from Boyarka. It's near Kiev, in Ukraine, and we're all from 8th grade and from one class. They're my teammates. It's like we are friends and we're
I just wanted to let you know I've been watching YouTube and there are people around the world who want to buy your product. I am serious. We've gotten some message from Canada and from United Arab Emirates, and they want to start buying this. So are you thinking about moving ahead and maybe actually making something that can be sold?
Yeah, we already think about it, and we just need to just a little bit more time. And now we think about price and how can we solve it. I think we are gonna just go to the like GoFunding or like that. So we can just put some money and it's like so.
Okay. 4 people on a team, that's a lot. How did you divide up? Did you divide up the tasks? One person worry about electrical, one person worry about mechanical, or how did you arrange who does what in your team?
Yeah. So in my team, so some people are just love mechanical things. Some people love electronic and programming. Nikita and Nikita are program, and construction are prototype. I'm manager or like that. So I just like I just okay, I just manager, and my like work it's to look as think about solving our prototype and like that. And Zhenya, yeah, love programming and constructions too. So he have we all so like I manager and the other people's just construct and program as prototype like that.
You had said that this could be used for other appliances, for other things in the kitchen. What else could you do with this? What other things could you make this work with?
Yeah, as Nikita say, now we're thinking about to put coffee grinder and waffle maker, and maybe something to like little oven to just make us product better and make product bigger, so we can sell it to people like that.
Do you eat popcorn in Ukraine?
Yeah, yeah, of course.
Popcorn. I think a popcorn would be very good. A popcorn maker.
Well, so thank you for idea.
Well, that was very exciting. Thank you very much.
So guys, just before you go, I want to let you know that one of our other hosts, Carmine Denisco, he's not on right this minute, but he is from Inventors Launchpad, and he said reach out to him when you have a chance to. He'd like to talk to you. It's called Inventors Launchpad. Okay. You can find him on, you can Google him, and his name is Carmine Denisco.
Okay.
And if you can't find him, your teacher knows how to reach me. You should actually know how to reach me. You all got emails from me. So contact me and I will give you his email information and you can reach him.
And in the meantime, Jake, you can find out which of these young men you're related to.
None of them seemed that excited about it. My great-grandmother's last name was Razumny. Anybody related to a Razumny? The silence is deafening. No Razumny. Okay. There are a lot of Razumnys in Ukraine, and I am related to them. Well, thank you very much. Thank you very much. You were a great team, and we're very interested in that. We are going to have another presentation in July, and I would love to have you encourage your classmates to join us, and they can be giving presentations too, along with your teachers. I tried to get your teachers, and they said we're a little shy. but please get your teachers to join us, okay?
Okay. 1 minute.
Ah.
Oh, that was fast.
Hello, and who are you?
Yeah, that was fast because as a teacher is my mom, and we together play with this project. So hi everybody, it's Lina.
Hi.
You know, I'll bet your mother is very proud of you.
Wow, thank you so much.
And you should be very proud that you have a mother who will help you the way she does.
Yeah, of course.
Very important. Nobody accomplishes anything without their mother. That's one of my experiences. Thank you. Thank you both.
So thank you so much. We're pleased to see you.
Thank you.
Today. So okay, bye everybody. Maybe.
Bye.
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 Find some resumnees.
Jake, do you want to do a video? Since
Can,
we're ahead of schedule still?
We can do that. Well,
your next two guests are waiting, so we could do a video and then we'll get them.
We're a little bit ahead, and I love these are all videos that.
You know how much every time we met, we talked about how far behind we'd end up, and we really haven't been behind at all in the last 22 hours. No, 21 hours.
Well, the reason we're not behind is because I have deliberately gotten all the videos not to work properly.
That might be it.
That's my story. Okay, let's see this. This is another one of Dacia's masterpieces. Okay.
Dacia, thank goodness you did not put calm, soothing music to those, or we would not have made it through the night.
Okay.
Didn't do that on the career videos either.
Well, I am excited. So our next presenters are from Canada, and this is Samara and Sparrow, and they're in 5th and 6th grade. Are they here? Yes, we are. Oh, this is great. Let me unmute Sparrow. Great. So,
hello.
What I'd like you to do is to introduce yourselves, okay, and talk. And your presentation title is Green Scene, a STEM-inspired entrepreneurial venture. Ooh, this is going to sound really exciting. The floor is yours.
Thank you. Hi, my name is Samira. Sparrow and I are the management team for Green Scene. I'm excited to participate in Business Day because I think it is a great opportunity for us to be risk takers and innovators. This year, we are supporting Ecuador and the Pillar of Education. Our company has created a mission statement, logo, company name, along with some research on the charities WE, UNSDG, and UNCRC. We also completed job applications and practice for our interviews when preparing to take on different roles within our company. Each student in our team received by mail a STEM kit to build a prototype of our product concept, which was based on blueprints that we designed on Google Drawings. Each student in our team, we developed a company website on Google Sites to showcase all our learning to our potential customers and community. As a company, we were engaged in the inquiry process for our research areas. The UN Sustainable Development Goals, also known as the UN SDGs, replaced the Millennium Development Goals, MDGs, which started a global effort to tackle many global issues in the year 2000. As a world community, we made a lot of progress, but much more is needed to be done, which is why the UN SDGs were born. There are 17 goals with targets for the world to reach by 2030. green scene is spreading awareness on UN SDG number 4, quality education, and number 15, life on land. Through our virtual reality experience, our goal is to show people where in Toronto pollinator gardens can go. We will also be hoping to build pollinator planters where we will plant bee-friendly flowers and herbs. The UN Conventions on the Rights of a Child were born on November 20th, 1989. Our company is looking at Article 24. As a company, we believe that we need to be advocates for our environment and inform others how they can help. We Organization is a Toronto-based charity that is globally recognized. They believe in empowering communities to lift themselves out of poverty through a holistic, sustainable development model called We Villages. All companies participating in the entrepreneurial venture called Business Day will be spreading awareness and raising funds for We Organization and the Pillar of Education in Ecuador. We developed a VR experience and tour creator for the community to learn about why bees are important pollinators. Cedarville Park is a great place for bees and other pollinators to go. Although it does have a lot of concrete and human-made structures, there are also lots of possible places for pollinator plants. Why are bees so important? Bees are our predominant pollinators, pollinating a third of the food we eat and 80% of flowering plants. Pollination is crucial because many of our vegetables, fruits, and the crops that feed our livestock rely on it to be fertilized. So without it, we could go hungry. Here's Hillcrest Park, Witchwood Barns, and Christie Pits. Now I'm going to pass it on to Sparrow, who will be talking about the design thinking process.
You need to stop sharing.
Oh yeah.
The design thinking process is an iterative process of providing needs and solving problems. The design thinking process is not a linear process. And when you are at one stage, you might go back and change something. It will allow us to create a product while solving a problem. Empathy. Empathy is interacting and with people to find out a common problem. You empathize with them and figure out what they are having trouble with and what their needs are. The problem our company wanted to solve is helping the bee and pollinator population. Define the problem. Defining the problem is when you look at all the problems from the empathize stage and choose which one you want to solve. You find trends and patterns throughout a problem. Then you brainstorm solutions. We looked at all the problems that we wanted to solve, but we narrowed it down to helping pollinators have access to food and helping increase the pollinator population. Iteration. Iteration is generating ideas for a solution to the problem, which leads to a prototype. The ideation stage provides fuel for the prototypes. You might also sketch, draw, or create a digital version of ideas for a solution. We brainstormed ideas that could help the pollinator population, and our idea was to plant bee-friendly flowers so pollinators can now have a habitat and food. We're also creating a VR experience that will teach people how important pollinators are. Each student received a STEM kit to help us build our prototype. Prototype. Prototyping is when you create a prototype of what you want the end solution to possibly look like. You'll most likely be creating multiple because most ideas will not work out. Perseverance is important in this stage because you can't get discouraged if one idea does not work. We are currently creating prototype planters where we'll plant the flowers in a VR world where people can interact. Test. Testing is when you choose your final prototype and get users to give feedback. After you get some feedback, you will create a better prototype. The testing will happen when you're planting flowers and herbs in our garden. And these are some designs for a planter. The first one did not work out, but we eventually designed it into this. We will also be using the Microbit to help test the moisture levels of the soil to ensure our plants are healthy. Our company is planning to use this Microbit to help our pollinator garden grow better.
The Microbit will allow us to see the moisture levels in the water and see whether we should add more or less water. This will help us keep the plants alive and healthy because some plants may need more or less water. The Microbit is very useful in many ways, and we decided to use it to add an innovative twist. And that's it. Any questions?
Yes, I do. That was very good. That's an excellent presentation. You have some good presentation skills. You talked about your first version did not work. And I believe that when things don't work, it's very important to know why. So can you explain what didn't work out with that first version?
Well, when I was first trying to create it, the materials, when I was trying to put it together, it was too big. So it did not hold together and it wasn't stable. But when we went and we figured out ways to make it more stable, like staggering the wood. So that way it's more stable and it doesn't fall over and like break apart.
Very interesting. Very good. So do you planning to move on from here, or are you completely done, or is there another step that you'll be doing?
Well, this is all of our presentation for.
No, I understand. So now you're done. You gave a presentation and now you don't do anything after that?
No.
Nothing?
I don't understand the question.
No, the question is, you've given a wonderful presentation about what you are doing.
Yeah.
Yes? Okay.
Yeah.
What are you going to do tomorrow?
Oh, well, we're going to continue working on business day, and we're going to keep working on our companies and finishing our products and services.
In what way?
Well, we have virtual meetings with our companies to talk about which goals we're supporting, which articles. We talk about building and prototyping and the design thinking process. So we're going to continue with that.
Great. That's what I was hoping for. I didn't want to think that you were done. That's it. Now you're close the book and never go any further. That was very good. Let me just see. There's all kinds of stuff coming on here. Boy, you have fans all over the world. You have no idea. I'm reading some of these comments, and it's very, very impressive. So, I mean, part of the problem, the reason we're doing this is because when you do a project like this, I'm sure your mother says, oh, that was very good. But now there are total strangers who think you are doing an excellent job, and that counts for a lot more. So congratulations.
Thank you.
Okay. Good luck on your next project. Good luck on talking with your partners and making things happen in the future. Thank you.
Thank you.
Thank you for sharing. Julie, do we have our next presenter up?
Hold on a second. I'm trying to figure out something totally different. Give me just a second, please, since we have a few minutes to spare.
Hey, Jake, would you let me do a career video?
Oh, please, of course.
That would be wonderful.
Yes.
All right,
wait, Daisha. It's got to be an interesting one.
Of course it is.
It's an interesting one.
Of course. So this one is going to be good.
Dr. Drizzle, how can health information apps improve our health care? We know that we need to be able to improve the quality of health with ourselves and people around us. So how about creating a technology that could involve gathering medical data without a visit to the doctor? Things that could monitor our temperature, our pulse, and our heart rate by creating wearable pieces of technology that you could embed into a jacket or a hat. Maybe a new feature added to a watch that could monitor seizures. Create a new technology that will improve the health of a friend or family member. First, investigate their health challenges and learn as much as you can about them. and then create a personalized app or wearable device that can make their lives better. Their health depends on you. Hashtag Global Innovation Field Trip.
Great. You come up with wonderful things, I'll tell you. You're like a sponge. You keep squeezing and more stuff comes out.
I am.
Julie, I think our presenters are on board, aren't they?
We do have two presenters on board, but in the interest of staying on time, we're really not quite ready for them yet. I have asked them both to turn on their videos. I am curious, do we have a teacher on too?
Yes.
And can we, while we have 5 more minutes, can I ask where you're from? Can you unmute and tell me where you're from?
Hi, we're from Toronto, Ontario, Canada.
Okay.
And we go to McMurk Junior Public School.
Are you with Jack and Sophia?
I am their teacher. I've had the
Okay.
privilege of teaching Jack and Sophia.
We couldn't, you weren't on my list and I was trying to figure out why were you here? So I do have a question for you. You were able to send in a Q&A asking to be let in, even though you weren't in. So I was wondering how you did that.
I think I clicked on the students present link. Yeah.
Okay. All right. Cool.
Yeah, just so I could present with them as well as a quick opening.
You're absolutely welcome. You're absolutely welcome.
Thanks.
I just figured it was technology going right past me again. And
not at all. I just clicked on their link.
So, Julie, why don't we have them start? Because
I think that's fine.
Okay.
Alrighty.
So here's what I have. 2 of you are in 5th and 6th grade. Okay, I don't know what grade your teacher is in, but looks older, so she's probably 7th grade. And this is the title of this presentation is Inspiration Nation, a STEM-inspired entrepreneurial venture. Ooh.
Hey, so I'm gonna just do a quick intro. So as an elementary teacher, we thought it was really important during this remote learning experience that we still engaged our students in experiential learning. So through the EA program and the Learning Partnership, we continued our focus through STEM, literacy, social studies, so these students could continue their business day journey. And Sophia, you can take it away.
Hi, my name is Sophia. Jack and I are the management team for Inspiration Nation. I am excited to participate in Business Day because I think it is a great opportunity for us to be risk takers and young entrepreneurs. This year, we are supporting Ecuador and the Pillar of Education. Our company has created a mission statement, logo, company name, along with some research on the charity We, UNSDG, and UNCRC. We also completed job applications and practice for our interviews when preparing to take on different roles within our company. Each student in our team received a STEM kit by mail to build a prototype of our product concept, which was based on our blueprints that we designed in Google Drawing. We developed a company website on Google Sites to showcase all our learning to our potential customers and community. The UN Sustainable Development Goals, also known as the UN SDGs, were replaced by the Millennium Development Goals, MDGs, which started a global effort to tackle many global issues in the year 2000. As a world community, we made a lot of progress, but much more is needed to be done, which is why the UN SDGs were born. There are 17 goals with targets for the world to reach by 2030. 193 countries have adopted the UN SDGs into their countries. We are focusing on the UN SDG 3, good health and well-being, and number 4, quality education. We are using good health and well-being because with our bookmarks and homemade Play-Doh, they will have motivational messages on them to support the well-being of our customers. The UN Conventions on the Rights of a Child were born on November 20th, 1989. Our company will be raising awareness on the UNCRC 12. Children have the right to give their opinions freely on issues that affect them. Adults should listen and take them seriously. We believe that by promoting well-being within our community, we will be supporting the health of everyone. We Organization is a Toronto-based charity that is globally recognized. They believe in empowering communities to lift themselves out of poverty through a holistic, sustainable development model called We Villages. All companies participating in the entrepreneurial venture called Business Day will be spreading awareness and raising funds for the We Organization and the Pillar of Education in Ecuador. Here's a tour of our company website. I will be highlighting our mission statement. We at Inspiration Nation believe in supporting the well-being of our customers by designing and creating a variety of products, such as paper bookmarks, homemade Play-Doh messages, with inspirational messages that light up while enjoying a delicious honey-inspired dessert. Now we'll pass it on to Jack, who will be sharing how we use the design thinking process.
Hi, my name is Jack. The design thinking process is an iterative process of solving problems that are grounded in empathy. That is not a linear process, allows you to design and create your product. The design thinking process relates to our team because when we made the Play-Doh, we always had to try new things like how we're going to make our Play-Doh. It relates to well-being because we are writing motivational messages on the bookmarks and on the Play-Doh. Empathy. Reasons not letting me go. Empathy allows you to understand others, especially your customer needs. We wanted to help and support the issue of well-being in our community. We noticed that students in our school community were feeling anxious or not believing in themselves, and we wanted to help. Define the problem. Brainstorm possible situations and ideas. We wanted to support the well-being of our community, so we are designing bookmarks and homemade Play-Doh with inspirational messages. Iterate. It's when you start to think about your prototypes. We decided to create our own Play-Doh since we're all working and learning from home. Our bookmark will also be made from material found at home and will also be attempting to create our own paper. Prototype. You can use any item and it works quickly in any potential situation. We have been testing out different recipes to build our Play-Doh. Test. It allows you to consider the user and iterate ideas. Gives feedback that can improve your idea. Once we did our first prototype, it gave us ideas how to make changes, such as increasing the temperature of the oven to ensure the mold is hard enough, adding less water so that it wasn't so moist, therefore it will get harder quicker. And here we are testing out our Play-Doh recipes and circuit to light up our bookmarks. What the? Oh, wait. Sorry.
You're okay.
Here are our molds, and these are good because you can put them in on your desks in your locker, and you can hang them up on your mirrors to feel motivated each day.
Hey, Jack, can you hold that up?
Oh. It says, be brave. My other one says, be kind. And my bookmark here saying, it lights up and it says, it's hard. It's going to be hard, but hard does not mean impossible.
Jack, can you show us the bookmark, Jack?
Hold it up, Jack.
Nice.
Very nice.
So yeah, we were really lucky and privileged. We ended up having a grant to help support the student STEM builds, and each student was able to receive their own little kit to build their prototypes. So students are understanding that we are in a different situation with this remote learning, and they're wanting to take their ideas from what we worked on before. All of this happened before the March break, and they wanted to continue this journey of trying to support well-being within our community. And congratulations, friends. Any questions?
Oh, yes. Oh, my goodness. Yes. So I have a question. You mentioned about testing recipes. So evidently that meant that some of the recipes didn't work. Can you explain what made some recipes better than others?
Well, I only tested one, but I noticed that, like I said, it was a little bit soft when I took it out. So we have to sort of make it a little bit hotter in the oven to make it harder and not put a lot of water because it would also get moist.
Ah. And you had mentioned that you're doing this in conjunction with Ecuador, right?
Yes.
Why Ecuador? Not that I'm just curious. There's so many countries in the world. What drew you to Ecuador?
Well, we were looking at the WE organization, and we were looking at the countries that they help, and we were like reading through all of them, and we thought like, since we did Tanzania like last year for a business day, we try something new and do just Ecuador to help a different place in the world.
So did you research Ecuador and see if maybe they didn't need your help?
We so for one of our projects we did research Ecuador, and like we had inquiry questions, and we just researched different things about them to know more about it.
So the year is probably almost up, isn't it? I assume you're going to be doing this next year. At least your teacher is, if you move on, right?
Yes.
What do you have any countries that you're investigating or thinking about now?
Are you asking me?
Who's in charge?
So what happens is at our school, we support WE organization, and we also have a social justice club. And in conjunction with the social justice club that we have, we look at the countries that WE organization is supporting, and then they research all the countries, and they basically tell me who they want to help and which pillar within the model of sustainability they want to target for that school year. So some years it's the same and some years it's different. I kind of follow what the student's path and what they kind of want to do.
So there's a completely different organization that does the investigation and identification.
Yeah.
So I have a question then. At some point, do the two organizations talk and they say, we selected this country, and the other organization says, and here's what we did?
I'm not sure. I think WE's philosophy is they try not to spread themselves too thin. So I think they're in about 5 countries around the world. So I think it's Kenya and Tanzania and Ecuador and Haiti, and I'm totally forgetting another one. And so they put together the model of sustainability, and they have these 5 pillars within each of those communities. Right. And so what our students will do is we'll look up at the countries that they are supporting, and then we'll pick the country and then one of the pillars to support each year.
But I would think that the people who are doing the investigation and identifying the countries would feel very good if they knew that their work resulted in something that was helping that country. I mean,
absolutely.
Have your students, I think they give a wonderful presentation, and have them give a presentation back to the other group that suggested Ecuador.
Yes. Usually if we were in school and when they would present their business day companies, we is actually based in Toronto, and representatives from the organization usually come out and see what the kids have been doing. Because the other class who's also presenting, they presented yesterday, collectively the 6 companies have different missions and different company concepts, but ultimately they have one goal to support one country and one pillar. So yeah, we're very lucky that we're in Toronto and that the WE organization is not far away from us.
But I know you used to do it in person, but I think they're online.
Yeah, no, I think that might be a great idea.
I just think the people would love to see that how our work was turning into something, that was actually beneficial.
Absolutely. I will totally reach out. Thank you for that suggestion.
Well, but here, wait. My advice is not free. Okay. So if you decide you want to do that, you have to send me a link so I can watch it.
Absolutely. I'm not going to reach out. My managers will be the ones that will be sending out an email to reach out.
Okay, tell them I would love to see that, and I know other people would too. We can promote it and tell people around the world to come and watch this and see what your young students have done. This is wonderful.
Thank you.
You should be very proud of them. I'm sure you are. I'm sure you are. Well, this is great. This is wonderful. Thank you very much. Thank you. Thank you. Julie, do we know if our next group is up?
We do know
Oh,
Claire Evans is going to be next. I think we have time for a short video. We have 5 minutes before Claire comes on.
Yes.
Thank you.
Thank you for the
Thanks, Jax.
opportunity.
Thanks, Sophia.
Okay. So I will run one more and then we will hear from Chile.
Jacob, do I leave and then come back for the next presentation?
Well, you don't have to leave. What we're going to do,
Oh.
we're going to turn you into an attendee.
Okay, and then I will. And my other,
see
my
it,
other,
you'll see everything. You're not going.
yeah.
anywhere.
Oh, my other group is presenting at 10:15.
Then we'll turn you back into
game
a
on.
presenter.
Okay, perfect. Thank you. At
And,
10:15.
and if we don't, just send us a message and say I'm still here. You know, and
Okay.
we'll do it. Okay.
Perfect. Thank you. Sorry.
Thank you.
Okay. So let's see.
Hey, Jake, real quick too, before you start that, if you turn off our videos, we can't turn it back on. So don't turn off our videos.
I won't turn off your
You
video.
can turn off guest videos when they're done, but if you turn ours off, we don't have the power anymore. We want the power, you know, all the power.
Okay.
Yeah, actually, if you'll let me do a career one, let's do a student host one because we need to.
Go ahead. Go ahead. That's great. Do that.
Oh, we haven't done that in a while.
Please, please do it.
All right. So we are looking for students to help us host this next event on July 9th and 10th. So students, take a look at this Career STEM Challenge and see if you can do this for us.
Hey everyone, this is Dr. Drizzle and welcome to the Global Innovation Field Trip. We're having a lot of fun today and we have some great hosts, but we're interested in finding some new student hosts for the next one in July. Are you ready? Do you think you can do that? All you have to do is find a topic that you're passionate about and speak on it for 1 to 2 minutes. You can interview a family member, a friend, or reach out to someone that's an expert in the field that you're talking about. We want you to film it horizontally and send it to globalinnovationfieldtrip@gmail.com. You just might be the next host on our field trip in July. Good luck.
You know, Daisha, I love being a host and being part of this program, but I think I would love it even more if we were all replaced by younger students coming.
I was thinking about 23 of them because then we can open up for a half hour, close for a half hour, and they could do everything in between.
I think that's a wonderful idea.
I do want to assure the students that for this next one, that's not what's going to happen.
That is true.
Several videos, and we will let you have small segments where you can introduce our guest speakers, and we'll talk you through it. We'll take you through the technical part of it, how to mute people and start cameras. We'll let you be on the front side of the camera and behind the camera. So please make sure that you start sending those videos as soon as this Global Innovation Field Trip is over.
Excellent. Okay, our next.
And Claire, I got your note here, so I'm bringing them in now. Okay.
Okay.
Oh, we're missing some students. Okay, Claire. So
Yes.
Claire is from Chile, and she has an incredible program, Yo Invento, and you are the director of this program.
I am the academic director, yeah.
So, Claire, the platform is yours.
Okay, thank you very much. And hello, good morning.
Hello.
Thank you very much for having us on the show. So I'd like to tell you a little bit about the Yo Invento program. We've got a series of short presentations today, so we'd like to present from the different perspectives, the different players involved with the project that we're doing. Just to give you a little bit of background, a few years ago, I was working on a project looking at the school-wide enrichment in schools in the region. And I had good fortune to meet Dr. Joseph Renzulli. And he told me about the Invention Convention programs that they have in Connecticut. And it just hit a chord with me. I thought it was something really great. And I would love to try and replicate that model here in Chile. And so I connected with the Faculty of Engineering at the Universidad Austral de Chile. And together with the prototype lab that they have, the Leufu Lab, which is a laboratory of innovation and prototyping, we agreed this would be a great way to connect, to reach out to school children in the region and to really help them develop skills in STEM, really hands-on, practical way of working in a STEM project. And so that's what we did. And I'm going to share a presentation with you now to tell you a little bit more about that.
Karen, what is your last name?
Karen Mercado. So can you see that?
Buenos días. Buenos días.
Yeah, yes, we can see it.
Okay. All right. So just to give you some geographical context, Chile is a very long country, as you can see, and the Los Rios region is in the south of Chile. And we are concentrating on schools in this region. We're working with 7 different communes and schools. And I'm actually based in Valdivia, which is where the Universidad Austral de Chile is based. And so that's kind of the base where we work from, but obviously we have schools in the whole area. Yeah, I'm gonna present a video which shows a little bit more information about the work. We actually started last year, so we've been running the project for 1 year. And this video shows you the work that we've been doing.
Yo Invento Los Ríos es un proyecto presentado por la Facultad de Ciencias de la Ingeniería de la UACH, dirigido a estudiantes de educación básica del segundo ciclo. El objetivo principal es de proporcionar a los estudiantes las habilidades y conocimientos que necesitarán para enfrentar los desafíos del mundo de mañana. Eso significa trabajar, por ejemplo, la creatividad, resolver problemas, el pensamiento crítico y sobre todo de trabajar en un ambiente multidisciplinario. Nosotros trabajamos en las disciplinas del STEMI. Esas son siglas en inglés que significa ciencias, tecnología, ingeniería, matemática, innovación y emprendimiento. El curso Yo Invento está dividido en 2 etapas. La primera parte es la teoría detrás de la invención, y esta parte los estudiantes aprenden sobre qué es un invento, qué significa inventar, quién es el inventor o inventora, qué es el ciclo de vida de un producto. En la segunda etapa, los estudiantes exploran el proceso de diseño de la ingeniería. Y en esta parte tienes que seguir los 7 pasos de este proceso. Entonces empiezan en la identificación de problemas, por qué quieren resolver esta problemática específica, idear como soluciones para esta problemática. Tienen que diseñar un producto, un invento que podría solucionar esta problemática. Luego tienen que fabricarlo, tienen que probarlo, tienen que volver a idear, diseñar, fabricar si es que hay errores en su prototipo, si no funciona, etc. Y bueno, el último paso es donde tienen que comunicar su resultado. Así que este paso es muy significativo porque sería en la feria de eventos regional, que es la culminación del proyecto. En esta instancia los estudiantes tienen que mostrar su prototipo, tienen que presentarlo con un pitch frente a un jurado. Y bueno, necesitan un panel de exhibición para mostrar fotos, gráficas y bueno, el proceso de su trabajo que hicieron durante el año para llegar a este prototipo.
En Neofulab sabemos que es posible con jóvenes de la región hacer desarrollo de alto nivel tecnológico y queremos promover eso en jóvenes de colegio, dándole la oportunidad de conocer y familiarizarse con el proceso de innovación, de desarrollo, proceso creativo y multidisciplinario. Entonces, para nosotros es muy importante organizar un programa como Yo Invento para preparar la generación futura a estos desarrollos y a los problemas que nos van a venir como sociedad.
Mi proyecto se trata de una placa que sirve para reflejar los rayos de luz. La idea es que es para que no se sobrecalienten los techos de las casas.
Que ellos sean capaces también de visualizar una problemática y dar respuestas a esa problemática, creo que ha sido un trabajo muy intenso y hoy día pudimos ver que los niños estaban muy bien preparados y que de verdad que había un trabajo, digamos, sistemático con el tema del proyecto. Así que muy agradecidos de la Universidad Austral por darle esta oportunidad a una escuela rural, en donde los niños no tienen muchas posibilidades, ¿no es cierto?, de acercarse a la universidad. Ya el hecho de que todo el grupo vaya a ir a la universidad para nosotros es un gran premio.
Okay, so it gives you an overview of what we've been working on. And
Claire, can you try unsharing and sharing? There was a black box that blocked out some of your video.
Oh, really?
That's just from where the Zoom, that's probably where your Zoom people are down there at the bottom.
Yeah.
Ah.
So if you can minimize it by clicking on the little line.
Yeah,
like
I didn't realize you guys could see that.
So
do you want me to show it again? Because that was where all the subtitling was.
If you have time in your presentation to do that. Or we can do it at the end. See if we have time at the end.
Okay. Oh, I'm sorry. I didn't realize that was there.
It didn't really block everything. It only blocked the bottom like inch.
Yeah.
About 5 inches across.
Okay.
Right. That's unfortunate though, because that's where the subtitling was.
It's okay.
Right. Okay. Well, if you have time, then let's show that again at the end. So basically, that gives you an overview of the work that we've been doing. We also run a teacher training program where we teach about invention education, facilitation, project-based learning, looking at STEMI. Obviously, we're running that as an online program at the moment, as we can't do it in person. But we run university visits for the students, where it really gives them the opportunity to come and see the university, to look at the Leofu lab, the prototype lab. They get to talk to the experts, the technicians, and present their inventions and get advice from them for how to continue. They get consulting advice. And then we run workshops for the teachers and for the students in Arduino, design thinking, design of apps, prototyping, and entrepreneurship. So I'd like to pass the ball over to Karen, who is the director of the Colegio Aliwen. Karen's going to present in Spanish, but I'm going to translate for her. ¿Sí, Karen?
Sí. Buenos días a todos. Contarles que como directora he aceptado participar en el proyecto Yo Invento por tener un impacto positivo en el currículum escolar y también por complementar nuestro enfoque pedagógico.
Claire, the black box is back again. Can you make it or go away?
Is that okay like that?
It's small, much smaller.
Now all you have to do is move it up to a different part of your. Keep going. Go higher. There you go.
Keep going.
Perfect.
Okay. So as a director, I have accepted to participate in the Inventor project because it has a positive impact on the school curriculum and it complements our pedagogical approach as it offers a space for our students to benefit by discovering new experiences and knowledge.
Ya que ofrece un espacio para nuestros estudiantes, para que nuestros estudiantes se beneficien en descubriendo nuevas experiencias y conocimientos, permitiéndoles la exploración y la proyección de sus ideas. A nuestros docentes les permite incorporar nuevas prácticas pedagógicas y también herramientas para la estimulación del pensamiento crítico, el aprendizaje-enseñanza basado en proyectos y la innovación y la investigación.
Allowing them to explore their project ideas, it allows our teachers to incorporate new pedagogical practices and tools for the stimulation of critical thinking, project-based learning, innovation and research.
Además, el proyecto Yo Invento se desarrolla en el marco de colaboración y vinculación con el medio a través del trabajo con docentes en espacios de la universidad.
In addition, the Yo Inventor project is being developed within the framework of collaboration, and the project has a strong link with community outreach through work with teachers in the university.
Este hecho, sin duda, fortalece nuestras redes como centros educativos y propicia el intercambio de ideas, especialmente las áreas como la ciencia, la tecnología, la ingeniería y las matemáticas.
This fact, without doubt, strengthens our networks as educational centers, and it encourages the exchange of ideas, especially in areas such as science, technology, engineering, and mathematics.
En tal sentido, las perspectivas que surgen de la conexión con profesionales del área académica universitaria y proyectos como Yo Invento nos sitúan a la vanguardia en materia de educación científica en el contexto escolar.
In this sense, the perspectives that emerge from contact with professionals at the university and projects such as Yo Invento put us at the forefront of science education in the school context. Thank you very much, Karen.
Muchas gracias.
So I'm going to continue showing a video of two of the teachers who work on the Yo Invento project who started last year with us. And they are from the Rio Bueno school in Rio Bueno called Pamparios.
Hola, nos presentamos. Mi nombre es Guillermo Poblete Arias, soy profesor de Educación Física y Salud de la Escuela Pamparríos.
Hola, mi nombre es Nadia Ramírez Martínez, soy profesora de Historia, Geografía y Ciencias Sociales de la Escuela Pamparríos, ubicada en la comuna de Río Bueno, región de Los Ríos, Chile.
Para nosotros, el participar en proyectos Yo Invento Los Ríos, que es presentado por la Facultad de la Ingeniería de la Universidad Austral de Chile y Telefónica del Sur, ha significado un gran desafío como profesionales. El incorporarnos en esta área nos ha llevado a jugar a ser científicos, puesto que el buscar soluciones a problemas típicos de la sociedad nos ha llevado a la posibilidad de desarrollarnos junto a nuestros estudiantes de la escuela.
El interés por las ciencias tecnológicas partió en el año 2017 con un proyecto Cultura CTI Los Ríos, donde junto a docentes de la Universidad Austral nos entregaron las herramientas para comenzar a trabajar con los estudiantes en el sistema Arduino.
Posterior a esto, en el año 2019, se nos invitó a nosotros, como la única escuela de la provincia del Ranco, a participar en el proyecto Yo Invento Los Ríos, donde nuestros estudiantes pertenecientes al taller de robótica fueron introducidos en distintas metodologías para la educación en el invento, que incluye el desarrollo de la creatividad, aprendizaje basado en proyectos y la integración de 6 disciplinas del STEAM, que son una sigla en inglés que es para ciencias, tecnología, ingeniería, matemática, innovación y emprendimiento.
Durante el año 2019, nuestra escuela organizó su propia feria de inventos para seleccionar 3 equipos finalistas presentaría sus proyectos en la gran Feria Regional de Inventos a final de año, clasificando los proyectos de Rufenco, Luicún Puligüen y Gas Detector Assistance.
Bueno, y para los estudiantes de nuestra escuela ha significado una gran posibilidad de trabajar juntos en conceptos de innovación, emprendimiento, diseño y comunicación, vivenciando el proceso de la invención, desde la idea al prototipo, realizando visitas a la universidad con mentores de la carrera de la Facultad de Ciencias de la Ingeniería, y ellos también se van sintiendo visionarios de estar presentes algún día en la universidad como estudiantes universitarios.
En esta aventura hemos contado con el apoyo de diferentes autoridades de nuestro establecimiento. Cabe entre ellos mencionar a nuestro director, el señor Ariel Opi Fernández, a nuestro jefe de UTP, la señora Yolanda del Río, a nuestro jefe de DAEM, don Luis Reyes Farías, y por supuesto mencionar a los ingenieros, el señor Claudio Vargas y a don Rodrigo Roa, a quienes agradecemos su esfuerzo por apoyarnos y confiar en nuestros proyectos.
Muchas gracias.
Muchas gracias.
So that was the presentation from the teachers, and now we have a video presentation from one of their young inventors, from a young boy called Diego. Sorry.
Hola, me llamo Diego Alonso Ojeda, soy alumno del séptimo año básico de la Escuela Ríos de Ciudad de Río Bueno, región de los Ríos, Chile. Desde el año 2019 me encuentro participando en un conjunto de 7 compañeros en un programa llamado Yo Invento, Los Ríos. Clasificando el 2019 con el proyecto de invernadero automatizado Luis Kun Poliwan, de dialecto indígena que significa gotera en la mañana. La idea de tener un invernadero en la escuela era una meta que hace un tiempo atrás se construyó con el fin de cultivar hierbas medicinales para la enfermería de la escuela. Si bien en muchos invernaderos con recolección de agua lluvias, estos no poseen un sistema de riego automatizado bajo el sistema Arduino. Durante la temporada escolar, el invernadero es regado de manera manual, pero cuando llega la temporada de vacaciones, el invernadero se queda sin riego, afectando el buen crecimiento de las plantas por falta de riego y temperatura. Mi escuela tiene talleres. Yo participo en el taller de robótica, en el cual nos enseñan a usar el sistema Arduino. De ahí surgió la idea de usar este sistema porque tiene múltiples funciones aplicables para el riego automático para el invernadero. Nuestro proyecto de invernadero está en proceso aún, pero los materiales utilizados hasta el momento son Arduino 1, cables, protoboard, pantalla LCD, estanques de agua, aquí iría el panel solar, sensores de humedad, sensores de temperatura, mangueras para su regadío, bombas. Bueno, está en proceso aún, pero en la construcción hay una base de melamina que simula ser el suelo. Se usó PVC conduit naranjo para hacer el esqueleto de la estructura, láminas transparentes para revestirlo, el exterior del invernadero, amarras plásticas de sujeción, mangueras para su regadío y también para recolección de agua, bomba de agua, maceteros y los estanques. Mediante un software Arduino se realiza la programación generando un script y se carga la placa Arduino con todas las funciones para mantener eficientemente un clima interno adecuado para la producción. El sensor DHT11 se encarga de medir la temperatura al interior del invernadero. Un sensor para medir la humedad del suelo, un extractor que iría aquí, un extractor de calor, una pantalla LCD 16x2 para la información, cables DuPont para realizar las conexiones, un panel solar que también iría por aquí para la obtención de energía, estanques para recolección de agua lluvias y bomba de agua para el riego. Su bajo costo de implementación es una de las principales razones porque es aplicable a gran y pequeña escala. Nuestro proyecto es innovador por el uso del sistema Arduino. Ayudaría a optimizar el tiempo, reducir esfuerzo y aumentar la producción, contribuyendo a una sociedad más cercana a la tecnología y preservando áreas verdes y medio ambiente. Se elaboró una encuesta dentro de las actividades propuestas por el programa Yo Invento, recolectando información complementaria para nuestro proyecto.
Okay. And now I'd like to present Javiera, who is going to talk about her invention. Okay. Javiera.
Julie, I'm trying to unmute her and I can't. Can you unmute Javiera?
Let me try. Yep, there we go.
You got it. Okay.
Javiera, do you see that little black box? Can you, there you go. Good job.
Yeah. Start?
Yeah, go for it.
Yeah. My name is Javier Olivares. I'm from Chile and I love to read books of many types. Today, I'm going to present my invention. My invention is called Reflector OV. It's an insulating panel made from recycled Tetra Pak. The problem that my invention solves is the need for a house insulation that works well, is inexpensive and does not harm the planet. My invention solves the problem because the insulation is made from recycled materials, Tetra Pak, milk or juice cartons, which are easily available in schools and or institutions, so it considerably lowers the cost. It is sustainable and helps the environment. The invention is made of milk boxes, pressed wood, and anti-moisture glue to join the two. This invention is to keep heat inside the house in winter, or to prevent heat from entering through the winter in southern Chile. And I want to find a solution that was good but cheap at the same time. It's made to be placed between the walls. This invention is made for any type of construction, be it a school, a private house, and other things. I did an experiment to test my invention. I used a light bulb to generate heat, then put my insulation panel on one side and wood panel on the other side as control. I used digital thermometers to measure the temperature next to the bulb and in the terms under the two panels. From my results, I could see that my installation panel works and the temperature of my installation panel was lower than of the control panel. I would like to carry out more tests to see how I could improve further. That's okay.
Thank you very much, Javiera. Okay, so that finishes off our presentations. I'll stop sharing the screen now.
Claire, would you like to show that first video again? This time we can see it with the
okay.
Closed captioning.
Yeah, that would be great. If you've got time, I'll show it again, yeah.
Just make sure we get rid of those black boxes.
Yeah, tell me if they're there. I need to go back to the beginning though. If you just give me a second. I don't know if there's a way of doing it faster.
We have a very low bar for technology. You won't have any trouble doing it better, at least better than me, that's for sure.
Speak for yourself, Jake.
I said better than me. I said that.
Here we go. Okay, this time?
Yes.
Yo Invento los Ríos es un proyecto presentado por la Facultad de Ciencias de la Ingeniería de la UACH, dirigido a estudiantes de educación básica del segundo ciclo. El objetivo principal es de proporcionar a los estudiantes las habilidades y conocimientos que necesitarán para enfrentar los desafíos del mundo de mañana. Eso significa trabajar, por ejemplo, la creatividad, resolver problemas, el pensamiento crítico y sobre todo de trabajar en un ambiente multidisciplinario. Nosotros trabajamos en las disciplinas del STEMI. Esas son siglas en inglés que significa ciencias, tecnología, ingeniería, matemática, innovación y emprendimiento. El curso Yo Invento está dividido en dos etapas. La primera parte es la teoría detrás de la invención, y esta parte los estudiantes aprenden sobre qué es un invento, qué significa inventar, quién es el inventor o inventora, qué es el ciclo de vida de un producto. En la segunda etapa, los estudiantes exploran el proceso de diseño de la ingeniería. Y en esta parte tienes que seguir los 7 pasos de este proceso. Entonces empiezan en la identificación de problemas, por qué quieren resolver esta problemática específica, idear como soluciones para esta problemática. Tienen que diseñar un producto, un invento que podría solucionar esta problemática. Luego tienen que fabricarlo, tienen que probarlo. Tienen que volver a idear, diseñar, fabricar si es que hay errores en su prototipo, si no funciona, etc. Y bueno, el último paso es donde tienen que comunicar su resultado. Así que este paso es muy significativo porque sería en la Feria de Inventos regional, que es la culminación del proyecto. En esta instancia los estudiantes tienen que mostrar su prototipo, tienen que presentarlo con un pitch frente a un jurado. Y bueno, necesitan un panel de exhibición para mostrar fotos, gráficas y bueno, el proceso de su trabajo que hicieron durante el año para llegar a este prototipo.
En Neufurab sabemos que es posible con el gobierno de la región hacer el desarrollo de alto nivel tecnológico y queremos promover eso en el gobierno de colegio, dándole la oportunidad de conocer y familiarizarse con el proceso de innovación, de desarrollo proceso creativo y multidisciplinario. Entonces, para nosotros es muy importante organizar un programa como Yo Invento para preparar la generación futura a estos desarrollos y a los problemas que nos van a venir como sociedad.
Mi proyecto se trata de una placa que sirve para reflejar los rayos de luz. La idea es para que no se sobrecalienten los techos de las casas.
Que ellos sean capaces también de visualizar una problemática y dar respuestas a esa problemática, creo que ha sido un trabajo muy intenso y hoy día pudimos ver que los niños estaban muy bien preparados y que de verdad que había un trabajo, digamos, sistemático con el tema del proyecto. Así que muy agradecidos de la Universidad Austral por darle esta oportunidad a una escuela rural, en donde los niños no tienen muchas posibilidades, ¿no es cierto?, de acercarse a la universidad. Ya el hecho de que todo el grupo vaya a ir a la universidad para nosotros es un gran premio.
Claire, I had a question for you about how many students do you reach?
Last year we worked with about 150 students in 7 schools. Then during the second part of the year, we selected 3 groups that went on to carry on in the second part to actually make the prototype, and there we had 56 students.
Okay.
This year, unfortunately, we had to stop school just when the groups were starting to be made. So we haven't actually got to the point of selecting groups this year or for them to choose the project. But we've extended the project to 10 schools, and we're hoping to reach about 250 to 300 students.
Excellent. Good job. Very nice, Claire. Please tell all of your students and all of your teachers what a fantastic job they are doing. We're very happy that you're part of this. Thank you. Thank you.
Thank you very much, and thanks for having us on the show.
Thank you. Okay, we're a little bit behind, but not too much. And Julie, if you could...
we have all the next guests. They're here and they're waiting.
Looking forward to this. This is great. So if you can... so this is Tabitha Weissengruber and Sawyer Lau and their incredible teacher. I don't see her.
I want you to pronounce her last name or her first name. Is that your first or your last name?
Kamala.
Yeah, Kamala, I'm here. I don't see me on video though.
I see you.
We see you.
Oh, you do? Okay, perfect.
Don't do anything embarrassing.
All right, should we get started?
Yeah.
Yes, please.
Awesome. So we're from McMurray Junior Public School, and I teach a grade 5-6 class. And we thought it was really important as we moved into remote learning to try to provide our students with experiential learning that was connected to science, social studies, STEM, so they could continue their learning journey that they started prior to our March break. And also to give them a chance to become those inventors and risk takers that we know that they are. And wow, I am so impressed with all the stuff and the work they've done after, during this remote learning journey. So I will send it away to Sawyer.
Hi, my name is Sawyer. Tabitha and I are the management team for Game On. I'm excited to participate in Business Day because I think it's a great opportunity for us to be risk takers and young entrepreneurs and young inventors. This year, we are supporting Ecuador in the Pillar of Education. Our company has created a mission statement, logo, company name, along with some research on the charity We, UNSDG, and UNCRC. We also completed job applications and practiced for our interviews when preparing to take on different roles within our company. Each student in our team received a STEM kit by mail to build a prototype for our product concept, which was based on blueprints that we designed on Google Classroom. We developed a company website on Google Sites to showcase all our learning to our potential customers and community. The UN Sustainable Development Goals, also known as the UN SDGs, replaced the Millennium Development Goals, MDGs, which started a global effort to tackle many global issues in the year 2000. As a world community, we made a lot of progress, but much more is needed to be done, which is why the UN SDGs were born. The UN SDGs are 17 global goals to achieve a better and more sustainable future. The goals our company is supporting is 4, quality education, and 13, climate action. Through playing our games, you will learn more about climate action and how you can make a difference. The UN Conventions on the Rights of a Child were created on November 20th, 1989. It is a legally binding international agreement setting out the civil, political, economic, and social, cultural, and cultural rights of every child, regardless of their race, religion, or abilities, so every child can have a healthy and educational childhood. Our company will be supporting Article 31, which states you have the right to play and rest. We are developing a variety of games for our customers to interact with. Reorganization is a Toronto-based charity that is globally recognized. They believe in empowering communities to lift themselves out of poverty through a holistic, sustainable development model called We Villages. All companies participating in the entrepreneurial venture called Business Day will be spreading awareness and raising funds for reorganization and the pillars of education. Here's a tour of our company website, and I will be highlighting our mission statement. At Game On, we will be creating a variety of eco-friendly cardboard games for our customers to be using by reusing reusable materials. We are a game-based company that will be incorporating Scratch, Makey, and Microbit into our game design to give our customers an interactive experience. Now I'll pass it on to Tabitha, who will be sharing how we are using the design thinking process.
Hello, my name is Tabitha. The design thinking process is the iterative process of solving problems that are grounded in empathy for key stakeholders, such as members in our community and customers. It has 5 steps: empathize, define the problem, iterate, prototype, and test. And even though I listed them that way, it's not a linear process, and you can go back and forth between them depending on your situation. Empathy. Through this step, you can get into your users' heads to understand their wants and needs. To us, this step is arguably one of the most important parts of the design thinking process because we wanted to inform our school community on the importance of climate action by developing games, and we needed to empathize with our users to be able to do that. Define the problem. Looking for a problem and the way to solve it. Our company wanted to develop games to promote the importance of play and UN SDG number 13, climate change. We also wanted our games to be eco-friendly. We also created our games from eco-friendly and used reusable materials. Iterate. The process of retrying, redoing, and remaking something until you've got it right. And while I was developing a game on Scratch, I had to iterate a lot when it came to the jumping code. Prototype. Creating a simulation or sample version of a final product/service. During the prototype stages of developing the game, I realized that I had to add in more information about the UN SDGs and climate change. Test. Testing is trying out a product/service and working out all the little kinks. During the testing stage, when I added a start button and clicked it, the characters started clipping into the ground. So I kept adjusting the code on the character and the starting screen until I got it to work. Now I'd like to show you the prototype of the game I've been developing. So in this game, you play as a rabbit, going around the world and helping animals whose lives have been affected by climate change. In this level, you're helping a mother seal find her babies after they got stranded on the other side of an oil spill. So in this part, you have to try to platform across the ice blocks, but then when you touch the oil or when you touch the oil or something, when you touch the oil, a fact about oil spills will pop up. We have also been working on a catapult launcher game, which is highlighted in our website. We believe that by creating a variety of interactive games, our customers can have fun while learning about climate action and the UN SDGs.
Thanks, Tabitha. That was fantastic. As I said, we had the privilege of receiving a grant to help students continue their journey. Tabitha was really keen on coding, so she proceeded looking at using Scratch while Sawyer wanted to build. And so it was really awesome to see these students move forward and design their games. which will be linked as they're playing their games. There's going to be a component where their customers are going to be able to learn about climate change. So awesome job, guys.
I've heard a lot over the last 24 hours, or 22 and a half hours anyway, about the UN Sustainable Development Goals. And it's really cool that there are so many students trying to work towards those goals.
Tabitha and Sawyer, have you told the UN about what you're doing?
Oh.
No, I'm serious. I'm sure they would love to know. Write them a letter, send them a video.
Jacob, you have fantastic ideas. That's going to be next on our list.
I mean, seriously.
No, I think you're right.
You're sitting there in New York, and they don't know what you're doing. They would be so happy to find out that what they have promoted is actually being used and done and benefiting the world. Please. Sawyer, Tabitha, you're going to do that?
Yeah.
Yes. I'm sure you can find the name of the right person at the UN to contact, and they would be very, very happy to hear from you.
Okay. Yeah.
Very good. So I have a question. You've been playing these games. Obviously, you wrote them, but have you given them to other students to see how well they enjoy them, if it's fun?
Not yet. We haven't. We're still like designing.
We're still in the prototype stages.
Okay. Okay. But you can still let them test it while it's a prototype, because then you may discover something that needs to be tweaked or made a little better. And let me just give you some advice, Sawyer and Tabitha. Don't give it to your best friends, because they won't be very good at evaluating it. Okay, I know this is hard to believe, but there's probably a student or two that you aren't terribly friendly with. Okay, give it to that student, because they're probably more likely to give you an honest report than your very best friend. That is very impressive. Julie, what did you think of their presentation skills? I'm always blown away with how well they're presenting and running the PowerPoints and everything.
I think it's pretty incredible. I'm pretty certain that that was something that we were required to do by 11th, 12th grade, maybe.
Well, they didn't invent computers until I was.
No, even without the computer, I mean, standing in front of a group of people talking about anything, you know, it's not something that we learned early. And I think it's just incredible, because it helps build their self-esteem, confidence. Their skill in verbal communication is just already phenomenal.
Whatever career you end up with, Sawyer and Tabitha, you will be giving presentations to people. You will be talking to your bosses, you will be talking to your subordinates, you will be talking to your coworkers. And these presentation skills, frankly, will be more important than anything else you've done in school. It really will be. So congratulations on your accomplishment. And Kamala, congratulations on having such excellent teachers. Students, I know they just don't appear out of thin air. I know they are there and they have these skills because of your help and support. So
thank you for giving them this opportunity. It was really fantastic. Thank you.
Great.
Thank you.
Thank you very
All right.
much.
We'll look forward to
Thank you.
seeing the rest of them today. Thanks.
Okay.
We're up to Oscar.
Is Oscar on?
He is on.
Oh, Oscar is ready. Let's just clean off a little bit here.
But you do have 2 minutes, Jake.
I
And we're running out of time to show all our lovely videos. So maybe we should throw another one in there.
Yeah, but you're only doing that because I've screwed it up almost every time I've done it. So this is a chance for people.
Not at all.
Okay, we're going to show it.
Oscar hasn't started his video yet anyway, so he's not ready.
Okay, let's see what happens.
But he can watch with us now.
Oscar won't, at least I know Oscar won't laugh at me.
Oh,
Oh, now he's laughing.
oh, you think he's laughing with you? Okay.
Okay, hold on a second. By the way, these were all created by Daisha, who is a fanatic about getting this stuff done.
Dr. Drizzle.
Okay, great. Okay, let's bring Oscar on. Okay, Oscar, where are you?
I'm here, Jake. How are you? How are you,
There he is.
everybody?
Okay, this is Oscar Mora. He's from Guanajuato and Mexico, Leon, and he is a man of many talents, okay? He is a musician, and he is also a technology coach and trainer. He has a master's degree in Montessori education, specialized in relay approach and special education, 20 years experience playing the instrument, so you started when you were 3 years old, guitar, drums, bass, violin, and he's also spent 4 years in Hewlett-Packard's in his tech support, so he's got both sides of his brain working. Some of his achievements are his robotics teams, which have literally traveled all over the world in different contests around the world. Maybe we'll hear some of that. And Oscar, I hope I have embarrassed you enough, but now it is your performance.
Well, thank you. Hi, everybody. How are you?
Hello.
Good. Well, first of all, here in Mexico, today is a Teacher's Day. So I want to congratulate all the teachers around the world because, well, at least here in Mexico, this is the Teacher's Day and everybody's celebrating the teachers in Mexico today. So I'm just waiting for some of my students. It's supposed to be here, and I want to start with some videos. Probably they're on.
So tell me their names.
It's Regina.
Regina, Sergio. Hold on a second. Let me put Sergio. So was Regina?
So Sophia and Christina.
I have Christina. Hold on.
Okay.
So the only people I have left over there is a Jen and a Regina.
That's good.
Are those aren't yours, Jen or Regina?
We're just missing Regina.
Oh, okay. I'll bring her over.
I think.
Perfect.
Okay. Well, Regina is right here. Okay, got it now. Well, it's been an honor for me to introduce those excellent students. I want to start with Sophia. Sophia, can you raise your hand so everybody can?
Hello, good morning, everyone.
Sophia, it's a former world champion on robotics world contest in 2018 back in China. There's a really talented family. Checo is her brother, and he was also a former champion on Europe and UK last year. Cristina Chivani is from Japan right now. She's in Japan right now, so it's probably morning. And Regina, it's also a former champion and in UK and Europe. So I want to show you some of the videos that we prepared for this. Right now here in Mexico, we're working on this pandemic and this COVID-19, and we're trying to develop some things in robotics. So if there's a chance, let me share my my stuff here. All right. Well, right now, because of the pandemics, is everybody watching the video now?
Yes.
Yes. Okay. Cool. So this is the team that we're working right now in Mexico. There are almost 13 students working on different type of robots. So they can develop breathers to prevent the SARS that we have as a disease. We are working on how to handle the distance between human beings right now. So we're delivering some of the services, money and stuff like that between, well, we have some drones to share. We have some robots to deliver the money and pick up the packages that we need to be in our house. So this is part of the team that we got, and those are type of the breathing machines that we're constructing right now. They're prototypes, and we are on the next week testing it on a real life situation. We're printing in 3D printers, and we're working on some face mask. So let me, well, Ivana will talk better about the things that we're having right now. Ivana, can you explain a little bit of this?
Oh, well, hello everyone. My name is Cristina Chivana. I have had the opportunity to participate in different 3D design projects. I would like to share with all of you my experience with this. 3D printing and 3D design have become one of our most important ways to ideas work. For example, the first project I participated in was to build a prosthetic arm for an 11 years old girl. Her name is Joanna, and she was born without her left forearm. The process to build the arm took us 7 weeks. During this project, we worked in 2 parts, one section on designing and the other was programming. Also, the arm consists of a electric sensor that captures the movements that Joanna performs with her biceps, causing the sensor to activate the servo, sorry. As a result, to be able to move her hand and fingers.
Yeah. Well, right now here on the video, we can watch the video. Christine is working with some RB tutorials to start programming a robot to grab something and release it on the other side. As you can see, they have the glasses from a virtual reality and start to develop some of the programs that we're running on our projects. Okay, I got some noises here. I'm sorry. Are you able to listen part of the video or no?
Yeah, we should be able to hear it. Oh no, hold on a second.
Okay.
No, it's not coming through.
Oh, this one is without a sound. It's well, right now Emilio's working on. Well, everybody's working on their houses because right now with COVID, it's really complicated to get together. This is a prototype of a hospital, a medical station. It's a helicopter that he programmed. It's the hospital door, and he programmed how to open it from distance. And then there's a breathing machine to help the patients with COVID to heal, right? And well, it's real quick how they're working on it. Release the patient on the front door. From the same helicopter, they can open the gate, and this is how he's gonna get in. Obviously, right now some prototypes, right? But they're working really hard on this one. They're trying to work with the creativity part of everybody, how we can use robotics as real-time, real-life situations and how they can solve some of the issues. I think it's really important when you teach something, it's important for the students to be able to use it on the real life. The other way, the knowledge, I mean, it's meaningful this way. So on the other side, we have Checo and Sophie. Are you there?
Yeah.
Okay, Sophie and Checo, can you explain a little bit your project?
Well, we do a project with a drone. This project is for we have like any contact with people, so we can stay safe, and you know, like there's people like.
First of all, this drone comes for my competition in China, and they give it like a prize, and we are trying to have the person that received the order safe like the one that gives the orders. So you put the money in
on the drone, and the drone go out, so you have any contact, and the person just deliver the package, and there is no contact.
This drone is already programmed. It's not controlled on real time. So they just get a little bag and put the money on it, and the delivery guy can pick up the money, and well, the rest is, it's important to be safe in a distance. And we have the other project about not everybody's able to get a drone. So we're having the vehicle to use this one. This is the F1 from Avilix, and this is Saul. He developed this this little card with a little bag, so also can pick up and deliver some things in a distance. It's programmed to get some point, make the delivery, and return to the owner. So they're working on it right now. There are probably some short videos, but to be working on it, it's really tricky. It's complicated, right? It's not that easy. So we're trying to develop some of the creativity on any situation that we're facing on. And well, this is part of the work that we have so far.
Great, fantastic. Oscar, I would just like you to repeat something. You said it very casually, and I want to make sure people are aware. In the United States, we have lots of drones, and they're remote controlled, and there's a person controlling them, okay? But this drone was autonomous. This was programmed, correct?
Exactly. And it's really, really precise. Checo came up with this idea, and he told me, you know what, Oscar? We just won those drones like 2 years ago, but it was so light, and on the outside, it was tricky to fly it. So it's supposed it was an internal drone to use only in their houses and some empty areas, but not on the outdoors. So right now, he fixed some of the things and programmed it to be useful on this type of situations. Actually, when we were creating the video, as soon as the drone gets out to the house, it was really complicated because you're not able to control it. It's all programmed. So if it's windy outside the house, so it was really tricky. And the front yard from the Checo and Sophie house, it's really windy. It's on a mountain, and so he told me it was perfect from the living room to the front door, but as soon as the drone is outside the building, well, outside the house, it was tricky. It was tricky to control it because it's not well, we don't have any chance to control it, right? But here I also have some of the projects. She's explaining the breathing machine because we're working here in Mexico. Well, we don't have that many cases that we thought we were going to be at right now, but it's still a problem for the sick people right now on COVID. And well, she's going to explain part of the process.
I'm sorry, what? I just heard my name on it. I can hear you well.
Can you hear us?
No, can you repeat it, please?
Can you explain a little bit the process about the robot that you're building and the stuff you're living right now?
Oh, yeah. Well, I fear that one of the main problems of our society is clean water. I mean, about 780 million people around the world do not have access to clean water. And I think that that's an issue because in average, an American citizen spends more water in a 5-minute shower than a third world citizen in their whole day. So we can see that the difference is huge. So we were thinking about a new way to create, to process water in order to clean it, and in a way that it could be faster and better. So it could also be cheaper. So people of third world citizens could have access to this clean water because, I mean, it's something really important for people to live with. I mean, without clean water, you can't really live healthy. And right now it's one of the main issues, like these healthy problems going on, that maybe right now it's just a virus because of animals, but it could also be transmitted on water or something like that. So I believe that clean water, it's like a really important issue to treat.
Well, that was very interesting. I want to congratulate all of you. I have some experience in robotics, and I know how difficult it is because it's just not something sitting on a table. It has to react with the real world. And like Oscar said, there's wind out there, and it's very difficult. And you guys have done a wonderful job. And Oscar, I know that they could not have done any of this if it were not for you and your help and support. So I think each one of these students is a credit to what you have done as a teacher. Congratulations.
Well, thank you, Jake. Well, thank you, everybody. And well, if you can give some support on a website, you can find us on Facebook on oscarmoraelmen.com, and you can find us all the projects that we have right there. Please.
Great, very good. Well, thank you all very much. Thank you, thank you.
Thank you.
Thank you. Have a nice day. Bye now.
And I see our next presenter is up, and this is Jennifer Perry from Calgary. And Calgary is beautiful. I love it. And you are a 4th grade teacher, and you're going to be talking about Coding Quest, teaching problem solving through coding.
Yes.
And Jen, just so we could do a shout out to your school that you teach at, what is the name of the school?
My school is St. Marguerite.
I'm sorry, St. Marguerite?
Yes.
Okay.
Okay, so it's exciting to be a part of this global initiative to showcase tech and innovation from around the world. And those were some pretty tough acts to follow, so I'll try to do my best. Like you mentioned, I'll be talking about the Coding Quest, and it's from a company, a nonprofit company in Canada called the Learning Partnership. And so I began being interested in coding about 4 years ago. Every Friday, my class would participate in something called Genius Hour, where they would work on some kind of passion project that they were interested in of their choice. And a boy who was a reluctant learner introduced me to a game he was making on Scratch. This particular boy had done very little all year, and he wasn't motivated to complete any of my assignments, yet here he was creating this amazing video game using Scratch. I witnessed him using higher level thinking skills, problem solving by seeking out answers, activating his growth mindset, and being a creator. It was pretty amazing to watch as he was doing this all independently without my support, as I knew absolutely nothing about Scratch or coding. After that experience watching this boy in my class, I needed to learn more about coding and how I could use this in my classroom. So I began learning about Scratch, which is an amazing tool for any teachers and parents as well. And once I discovered Scratch and coding, I really wanted to see if this form of digital literacy is something I should incorporate into my teaching practices. So I began teaching about 14 years ago, and I've actually seen the negative impact that technology has had on my students. Their literacy skills aren't quite as strong as they once were. They don't seem as attentive. Many of them have never actually experienced boredom until this very moment, because their iPad is brought with them on long car trips. They just never have had an opportunity to be bored. So I'm kind of leery about just incorporating technology without it being purposeful. So I think it's essential that we move away from our students being passive users of technology, where they just consume and consume and consume, to a place where they're in control of the technology and they're active users of it. So this is my goal as an educator. So I began reading educational articles about coding, finding resources, and it really wasn't hard to be convinced that coding is an essential skill that should be taught. I was further convinced when I was reading a book that I think all educators, and actually all people, should read, called Reader Come Home. There's a little shout out to it. And it's by Marianne Wolf, and it's about the reading brain in a digital world. So I started reading this book because I wanted to see how I could improve my students' literacy skills. And when I was reading it, my intention wasn't to read it to do anything with coding. It was just to do with pure literacy skills. I found this quote from some people that work at MIT Media Lab, which is where Scratch is created. And it says, every child should be given the opportunity to learn how to code. Coding is often seen as difficult or exclusive, but we see it as a new type of literacy, a skill that should be accessible for everyone. Coding helps learners to organize their thinking and express their ideas just as writing does. As young children code, they learn how to create and express themselves with the computer, rather than just interact with software created by others. Children learn to think sequentially, explore cause and effect, and develop design and problem-solving skills. At the same time, they aren't just learning to code, they're coding to learn. So when I read that, it really changed, well, it validated, I guess, so many things. And I was on this mission to incorporate coding into my classroom. From there, I went to so many different professional development sessions, and I found resources, and it's pretty amazing all the free stuff out there. Google has a great free educator course, CS First, Scratch, Microsoft Make Code, and in Canada, there's a plethora of free resources, including, I'm going to give a big shout out to Canada Learning Code, which has so many educational resources for newbie teachers, experienced teachers, education related, so you get your curriculum in. And that's when I stumbled across the Learning Partnership and the Code Quest Challenge, which is something my class did this year. So the Code Quest challenges students in grades 4 to 6 to build their own educational video game using Scratch. And it must have some kind of curriculum outcome, something that we learned about this year. So it has to be educational, and they work in groups. There's lesson plans along the way. You get a resource manager to come help you. So you're not, if you don't have any coding experience, you can still do it. So this is a huge shout out to Canadian teachers who want to try the Code Quest if you're a grade 4 to 6 teacher. And it ends with a Code Quest arcade where students showcase their games and deliver their elevator pitch to various people that are coming to check out their coding projects. And this Code Quest arcade takes place in over 15 places in Canada. So I thought I'd show you a little video, hopefully it works, of the actual arcade challenge. I think of it as like an old school science fair meets coding. So let me share my screen and I hope it works. Maybe. Oh no, I'm not sure if it's gonna work. I can't see my, oh, here we go. Maybe this will work.
We see your screen.
Do you see the Code Quest now?
We
There
do.
you go.
Make it a little
Oh,
bigger.
yay. Oh, I don't know if I clicked. Sorry, I'm gonna have to go back and click that. I just want to make sure that I click the audio. There we go. Okay, this should work now. I'm not showcasing my tech skills, am I? Okay.
Can you expand the screen?
Yeah. Okay, I'll just show you
I've
a
always
little bit about it.
wanted to code my own video game, and I'm looking to you guys for inspiration. Some of you have been working very hard over the past few weeks to make video games from scratch, and so I'm going to check them out here at the Coding Quest Arcade! Woo! What is this game called?
It's called Thunderman.
Whoa! What is the name of this game you created here?
Jumanji.
This game is called Wizards and Warriors Wind Edition. We have the geniuses behind Road Collector. How do you play Road Collector?
When they hover over the sprite,
Hey, all right.
you have to press that key. You have to try to find all the family members in the game.
So it's like a maze.
Yes.
Yeah. So it's a combination of a maze, you avoid the obstacles, and there's a spelling challenge.
Yeah.
If I'm going to design a video game, I need some tips from the masters. So what is your #1 tip for me?
Definitely look at other games. You have to try to make it exciting.
I'm about to win. I'm about to win.
You should have intense music.
3, 2, here we go. Here we go. I lost.
Okay, you can find this video on YouTube as well. Am I back now? You can see me?
Oh yeah, you're perfect.
Okay, good. Okay, so I'm just gonna scroll down here for a sec. So you can see how much fun, obviously, that is. My students were super disappointed. We were just on the cusp of going to the arcade challenge, and with COVID, obviously that didn't happen, but a lot of my students are still working on their projects. So I became obsessed with coding, and I still am, and the impact I was seeing on my students. The arcade challenge provided that authentic opportunity to use their coding skills to create this game. My students worked in small groups and had to figure out how to cooperate, which is always a great skill when you're a teacher, manage their time, make lists of things that they needed to do. That was, for many of them, the first time they've ever had to make a to-do list. Problem solve, activate their growth mindset as they failed and had to try again and again, and ultimately to be creative and innovative. They basically unleashed all 21st century competencies and became the active users of tech that they need to be. It's amazing to watch this process happen. There's an energy in your classroom where kids are excited about what they're learning. And I know how impactful the Code Quest Challenge was, because as we shifted to remote learning, I wasn't getting emails about math or my language arts assignments. I was getting emails about coding projects and asking for some help with their coding projects. So many of them are still working on their projects or working on new projects in Scratch from skills that they learned through the Code Quest Challenge. Their projects aren't quite ready to be shared, otherwise I would have shared some of them, but there are some ideas that they are working on include an environmental game about ocean plastics, a knight's quest to conquer multiplication and division facts, and an adventure game about our local geography. So those are some ideas. I believe as teachers, we need to learn with our students. Teachers have to become learners. I am not a professional coder, but when you create an atmosphere of learning together and not being the keeper of all knowledge, you allow your students the independence to take control over their own learning. I am not able to answer all their coding questions, but together we seek answers and we learn from each other. For the first time as educators, we don't actually know what jobs will exist for our students in the future. There'll be so many tech-based jobs that aren't even in existence right now. So how do I prepare my students for jobs that don't exist? Well, I have to prepare them with 21st century competency skills to be ready for whatever the future brings. And obviously right now, this is more important than ever. So I think that coding in the classroom and digital literacy skills enables my students to be future ready. So there's my own little presentation about coding. And if you're a Canadian teacher teaching grade 4 to 6, I highly recommend you check out the Learning Partnership Code Quest Challenge. And they also have some other amazing innovative programs.
Jen, that was incredible. You have no idea how happy I am to hear what you're talking about. I'll tell you why. And you don't realize this, but there was a teacher earlier. We're near the end of our 24 hours right now.
Yeah, I know.
Beginning of our 24 hours, there was another teacher named Tim Hotchkiss, and he was talking about exactly the same thing. He started to work with some products. It was a company called Parallax. And in fact, the CEO will be the next presenter. You may want to stay and listen to him. But Tim was saying exactly the same thing. He said, I didn't know how to do this. And he said, I told my students I didn't know how to do this. And I think your attitude is wonderful. So many times I've seen teachers who think, like you mentioned, that they have to know everything or they can't teach the subject. And that's not true. You are a facilitator. And I'm sure your students are going to go off and do incredible things. And maybe they will come back and explain to you what they have done.
Yeah. Students as teachers, I love that when my students become the teacher in our class. It's one of my favorite things.
Jen, I would also just like to thank you so much. I do a lot of work in Alberta and Nova Scotia and Vancouver, and I'm texting with some Canadian teachers right now who were just thrilled to watch you. And they love the whole idea of the Coding Quest arcade. And so they may be reaching out to you if that's okay.
Yes, please send my info their way.
Partnerships. Yes, thank you so much.
Thank you.
Thank you for putting on this amazing event.
Thank you.
No, it's only amazing because you were part of it.
Thank you. Have a great day.
Thanks.
Okay, well, now we have another visitor that is making me extremely happy, and this is Ken Gracie. Hello, Ken.
How's it going, Jake? Good morning or good afternoon. Hi, Julie.
Hi.
Tim did a presentation earlier in the day, and he was talking about your products. He showed some videos. He talked about what his students did. It was really good. So we're looking forward to this. Ken is a lifelong hobbyist and educator and a CEO of a company called Parallax. And Ken has been doing this for a long time. I have manuals that Ken's company published in the early 90s. So it's been quite a while. So Ken,
Well, if it's fun, you just keep on doing it, right?
It's great. So I'd love to have you explain what you're doing and what all this has to do with education and getting ready for the future.
Yeah, sure. So, by the way, it's great watching Jen and Oscar previously. I think this kind of ties together with what they're pointing out, being teachers and using tech when you're not a tech teacher. In Jen's case, is great because you do have to be able to write about things and communicate everything you're doing. So that was really good to watch her. Sure. So I'll tell you a little bit about what I'm going to show and who I am. My name is Ken Gracie. I'm from a company called Parallax in Northern California. And we make microcontrollers, robotic parts, and tutorials for students. I'm also a preliminarily certified CTE teacher, and I've been at this thing for about 25 years. And I followed a lot of the science fair and the maker fairs and the innovations that are happening with students, like the Invention convention. And I'm seeing how that they are really progressing. Like these kids are getting really good. They're doing better stuff, and we're seeing more electronics in it. And because we make electronics, I thought I would show two things that I've been working with lately that I think hold a lot of promise for both inventions and student-oriented projects. So I'll run through these projects really quick. The two things I'm focusing on, one is using a camera to identify objects of different colors and where they are. So I believe we'll be seeing a lot more of this kind of sensing used in some student projects. And then the second item is just a really easy demo of how you could communicate wirelessly with something called the Microbit. It's a very low cost controller, and I think it's useful for any student because you can program this in block code or Python or whatever. So now we'll get rolling. Yeah, so the Pixie 2, the first project I'm going to show you is called the Pixie 2, and that's a little camera that you can interface with a microcontroller. And I want to work with color items because I want to do more advanced work. I want to count objects, identify them, sort them, move them around, whatever. Because for years in educational robotics, we've been using these kinds of sensors, which are sensors that detect things and their distance. Like laser sensors could work up to 100 meters. Infrared can detect people walking into a room. Infrared emitter receiver pairs can tell you when something is nearby. Ultrasonic sensors work up to 10 feet. So there are a lot of good technologies, or even physical bump switches. But these are all just detecting whether or not something is in front of you. Something, I say, because it could be almost anything. But whether or not you can see it depends on the technology you're using. Like a fuzzy stuffed animal may not be seen by an ultrasonic sensor. So students get to learn about these things pretty quickly. This is usually where they go. I think where they're headed, though, is to do things that are quite a bit more complex in time, because I'm seeing it now. So for example, here's a robotic arm, and this is moving around some items of color, like some little round discs, picking them up, placing them somewhere. Or how about this? This is a little more human-oriented task. Picking up an object. What color is the object? What do you do with it? And then we're seeing some stuff like this, conveyor, automation type things. Also really neat, Legos can factor into this. And we're seeing games that can be played against robots. Okay, so if you can track a color object, you can actually create some kind of actuator to attach to it, hit it, or bounce off of it, or move a chess piece or whatever. And of course, we see a lot of robots like this. Okay, so what happens, let's say you got 100 objects in front of you. We're humans. You know, this is easy. Count the yellow balls, 1, 2, 3, 4, 5. You can do that, no problem. But what's a microcontroller? What's a robot going to do with this? I mean, this is like absolutely complicated to deal with if you're a machine. It's not easy. And even though we have a tool now, and there are many that can identify these objects, count them, sort them, what do you do with all that information? How do you code around it? I mean, this gets really, really tricky really fast. So my little project that I used to learn about this started out like this. So I'll show you the beginning, then the end. So here's a little robot, and it's just tracking this yellow block. And so this project probably took me about a week of coding to get to. But the great thing is, every time someone goes through this process, they post the code and they share it. It's available for others. So I'll provide links to this in the chat at the end. Okay, so that's where I started. Now, where I wound up was somewhere kind of different. So you got to look at these projects in pieces. You have to break them down into little pieces when you're working with this, or when students are. So this is some advice I can give you. It doesn't require a lot of skill. You can learn online how to do these things, but you have to be able to do subsystem testing. You have to break these problems down into little pieces with a block diagram. So here's a block diagram of the problem we're working with, or I should say the hardware. What I'd like to be able to do is pick up the yellow cylinder and move it around. So I have 3 pieces to this, really. I have the robot, which is shown in the top block. Okay, so that has a little chip on it. And then I have this Pixie 2 camera, which can detect the object, and it talks to the robot. And then I have the object itself. So I got these 3 things. An environment has everything to do with making something like this work. Again, we take this for granted as people, kind of like Oscar was showing that drone flying around, you know, in a closed area, indoor, doesn't have GPS, has to detect objects. We take this all for granted because it's so easy for us as humans. So let's look at one piece of this at a time, just briefly. All right, so to configure a camera, you first have to teach it, the camera microcontroller, what it's looking at, where it is, and then it will generate information that will go out to you. So in this case, I just put 3 blocks down, and I hooked the camera up to its PC software, and then I could train it, and I could say, this is a green one, and I do that by clicking on the block, outlining it. Here's a yellow, here's a red. So the camera now knows what it's looking for, and once these colors have been trained to the camera, it can count them and tell you the size and the location. Okay, this is pretty awesome, pretty powerful, and pretty easy too. Then you got to write some code. And again, as I mentioned, this work having been done by many people, it's available, it's online, not just for this, but for other things. So for students doing projects, we really just have to help them find the resources and get them the hardware. So on the microcontroller side, where the robot is, we wrote some code, and we did this in Blockly. And this is a pretty big program. It has 500 blocks in it. So it's pushing the limits. And all these things on the right, these are functions that are all collapsed. And you know, if you've worked with Scratch or Blockly or Snap or whatever, you know something about this already, but you can take big chunks of code and then collapse them. And so the main program's here on the left. And it does things like, it goes out to the camera and then it says, what are you looking at? And then the camera returns a bunch of data. So the camera being trained, you have to interface it to a chip, to a microcontroller, and then get data, numbers out of the microcontroller. So this is what the microcontroller would see looking at those previous objects. So it's looking at these things, 3 blocks, and then it tells you which color signature it has. So here's 1, signature 3 might be the green, and then 1 might be the red, and then 2 is yellow. And then check this out. For each of those items it sees, it tells you the X and the Y position in its coordinates, and then how big it is, both in the X and Y dimension. So you got all this data. Now, go back to that big old bucket of colored balls that was dumped on the table. Imagine now trying to sort through what to do with 50 different versions of the same color on your screen. Oh my gosh. Yeah, I see Julie. She's like, this is complicated. Yeah, so you have to simplify your problem to make it useful and demonstratable and solvable sometimes. Anyway, here's the result that I got out of it. So after, working for a while.
And it wouldn't look as complicated 23 hours ago.
Yeah, exactly.
In a way, 24 hours makes a difference on how we look.
You guys are hanging in there. So what happened in this video, and I'll play it again, is the robot took an inventory of what it was looking at, swept from left to right, and it was coded to go for the yellow one. And so it determined where it was in its X and Y viewpoint, and then just went after it. And again, I'll post all these links in the chat, so just hang on a minute. Because as Jen pointed out, tech integrates with writing, and if you're going to be useful in anything you do with tech, you have to be able to communicate it. And this is a requirement we have as an employer of anybody in tech, is that they have to be able to write. You could be the best engineer in the world, but if you work alone and you can't work with others and you can't share what you've done, it's really of no use. So in this case, this project is written up for you. So second thing I wanted to show that I'm playing with too, and I think this is really good for students to be using in any invention type project, is the Microbit. And why do I like this thing? First off, there are a bunch of ways to program it. You can program this in block code, JavaScript, Python, whatever. What I'm showing is in Python. And one feature in particular here that's really nice is the wireless communication. Okay, wireless is all around us, our phones, our routers, everything we're doing. Even any appliance you buy now has some wireless capability. So this is a little $17 controller that you can buy just about anywhere now, and it's loaded with stuff. So if you think about the inventions again, so just look what's built in here. No electronics needed. It's all packed onto this board. You got a compass, accelerometer, there's a temperature sensor, there's a wireless radio, there's a bunch of LEDs, buttons, okay? So you can connect this to anything that moves, shakes, has temperature or whatever. And if you still have to connect stuff to it, you can use this edge connector. Okay, so I like this little tool. And what I was looking at here was just the ability to use it in robotics, well, because I make robots, and how easy is it to do. And so I started out with this project, but wait till you see where I went. It's pretty cool. So just driving the robot around using the accelerometer, that is, you tilt the board and the robot follows. What do you think of that? It's cute, right? Now, the sixth grader can do that. Okay, so got to have you picture a situation here. You have a student, actually a classroom full of kids. Let's take 30 of them.
I saw some of Tim's kids. I saw his 2 6th grade classes, and it was amazing. Some of them had their stuff done. This was way back in November, so they weren't all finished, but they were using the parallax boards, and I'm not sure what you call the totality of what you have, the equipment they got from Parallax, and they're pretty phenomenal little things. They demonstrated a few of them for us.
Well, it's a matter of being a teacher, just throwing it in front of them and finding the resources. And all this stuff is new, so not every teacher can know about it, but experiential learning, letting the students discover it is really what it's about. We all want control. So I want you to picture class, Tim's class, or Jake's class of like 30 kids, and they're all on their computers, and they have these little microcontrollers connected to them on a USB cable. And they suddenly open up a chat in them. And that means they're typing commands on their computer, which are sent out through their microcontroller to other students in a very open, unencrypted way. So it starts out just with fun, but then it turns a little bit crazy, and then suddenly the teacher needs to shut things down because it can get out of control. So there are only two lines of code here. This is the whole code that I'm going to show you running here. It's you know, 24 lines, but 2 do all the work. That's radio send and then radio receive. So it's a little loop, and it's just checking to see if anything's come in and if anything can go out. So this allows you to take one controller, connect it to something like a sensor, and then say to send data back to a computer. Let's look at this application. Okay, so say you've got, this is actually my computer, and what I have is two browsers open side by side, and I have 2 microbits connected to 2 different USB ports. So it's like having 2 computers on 2 students. And the tutorial documents this. Doesn't require any expensive hardware, nothing special from Parallax. Like I said, you can get these things anywhere. So basically, you're going to load the code into both microcontrollers, and this video I pre-recorded, so I'll switch over here. Here it should. Okay, so I'm going to flash them both with the same Python code. And then after that's done, you'll do what's called opening up a serial terminal, okay, on both sides. And now you can communicate across the room. So I send a message. Why was 6 afraid of 7? And everybody in the room receives it. And anybody can type back too. And I answered my own joke because 7, 8, 9. Okay, so that's the kind of stuff that's possible. Where I wound up was here, actually. I wanted to control a whole classroom of robots. Well, this is what our customers will want to do. So this is part of teaching cybersecurity. You start out with things totally wide open, and then eventually you can control the whole classroom. So type in some commands on the computer. And then you can see every single robot can respond. Yeah, pretty crazy, huh? Fun. Yeah, so I'll post that. And let's see, how are we on time right now? I'm just about done.
You've got actually about 15 minutes left, I think.
Oh, okay, good. I won't even read it all.
Let me look to make sure, because I could be totally wrong.
But there will be some questions there.
Yeah, we'll take the questions and use it for
You're on
chat.
till 11:30.
Oh, okay, good. All right, so teachers who want to get into this, or students, anybody interested, there are a couple ways to go about it. I will post in here momentarily all the links to chat, and then we could just talk about whatever. But this is a good way to get started. This we actually created for the Invention convention. It's called the Inventing Kit, and there's a series of slides that go with it and show how students how to wire things on a breadboard and then write some code for it. It's nice, fun, basic stuff. And if you're a teacher, you can sign up for this, which happens next, actually the second week of June. We are running a 3-day, hour-and-a-half per day workshop with Python and robotics. And this is free for up to 80 teachers that we accept. And it's actually paid for by the Cyber Innovation Center. And they're funded by Department of Homeland Security. So it's only open to American educators because of that restriction, but there is no cost in it. So I'll drop this link in the chat as well. And yeah, we could talk about whatever now, and here come all the links to look at. And I can go back to any of those items of interest too and go over them more.
Wow, very good. Ken, thank you very much. One of the things I just want to point out, and Ken, you did an excellent presentation. And it was a very accurate presentation, but it also involves some rather large words every once in a while, like, microcontroller, which in some situations might sound a little scary. But you might want to talk about a little bit about what Tim had done with his students, because his students were in 5th grade, very, very young students, and had no trouble working with this. It was great.
Yeah. What Tim did is, we just put a bunch of hardware in his class, and we actually gave him resources that were intended for an older audience, like high school, and see what happened. And Tim is such an open-minded teacher about these things. What he didn't know didn't bother him, but he just plopped in front of him, and the kids wound up producing all kinds of little contraptions and just learning as they go, not knowing the rules of the game or even the intended outcome, but succeeded. And I think they had a wonderful time, and he's still using all this. Is that an accurate representation of it?
No, absolutely. And it was exciting to watch the students grow, because he told them, he said, by the way, we have all this equipment, and I don't think you're going to be able to do this, because this is meant for high school students, and you're only in fifth grade. And so
reverse psychology there.
Oh no, I don't think it was reverse. He was covering himself because he had told the principal that he was going to do this. And I mean, I was just really impressed with what these kids had done. And the excitement. I mean, the nice part about this is Ken showed a lot of robots that were moving. What he didn't show was all the blinking lights and the flashing lights and the OLED screens, you know, with things going on. And the kids really enjoyed, you know, all the blinking, flashing, making sounds. They made musical instruments. It was really exciting.
Yeah, I think I was just talking about sensing, right? Just sensing something you can see, but there are sensors available for measuring just about everything now. And they're getting easier to connect. So these sensors are just for distance or detecting something, but anything in your physical environment now can just about be measured.
Daisha, I could see you coming up with 1 to 500 challenges that could use this equipment.
Oh, I would love to. Yeah, I mean, we can measure.
She makes some pretty cool challenges, and I think
I'm typing them in my phone right now.
I mean, most of them are things you don't have to necessarily spend money on, but you know, as we want the kids to start learning more and becoming more able, sometimes there's a small cost associated with that. But I could see some pretty cool challenges that you could come up with.
You know,
Julie, you could use this.
I'll just share something with you. The most exciting time in my life was the first time I ever programmed a microprocessor, and I got an LED to blink. That's all that it did. It turned on, it turned off, it turned on, it turned off. And I mean, I was just so excited, because once you have that very simple ability, then you can go off and do anything in the world. It's just amazing. And while Ken showed some very sophisticated things, just turning on an LED on and off, or turning on different LEDs and lights and making different sounds, it's a really exciting opportunity for students.
So one of the particular resources I like, and I think this is suitable for just about anyone, is this particular site. It's the Make It Code It from Microbit. And I pasted this into the chat. And you can come in here and identify the language you want, whether it's Make Code, which is their block code, or Python, and then pick on a project and actually see the code for that project. So for example, let's just say I want to pick on Python, and then I want to do a beating heart, a very simple project. Click on this, and it describes the project. And then as you scroll down, you'll see these two options, Make Code in Python. And so there's the equivalent. This just came out. This is a useful site. And I would say anyone that can read can do this. Especially if you can hook something up to a computer, just plug it in. And once you've clicked on the code you want, like Python, I prefer, you can just open it in the editor right here, and then download it straight to your microcontroller. So yeah, easy. In terms of cost, one thing you mentioned, yeah, the costs are coming way down. So once you have a microcontroller, you know, 10 to 15 bucks, 20 bucks, then you can go to Amazon, and there are some super low cost sensors, like we're talking $2 to $5 that you can interface to these devices. You just want to do a little Google search on the sensor and the name of whatever you're using.
Very good.
Yeah, and want to thank you guys for the lovely opportunity. I think what you're doing is really cool. I only got to watch a few of these, but wow, what a resource to be kept on YouTube forever.
Well, we've recorded this, and we're going to take each one of these presentations and make them a separate YouTube video. And, you know, you'll be up there, and Tim will be up there, and Jen will be up there. And we may have to have a whole folder just for programming. No, I mean, we need to organize it somehow, but this will be great. So thank you, Ken. Thank you very much for your participation. And thank you for all that you do to support education and support the future.
You're very welcome.
Thank you.
See you soon.
Thank you.
Okay, Julie, I believe that our next presenter, and Nicole, we have saved the very best for the very last. I hope I haven't frightened her too much.
No.
Okay. Oh, let me read the magic thing here. So, Nicole, you're from, oh my goodness, Nova Scotia. Welcome.
Yeah.
This is great. And you're with the Skills Competence in Canada. And the talk is, oh, what I have learned through the skilled trades and the passion for car painting. This will be interesting.
Oh, thank you very much, Jake. As you said, my name is Nicole Hamilton. I'm 25. I live in Nova Scotia, Canada. I am currently a Red Seal motor vehicle repairer in metal and paint. I'm also the Skills Nova Scotia Alumni Association president and the Nova Scotia representative for the National Alumni Committee with Skills Canada. So a little bit about Skills. Skills is like the Olympics for the trade and technologies. You get to compete within your trade against people across your province or state, depending on where you're from, for a chance to win gold. And if you could get your chance to win gold, and then you can move on to go to nationals and compete countrywide. And then you can also try to get a chance to win gold there and move on to compete worldwide if it's a qualifying year. So a little bit about myself in getting into the trade. In high school, I wanted to do video game art and design, but there was nothing available in Nova Scotia at that time. So my options and opportunities teacher had suggested I do something with engineering because I left a lot of doors open in high school. I took as many courses as I could, opposed to just getting what I needed and got out. And she suggested engineering, and I just said, well, why don't I paint cars? So I never really looked back. After that, I applied in my grade 11 year to the NSCC, and I got accepted. I did job shadows and co-ops and test drives to learn what I was always taught, like to learn what I really wanted to do. But in my experience, I actually learned what I didn't want to do more so than what I wanted to do. So in auto body alone, I found out that I wasn't a big fan of like taking door skins off or removing quarter panels. Like I knew I wanted to paint, so I stuck with paint, and I just learned as much as I could and asked as many questions as possible, kind of thing. So how I got involved with Skills was a little different. I tried to compete in high school, but there was nothing for a secondary competitor, so a high school student for car painting in Nova Scotia. And they wanted me to wait until I was in college and had some experience under my belt, kind of thing. So I waited until my first year, and my instructors had kind of warned me, like, we don't usually take first years into car painting because there's not a lot of experience with the products and the booth and everything. So that was fine. So I waited another year. So in 2014, I finally got to compete in car painting, and I knew the other competitor who I was competing against had competed for 3 or 4 years before me. So I was a little shaken about that, but that was fine. Him and I competed. We both did really well. I had placed silver that year. And eventually him and I became pretty good friends, and we stayed in contact, and he helped me through a lot of my skills journey after that. So in 2015, I competed again for my second year, and I moved on. I won gold, and I went to nationals.
Wow.
So in nationals, I went to Saskatoon, Saskatchewan, so for me, across the country. And it was very like unnerving. Like there was just so many people and so many cameras, and I was nervous my first year, but that was fine. I just kind of buckled down. I knew what I had to do. I did my best, and I placed 5th out of 8 my first year at nationals.
Wow.
So then I went back again, and I competed. I won gold provincially. I went to nationals again, which was in Moncton, New Brunswick. So it was a short bus ride for us from Nova Scotia to go. And that year I knew I was a bit better. I could handle it. I didn't pay attention as much to like the people walking around or the cameras and the video cameras all in your face. So then I had fun and I did good, and I was like, yeah, I'll win gold, right? But I got the results back, and the competition is very close. Like I placed 4th that year, and I missed the podium by decimal points. And I think between me and gold was 3 points in total, which was a crazy amount to come so close to. And so that was fine. So I thought my next year would probably be my last year. I'd have enough hours so I could write my red seal. I went and competed, and provincially I placed silver, or placed 2nd and got silver, against somebody who had been in the trade for about 10 years. They weren't red sealed certified, so they beat me, not by a whole lot, but enough that I lost, kind of thing. And so I was like, okay, well, there's my skills career done. But I got a call a couple weeks before nationals, and something had happened and he couldn't go. So I got the opportunity to go to Winnipeg, Manitoba again, and I competed again for my 3rd year at nationals. And unfortunately, the same thing. I placed 4th, and I missed it by decimal points again. I remember sitting and waiting for the results, and we knew it was probably between 4 of us who had placed. And New Brunswick and I were kind of talking because we were separated into our own groups, and we were both sitting there kind of thinking like, oh no, like New Brunswick's got gold, and he thought I had won gold kind of thing, and it was his last year. But we met afterwards after he had won, and he was like, I wasn't sure, and I looked at him and I was like, I wasn't sure. So that was Moncton, or that was Winnipeg. And finally in 2018, I went to Edmonton, Alberta, and it was my final year. I was in my 4th block training. So this was my last shot at winning gold. And I was so excited to go again. And I just remember competing. I walked in, I knew all the judges, I knew everybody. I knew what I had to do. Like I had practiced so much on certain things that I had not a lot of experience in. So like my tinting and my buffing, I could do no problem. And I just remembered like New Brunswick was there again, and he saw, and he was like, you're definitely up there this year. And I was like, I really hope so, because I go and write for my red seal in 2 weeks. So we were just sitting and waiting for the results, and usually automotive sector is at the end, and that year they had changed it, and it was first, or near the beginning, and just the room went quiet, and I was like, this is me, like, I hope they call my name. Like, I was getting really excited, and they had announced the secondary competition who had won, and then they had gotten to bronze and then silver. And I just remember just hearing Nova, and I just jumped up out of my chair, and I jumped, like I had a lobster hat on, And so I ripped that off of my head, and I jumped up and I jumped across 6 chairs and I grabbed the flag and I ran up to the stage. Like, it was just such a exciting moment, and it's great. But yeah, so that's about me and skills and everything that I have done, and I mean, it's a big experience, and skills is like another family. And even like I found a lot of passion within my trade, and I'm really happy that I decided to stick with it and continue in with skills, and really trying to persevere through like being told, no, I can't compete now, or even as oh no, you're this close but you didn't quite make it, kind of thing. But yeah,
Nicole, that's a great story. That's a great story. No, I'm serious, and it's something you need to share with students, because they think, oh, I didn't get it the first time, I'll quit. And you didn't quit, and you just kept on going. It's wonderful.
Yeah. So kind of just to wrap up everything, I guess, I'm still currently a full-time automotive painter. Well, with COVID happening, I'm currently off work, but that's all right. I'm staying involved with Skills Canada and Skills Nova Scotia. And currently I'm also training another young apprentice, another female apprentice who also wants to paint just as much as I always did too. And I really hope that I can keep the momentum kind of going, and I can become like a really good mentor and a great support for anybody who may or may want to be in a trade in general, not just necessarily my trade. Because like my mentors were a really good support and help, and they know that, and I try to keep them updated as much as I can, and I really appreciate everything that they've done for me.
I absolutely guarantee you will be an inspiration and a mentor, not only for the students, not only for the young people you know, but for hundreds of others who you will never meet, who will see your video or hear your story through somebody else. I guarantee it. There will be an inspiration, plaque for you somewhere.
Yeah. Thank you.
Thank you, Nicole. Thank you very much for sharing your story.
Thank you for having me.
Thank you. Thank you. And now, Daisha.
Thank you.
So I just need to let everyone know that it is almost 24 hours that this crew has been up and working together to host all of you all over the country, all over the world. And we are flat dab exhausted, but so glad that this happened. We can't wait till it happens again. I just want to remind you, can you see my website screen?
Yes.
I just want to remind you that this happens again in 2 months. Julie, get some sleep. We will start the countdown
You
clock.
can't bank it. I've tried that before. It doesn't bank.
We will start that countdown clock again next week. We are already open for presenters. You can go ahead and sign up for the next event. We will have brand new, oh, it just went away, hang on. We will have brand new challenges that we will put up on a separate page. So we're not going to get rid of what we have, but myself, Dr. Drizzle, has about 40 more ready to go. And I have a special little treat for the team. Now, we have probably gotten on each other's nerves very badly over the last 24 hours. And some of that could include being passive aggressive when people say, do this or do that, or we're live or we're off YouTube. But I tell you what, this is an amazing group of people to work with. So I would just like team to celebrate you for 21 seconds. So if you would just sit there and enjoy this. So that is us. and we can't wait to do this again. Now, don't get me wrong, we are not doing it tomorrow. And we're probably not even going to talk to each other for a week. I love them, but their faces are not what I need to see right now. I am in a hotel room, and my husband just got me another night by myself. So I'm going to be sleeping within 20 minutes. But Julie, talk, say something.
I can't. I'm going to wipe the tears away. This was fantastic. I thank each one of you for volunteering to be part of this chaos, and look forward to the next one and them getting better every time.
Jake, you got to make another 150 relationships. You know, you have to build another 150 if you don't mind.
Well, does that mean that the people who know me won't want to meet me again? Is that what you're saying?
They're now a Global Innovation Field Trip alumni. They were in the first inaugural group. So they now join this alumni team, and they will help you, I would assume, source new presenters for next time.
Oh, they will all have assignments. Trust me. They will not. Nobody gets away free.
Carmine, I know you've enjoyed it. We have wowed and holy moly together for 12 hours.
You know, I was really hesitant. I didn't know what to expect. And first off, you guys, I can't even take hardly any credit for this. You guys were just super organized. I mean, looking at that list and the speakers and coordinating all that stuff. I mean, you guys, hats off to doing all of that crazy work. I kind of jumped in and did a little bit of talking, but it's really all you guys, and I really appreciate you allowing me to be part of it. I was actually honored to be part of it. I could not believe how great not only the presenters were, but the kids. I loved their ideas and their pitches, how excited they were. I mean, that's what really pays off. I mean, I was tired as heck, but I was laughing, and I so enjoyed it all.
Well, we're getting lots of response on YouTube right now. People just thanking us, and we'll take it. We're not going to be like, well, we didn't do anything. We did. We worked hard. Admit it. This was hard work. But as you can tell through Julie's eyes right now, it was so worth it. I'm going to cry, but later, after I sleep for a little bit, it was really great. And Julie, thank you for reaching out to all of us individually and pulling this team together, because you are the one that said, okay, COVID-19, we need to get ahead of this. What can we do to keep kids engaged? And then you started reaching out. None of us knew each other, and now we're a little family, dysfunctional family, but we're a
well, we're more functional than not.
Yes.
Yeah, I mean, this really set a precedent, and what's going to be crazy is after, you know, several of these are done, we're going to look back and be like, remember that first one? You know?
And all the mistakes that we made. I do want to share one more time. Remember that we have all the challenges, but one of our biggest challenges is this student host. As you can see by our bags under our eyes, we need some help. So students, hey everyone, this is Dr. Drizzle, and welcome to the Global Innovation Field Trip. We're having a lot of fun today, and we have some great hosts, but we're interested in finding some new student hosts for the next one in July. Are you ready? Do you think you can do that? All you have to do is find a topic that you're passionate about and speak on it for 1 to 2 minutes. You can interview a family member, a friend, or reach out to someone that's an expert in the field that you're talking about. We want you to film it horizontally and send it to globalinnovationfieldtrip@gmail.com. You just might be the next host on our field trip in July. Good luck.
And Daisha, can I make a comment about that?
Yes.
You know, we've joked for the last 24 hours about how we can have a student innovators take over for parts of this for us. And while it's true, it actually ends up being a little more work for us than just doing it ourselves. And that's not the real reason we're doing it. We're doing it because we see such articulate students. And this is just another opportunity we want to make for you. I mean, we can't invite you to a big gala. We can't invite you to a big competition or an expo, but we can take your skill set and help develop it even further so that when you're ready to make that pitch, no matter if it's a pitch about a robot contest or whether it's a pitch about an invention or whether it's a pitch about getting a job or getting engaged someday and doing it right, we want to be there, not there. We don't want to be there. We want to help you ahead of time. And this is one way to do it. We can offer you opportunities to improve communication skills, self-esteem, confidence. And so that's why we really want you to do it.
Exactly. We want to mentor you. We want to take you. And let me just say also, if there's any big companies out there that saw this and think, wow, can we help? The answer is yes. So if you can reach out to Julie at globalinnovationfieldtrip@gmail.com, we would be glad to partner with you if you want to help with your time or with your money. This cost us a little bit to put on, but it was all our own money that we used. And we would have loved to have gifts to give away to all of the presenters, but I have one Diet Dr. Pepper left and a few Tylenol. And that's absolutely it. But
in addition to funding or help, there's always technology. I mean, anybody who was with us the whole time realizes we had some technology issues that really weren't our issues, but they impacted us. So we're always looking for new ways to get out there and do these field trips 24 hours without being interrupted as much. So we'll keep doing it this way if that's what we need to do. It wasn't that huge a deal. People kept coming back when we got shut off a few different times. But you know, technology is another way you can help if you're an organization wanting to get involved.
Absolutely. And speaking of technology, we're going to get knocked off, I think, in just a few minutes. So last words, Jake?
No, it's a real honor and a privilege to be part of not only this group of the four of us, but of all the presenters. I frankly think of what we're doing is sort of like a dandelion, and I'm not making a reference to my gray hair, but the dandelion seeds blow in the wind and you never know where they're going to go, but they go someplace and they sprout and they create new inventions and new ideas. And that's what I think we've done today. We've taken the dandelion head, blown it, and there are dandelion seeds floating throughout the world, and we will see what happens.
I saw some. They were coming over my head. Again, guys, this was great. July 9th is our next date. We are ready, getting ready for that in a few days. So thanks so much. We love you guys. We feel like you're part of our family too. So
now let's all go to sleep.
Everyone's going to sleep right now. All right.
Bye, everybody.
Goodbye. Signing off.
Bye, everybody.
Friends.